be working the question, everybody. Have 10 minutes. You're looking at me. Have 9 more minutes. 9 more minutes. Not as small. Smallest I can make it. Right. That's it. Remember, the paper is in the group. So be the case now. It's 2021. So the papers in the group. You can't see so well on the screen. I can on the group. This is July. See it on top of the screen there, but you can't see. July 2023. 2021, sorry. Line up the next question I do want to do after this one from now. The next question 11. All right, go on to the first part of this. So then, and then major C's are the vectors. Question 11 took about 2 hours. Took a half an hour break. And we're moving on to question 10, which is trigonometry question. The circuit theory, the trees, the bearings, sine rule, cosine rule, all that. Cooper's is asked for circuit theory question already. All right, so.
It's Sammy. It's mommy. Do what? Do what? Like
Matthew, unmuted.
Finish? I have 2.5 minutes. This question is super easy. Super easy. The paper today already. 1 minute to go. Should finish this question in the exam already. This question don't need 10 minutes to finish. Remember, the last question on the paper should be 10 minutes each part. So 10 minutes for the vectors question, 10 minutes for the matrices question. They should spend more than 20 minutes total on the section 2 questions. 10 minutes on each part. Each part is a different question. So part A is matrices, transformation, part B is vectors. 10 minutes for each part, 20 minutes 4 times. All right, let me work it out. Time up. All right, so this first part right here. Gives us the vector OA is R, and they give us the vector here. Now they put the R here, but that R is for the entire vector. It's not the vector from here to here. All right, so if I'm in the exam, I'm stretching this out, but I don't want it to throw me off. Right, because it says here OA is R, so this R is for this entire vector. That's what I don't like about this setup of this question. Then OB is S, that's down here. The vectors at this level is just how you go from point to point. You know, that's all it is. How do you go around the diagram from point to point? The vectors are like roads that you have to go on. And sometimes you go the full length of the road, sometimes you go a part of the road, a fraction of the road, 2/3 of the road, 1/3 of the road, 3/4 of the road. Right? Roads are directions. So the R is a direction road, the S is another direction road. And you combine the roads to go from place to place in the diagram. Simple as that. Or you go around the diagram from place to place. The more you can populate the diagram with the fractions of the roads, the fractions of the lines, the more information you have to help you get around the diagram, to see how you get around the diagram. All right? Remember, when you know position vectors, then a displacement vector is just O times the last minus O times the first. So for example, if you know OA as we do here, and we know OB, then if you want to find the vector AB, it's easy. It becomes this one minus this one. It becomes OB minus OA, and you don't need the diagram that time when you know portion vectors. But if they ask for another displacement vector that you don't know the position vector, then you look at the diagram now and you see how you go around the diagram from point to point. Simple as that. All right? Now, sometimes with the questions, they will ask you stuff that you need something else to get it. You have to learn that, what do I need to get this information? Comes with practice. All right, let's look at it. So they tell us that OC is really 3/4 of OA. Right? And remember, OA is the vector R. This vector is R. And this right here is 3/4 of the entire thing. So it is 3/4 of R. Right? So it means then I'm going to change the diagram. I'm going to mark it out. And I would do this in an exam as well. Everything I do in the class is that I would do in an exam. I would scratch this out. I would scratch that out and put on my vector on the diagram. So there's no ambiguity. The vector from O to C is 3/4 of the entire thing. So it's 3/4 of R. So here to here is 3/4 of R. 3/4 of R. So this little piece is the remaining portion of R. Has to be 1/4. 3/4 and 1/4 make the whole R. So this little vector from C to A has to be 1/4 of R right here. This little piece is 1/4 of R. Then it tells us about the line AD. AD right here is 2/3 of the entire thing. 2/3 of AB. Again, I'm gonna put that on there. Just that I don't know what AB is yet. And they didn't ask me for AB. To write what this is, I need to write what AB is. And they give me information for me to find AB. So I'm going to work out AB even though they did not ask me for it, so that I can represent what my AB is in vector form. They don't give it to you for not to use it. Once I give it to you because you're going to expect to use it. They don't give you information for you not to use. So I know that I'm going to have to find the AB. And they're telling me that it is 2/3 of AB, but I don't know AB. It's not like in this one where I know the R already, the OA already. So I'm going to work out the AB, and AB is easy to work out because I have the position vector of A and the position vector of B. Once you have position vectors, you're good. So I'm going to work out what AB is right here. So the vector AB that I need for here is OB minus OA. Some teachers say is AO plus OB and then some switch around and all that thing. Nobody of them foolishness there, waste of time. Always O times the last minus O times the first. I don't know why they keep complicating the thing. When it is position vectors, it is O times the last, see there? B is the last, minus O times the first. A is the first. Remember that little statement. O times the last minus O times the first. O is a position vector. Look here, it don't have to be O, you know. It can be P times the last minus P times the first, you know. Because I can use P as a reference point, just the same. Any point, but normally O is your reference point. So I say O times the last minus O times the first. But it can be any point times the last minus any same point times the first. All right? So that is it. So this then becomes the OB is S. Sorry, S. Minus the OA is R. So it becomes S minus R. So that's what AB is. Now I like to underline my vector components. See, they write them in italic letters. I like to underline them. I underline them to separate them from a scalar quantity. But if this question entered or introduced a scalar quantity like a K, like suppose I said this side is K times the whole thing, then this K would be a scalar value, like a number, not a vector. So to differentiate it from my vectors, I underline my vectors to make it different from a scalar quantity. All right, so I now know this. Now, if I know this, I can just take this now and put it here for the AB, really. And then I know what AD is. So I can write it here somewhere. It means then that the AD that they gave me right here, that's this vector right here. I'm not going to bother put on the diagram because it's so much. Right? So I'm going to put on the diagram. But the AD right here now, because it is 2/3 of AB, is 2/3 of this. So 2/3 of this part minus 2/3 of the R part. 2/3 of R. That's what AD is. 2/3 of S minus 2/3 of R. So I have information for this. I have information for that. Right down here, no. It's going to be 1/3 of AB, you know, right down here. So if I want it. DB is going to be 1/3. This is 2/3. I'm right it up here. Right here is 2/3 of AB. Put on in it. Put on in it. From here to here is 2/3 of AB, which works out to be this. Down here, to complete the whole is 1/3. 2/3 and 1/3 make a whole. So down here is 1/3. Going from D down to B is 1/3. 1/3 of the entire length, AB. So I populate my diagram. If I want to write this, I can take this thing and put it for the A minus B if I need to use it, for the AB, if I need to use it. All right? So I put the information on the diagram. I know already, but they ask me for CD right now. So look at the diagram now. I don't know the portion vector of C. Well, I know the portion vector of C, yes, because I know it is this. What I don't have is a portion vector of D. Because I don't have the portion vector of the 2 points in this reference. I'm going to look at the diagram to see how I go from C to D. That's what I'm going to do. How do I go from C to D on the diagram? Going along the vector direction that I know. It is pretty obvious. Go up to A first using this vector. And then come down to D using this vector. Simple as that. So go C to A and then A to D. I'm going to write it out here. So look at the diagram. So go from C to D. I'm going to go C to A based on the diagram. And then, remember the plus in vectors means, and then I'm going to go A to D. And the AD is 2/3 of AB, so we know already work it out to be this vector over here. All right, let me move this. I want this on the next page. So this simply works out to the CA is 1/4 R. See there? I have it on the diagram. 1/4 R, 1/4 R. Plus AD, I worked it out already. It is this. And if I did not work it out yet, I would have put this expression for the AD, 2/3 AB, and then work out the AD. But sometimes you can foresee what you're gonna need in the question and do it first. Right? So I'm now adding this comma AD. This. This is now 2/3 S minus 2/3 R. Now, generally, you would say that this is correct enough. That's correct enough. We see the question say in simplest form. Simplest form means you're going to give one S component and one R component. So I need to put these two together, R component. Work them out as one fraction. If you want to use a calculator and do 1/4 minus 2/3, fine. But I can also recognize this one as 3/12. And this one as 8/12. How I know that? Because in my mind, I am multiplying this one by 3/3 to get the denominator become 12. And I'm multiplying this one by 4/4 to get the denominator become 12. So this numerator is 3 times 1. This numerator is 4 times 2, 8. That's 3 minus 8. That's -5/12. All right, so if you want to calculate and do the fractions, fine. But if CSEC don't give you no whole heap of space, you don't know whole heap of lines are writing to learn to do your work efficiently. So this vector then is simply equal to 2/3 S. Go back for the shoe. 2/3 S. And then this and this, I said it becomes minus 5/12 R. That's it. That's it. 2/3 S minus 5/12 R. That's the answer. All right. And I like to tell the students as well. Some you can check if the answer is correct, if the answer makes sense. All right. Let's check if the answer makes sense. So this is saying to go from C to D. I need to go 2/3 of a S. 2/3 of a S. Let's look at it. This is a whole S. This is a whole S. All of that is a whole S. 2/3 of it, if I divide it into 3 parts, would be this. This is about a 2/3 S, right? That is about a 2/3 S. Let me put it up here. So I'm going to use that 2/3 S. Start at D right there. So see there, so that 2/3 S is taking me out to this point. Sorry, it's taking me out to this point right now. Then I need to do a minus 5/12 R. That's almost a half R. But I need to subtract half R. So R here, so all of this is a R now. All that is a R. About half of a R will be about right here, so. This is about half of a R. This is about half of R. And I'm subtracting, meaning I'm coming back. Coming back. So if I take this now and put it at the end of that vector. If I take this and put it at the end of this vector, see, it's taking me to D. Remember, I didn't need a full half R. I didn't need a full half R. And I use a full half R. So maybe the 5/8 R will really stop at D for true. So I can accept that this answer is correct based on that. Now, suppose I made a mistake. Suppose I made a mistake with the character and put a plus right here. So, for example, a plus. Then I would know that this answer is wrong because that plus will be sending me that 5/8 R will be sending me further away from D up here. So I would know that this answer is incorrect down here. And that's why you can check your answer with the diagram. You don't have to physically do all of that. You know, just look at it and say, okay, 1/3 R and just map it out in your head. You say, yes, I can accept this answer as correct. All right, we need to do those things sometimes. Okay. All right, guys. So that was an easy question. Really, very easy. What is the one? The one OE. Same thing again. Look at, I'm going to change this. How about this minus this and don't leave it on the paper. I need to go from O to E. Look at the diagram again. How do I go from O to E? Remember, the question tell you that E is the midpoint. See there, E is the midpoint of CD, you know. So E is half of this. So basically, just work out CD now, you know. Right? And the CE is half of that. CD that we just worked out. So look at the diagram now. How do I go from O to E? Simple. I'm gonna come up to C here so first, using this vector, and then I'm gonna go to E right here. Where this vector taking me to E is half of the CD that we just worked out a while ago. So you're good to go. Just put in the numbers there, gone clear. It's not complicated. The diagram shows you how you go around the point. And you naturally try to go in the direction of the vector. Don't try to go in the opposite direction of the vector. When you have to go in the opposite direction of the vector, you have to introduce the negative. I have to introduce the negative correctly, because the opposite direction in vector, you introduce the negative for the opposite direction in vector. So that's how I'm going to go from O to E. And then you just do the maths on it. I'm going to O to C, and then I'm going to go C to E. And the CE is half of the CD. Simple. So I'm going to go from O to C first. See here, O to C first. And then plus, I'm going to go C to E. That's how I'm going to go from O to C, O to E. The OC, we have it already. It is 3/4 of R. We know it already. We have it already. So I'm going to put the 3/4 of R for this. Man, 3/4 of R. I'm only taking this now because I'm explaining it. Finish this in 2 minutes. Examine it. 3/4 of R. Plus CE is half of this. I don't have to write 2 lines, you know. I can just put a half of this right there. Let me put half of this to the side. May the examiner see. So see here, I'm going to put it to the side that the CE is half of the CD that we just worked out a while ago. See here, so this CE is half of that whole thing. Part of the road, half of the road between C and D. So this CE is half of CD. So I'm just gonna do half of these values. So all I'm have to do half those values and put it right here. So I don't have to put 2 lines. CSEC don't give a whole space to work with. And to be efficient. So half of this becomes a third. Everybody can see that. Half of this becomes a third. We multiply this by a half. You can see that 2 there, give me a third. So it's 1/3 S that. 1/3 S. And then half of this on the becomes 24. Come on, multiply this by a half. This on the becomes 24. So it's 5/24. So it's minus 5/24 R. See that? In simplest form means you don't want 2 components with R in it. So I need to consolidate those 2 and make it into 1 fraction with R. If you want to use a calculator, and put 3/4 plus 5/24 and get 1 fraction, no, not plus, minus, and get 1 fraction, fine. But this 4 can become 24 if I multiply by 6. So in my mind, I'm multiplying this by 6/6, but the denominator become 24, like that one. And this 6 is at 18. So I'm really doing 18 minus 5, 13. You don't have to do them, you can do those things in the mind quickly. Don't need no calculator for that. But this denominator become 24, and it multiply by 6. So I need to also multiply this 3 by 6. So this fraction is going to become 18/24. 18 minus 5 is 13. So it's 13/24 R. So the answer for this one is 1/3 S, and the only S term there, plus 13/24R. That is the answer. Everybody good? Everybody okay with that? Online, you okay? Online?
Yes, sir.
All right, beautiful. Next part, no. All right. This question no easy like cheese. This question gives you this diagram, right? And you can see the points on it. So you automatically know that this vector has the same values as the coordinates of that point R. What are the coordinates of the point R? It is -1, 4. It means that OR is the vector -1, 4. No? If the point R is -1, 4, -1, 4, then the position vector will have the same values in the column vector format, -1, 4. And this point out here is what? This point out here is 5, 2. So if Q is a point 5, 2, then OQ, the vector from O to Q, will have the same values, 5, 2. Or maybe I don't need all of this, but I'm just doing it to show you, in case you need them. The question said, we must write down the vector OR. So it asks for this one. See, it asks for this one, this one. So since the point is -1, 4, then the vector is -1, 4 in the column vector format. Let me write it down. R is -1, 4. So OR have the same values, -1, 4. Position vectors. 1 point for that. 1 mark for that. Don't you know, say they want the modulus of QR, this thing. This thing means how long is the vector QR? How long is that line QR? That's what this means in the modulus, the length of it. You can do it by calculating QR and then calculate the modulus. But I always say when you have the diagram, especially anything with diagram, coordinate geometry diagram, Cartesian coordinate, you can count off the units on the diagram rather than calculate it. It's easier to count than to calculate. So because they give me the diagram, this means modulus means length. I want the length of the line QR. The length of the line QR. So QR here, this is the length of the line QR. Let me take these off. I'm gonna do it the easy way. I'm not gonna calculate it. Maybe next, I do another question, I'll calculate. I don't make no sense, I do it harder than it should. Don't like to do mathematics harder than an info. So I want to find the length of this line right now. Find the length of that line. I'm going to find the horizontal and the vertical components of that line. I use Pythagoras' theorem. What's the distance out to here? Count it off. And the distance up here. Count it off. Count off the units. Now look at the scale. If you notice the scale, that's the problem with this now. Look at the scale. Right? So this is not 1 unit. This is not 1 unit horizontally. This is 1 unit horizontally. So if I'm counting out the units horizontally, look at it now. It's 1, 2, 3, 4, 5, 6. Or you can say from -1 up to 5 must be 6 units. So that is 6 units. So horizontal piece is 6. So this right here so is 6 units long. Then vertically now, same thing. Every 2 line is 1. So up here so it's really 1, 2. See there? Up here so it's 2. Pythagoras theorem tell me that the length of this line is the square root of this squared plus that squared. Pythagoras theorem. There you go. Mathematics too easy. It's too easy. The modulus of QR is the length of this line, which is the square root of 6 squared plus 2 squared. That is it. This is 36, and this is 4. 36 and 4 is 40. That is the square root of 40 units, is the answer right there. Copy this down and put on the next page. Square root of 40 units. This equals square root of 40 And I have to say units because it's length. Important jump, the unit of measure is length. Unit of length is units. All right, so you're gonna say units. I want to say C diagram for my calculation. C diagram. You can do that in an exam too. Diagrams are part of your answer. C diagram for me get it. C diagram. See the diagram for I got it. I draw on the diagram I'm get it. Then I put down my length, them and so on. You want to see the other way to do it calculation wise just in case? Let me do it the other way. Yeah, somebody said this. More maths equals better maths. Good. So to do it the other way, we're going to calculate the vector. So may I do it in the examiner? I tell you now. I'm going to do it the other way to show you. So to calculate the modulus, I will calculate the vector QR first. Now remember that OR was what again? So it's minus 1, 4, right? Minus 1, 4. Minus. And OQ was what? 5, 2, don't you?
Negative. That 5, 2, 5, 2.
5, 2. Good. So those are the two vectors, right? What I give it that? So if I'm going to calculate the vector QR, it's going to be OR minus OQ. O times the last minus O times the first. So it's this one minus this one. Somebody mute the mic, please. And I don't have to work that out, guys. If I'm doing this minus this, I cannot subtract the values. Minus 1 minus 5 becomes a negative 6. And then 4 minus 2 becomes 2. What this means, you know, is that to go from Q to R, I have to go 6 to the left and 2 up. The vector is like a translation vector, you know, like translation. This means to go from Q to R, I have to go 6 units to the left. The left is because of the minus. And 2 units up. And that is what we saw on the diagram. See here? To go from Q to R, the calculation is saying go 6 to the left this way. To here, and then 2 up. That's where you go from Q to R. So the diagram and the calculation, they are consistent with one another. All right? So the calculation and the diagram match. And then now to use the formula method for vectors to calculate this modulus. The modulus of a vector is the square root of this value squared plus that value squared. Because this value represents a horizontal distance and this value represents a vertical distance to take you from here to here. So the dimensions are in the vector as well. All right? So calculation-wise, I would put minus 6 squared plus 2 squared. Minus 6 squared is still 36. 2 squared is still 4. The answer is still the square root of 40 units. But why do all of this work? We can just count off the dimensions of you on the graph. But good. All right, which one next? So I'm gonna spend. I try to do them fast. I've spent too much time. I was now about to 10 hours. I lie. There's a question I want to do today, which we don't need 2 hours on that topic. That is the pattern question. I think that is number 6 and number 7. I would be working on the number 6. We don't need 2 hours on that. So okay, I'll make up some time on that. Which question next? Which question next? You're getting 10 minutes to do it. Come on, come on. Tell it to me. Tell it to me. Which question next? Nobody have any question? No question 10. I don't put that question a while ago on question 10. No come prepared for this session. Online, anybody have any question 10 or 11 that I want to do? Matrices, transformation, vectors.
Matrices, sir.
Yes, tell me the question. Oh, you know, say, una joker.
Yeah.
Last week, say, you must bring on the question then. Huh? Madam, you must tell me which year question I'm going to do. Me, for the whole year, I've been choosing which question we're doing. You know, send me message to sir, I have a problem with that topic, I have a problem with this, I have a problem with that. You know, send me individual, I said, I have a problem with this. So I've said, bring the question today that is giving you problems. Bring the question today that is giving you a problem, explain it. That's what I said. I'm about to come empty handed.
Sir, 2022 matrices question 10.
All right, thank you, darling. Thank you. Find all of them where you want. You call them one in us are jokers. Them think them good, because them get P90s in the mock exam them. So them think them good. 2020, 2022.
2022, see, May, June.
June. June.
Wait, let me check. I have the thing open here.
Remember, I'm not giving you 10 minutes to do it first. That's how it is today.
Yes, sir, it's June.
All right, June 2. You guys watch me solving questions. Hey, about 1 million questions on my cell phone. I lie. About 1 million questions on my cell phone, you know. 24 exam papers. Plus all them classwork. Huh? But just on my cell phone, I still want to solve more again. Just stop solve questions. Your time now. Your time now, man. This one you want? This one, right?
Yes, sir. It goes.
All right, this one. All right, let me bring it up again. All right, so you
Yeah,
want this
that one.
question? All right. All right, I'm giving it 10 minutes to do it. Jordan, get cracking. 2022. I'm the American. Tired. Oh shit. So I'll be over soon. I kill on this week, you know. You're gonna get to it. I kill on this week coming in and I get to it. Right onto the wire. I'm gonna kill you guys with work. More maths equals better maths. All right, so this is the first part, and this is the second part. So hope you can all see it. The second part is over here. So the part A and a part B. Bring up the part, hold on. Start. Start. 10 minutes to do that, come on. We don't need 10 minutes to do that, man. Can that in less than 10 minutes. Chop it up 5. Don't need 10 minutes to do that this time. Come on. It's a 2022 paper. We can't sit on the screen. Just go in the group for the paper. In the group. It's super easy. I shouldn't give it 10 minutes to do this enough. You don't need 10 minutes to do this first. Serious. I think I'll stop it at 8 minutes. Huh? Huh? You don't remember this song? Never have made to see. Never have made to see that. Oh, when you're gonna do that. Now, some videos are good. And send to you. But you have to know the time send me want to me. Can send me some videos. Put in a lot of work in that's hard. I have to put in a lot of work. This scary so why not doing question? Huh? Looking at it is not doing it. 5 minutes. So I got the session after and go to sleep. Go to sleep. Like I wish the exam was Monday. Like I wish the exam was Monday. Like you all wish the exam was on Monday. So I'm getting over with and done. Exam out is honestly. Worse. About soccer. Capital T. You put the extra T on soccer account. No, each month. I think there's a greater demand for the greater demand for maths. I teach maths and not a course. I have physics, I know how them other subjects. It's a greater demand for maths, so I teach maths. They can teach all those other subjects as well. I'm gonna stop this out when 2 minutes to go here. I discussed that don't need that length of time, believe me. I'm gonna stop this when 2 minutes to go. You should have this. Yeah, you should have the first one asking for a point. You have to give a point, coordinates. If you ask for coordinates, you have to give coordinates. All right, 26 seconds to go. Come line up the next question you want me to do. January 2024, question. Still upon question 10, my boss. We need question 9 yet. We are question thing till 11 o'clock. We are question 6 later this evening. We're focusing on one topic at a time. Yeah, do you hear for accounts class? Eh? Oh, you go accounts class, it's gonna be recorded. It's gonna be rough. Based on at this rate, you might reach there before because nobody now put on a question. Hold on. Hold on. Let us finish this first. All right, ready. Let's do this. All right, let's do this one. Now, this question actually helped you by giving you some matrices that you should know. You should already know these matrices and what transformation they represent on sight. Because not every question is going to give it to you and ask you what transformation it is. And in fact, this question tests your knowledge of matrices, of matrix. Because when you calculate the matrix T, it is asking you to describe it. So it shows that even though they give you these two for free, you still need to know all of them. And you don't know which one you're going to get on the exam paper. So I gave you these matrices from about October last year. If you still don't know them by now, I've done my part. But this matrix is an anti-clockwise 90-degree rotation matrix. Anti-clockwise 90-degree rotation about the origin and site. Remember, an anti-clockwise rotation is also a positive rotation. And a clockwise rotation, remember, is a negative rotation. All right? And then this one, they're helping you, is reflection in line y equals minus x. That's the matrix for reflected in line y equals minus x. They give it to you, not every question I'm going to tell you what it is. You need to know all of them. So I'm going to write them out in a minute. I'll write them out for you. All the matrices that you're supposed to know on sight. All right. Question says, write the coordinates of P prime. Write the coordinates of P prime. Coordinates must be written like this with x and y values. Once the question asks for coordinates, that's how your answer must look. Coordinates. X value and a y value in bracket like that. That's what coordinates mean. If I ask for a position vector, your answer going to look like this. If I ask for a position vector, note the difference. So if you want to calculate a position vector, well, write the answer, we have to give it like that one. Remember, in transformation, we use a column vector for our calculations because we want to make the transformation calculations conformable. We want to make the matrices conformable. So if we're working on a point, for example, 3, 6, we use a vector, the column vector, 3, 6, to do the calculations. Right? Because we can multiply this with a 2 by 2. It is non-conformable. That's why we work it this way. All right? We use the position vector of the point to do the calculation. All right. So ready now. So we want the image, we want to write the coordinates of P prime, the image of this point after undergoing this rotation, which is this one. To do that, you apply the rotation matrix to the point. You multiply the matrix by the point, by the vector of the point. That's what the calculation goes. Right? So if I want to set up for you, you can say P prime is equal to the matrix. I said they don't give a lot of space to work. Is equal to the matrix 0 minus 1, 1, 0 times the point, the vector for the point, which is 7, 11. So that's the multiplication we're doing. And we all know how to multiply a 2 by 2 by a column matrix. Let's remind us of it. Right? You multiply the rows of the first matrix by the one column to get the 2 values inside here. This first value, because it is positioned in the first row and the one column, you get that value by multiplying this row by this column. You multiply them first element times first element, second element times second element. First element times first element, second element times second element. 0 times 7 and negative 1 times 11. Clearly, the 0 times 7 is 0 and the negative 1 times 11 is negative 11. So the value right here is negative 11. Then the value down here is positioned in the second row and the one column. So to get it to multiply this second row by this one column. First element in the row by the first element in the column. second element in the row by the second element in the column. And so it will be 1 times 7, which is 7, and 0 times 11, which is 0. So 1 times 7 is 7. So that's a position vector of the point P prime. But the question asks for coordinates. So this is not the answer. If you leave that as the answer, you might not get the mark. You have to write coordinates, please. You're gonna say P prime is minus 11, 7. Use this for the calculation, but this is the answer for ask for coordinates. That's the answer. Nice and easy. Next part. Question said, T is a combined transformation A followed by B. You must know by now that to get A followed by B, get a single matrix for A followed by B, you calculate the matrix B times A. The second one times the first one. A followed by B is obtained by multiplying B times A. P followed by Q is Q times P. M followed by N is N times N. You multiply the second one by the first one. And this multiplication only happens when the two transformations are 2 by 2 transformation matrices. It can only work with the 2 by 2 transformation matrices. It cannot work with the translation matrix, which is a column matrix. So you can only get a single transformation matrix when you have two transformations, one followed by the next. You multiply the second one by the first one. What we say is that we apply the A to the B. Because the B comes after the A. So you apply the B to the A. Apply the B to the A. That's what we're doing here. We get a single matrix. So we can basically, the matrix T is B times A. So this question is forcing us to multiply these two matrices. The second one, which is this, times the first one. If you put them the wrong way around, you're going to get a wrong answer. Because matrices multiplication is non-commutative. If you multiply them the wrong way around, you get the wrong answer. All right? So you have to multiply them in the right order. So this is the 0 minus 1 minus 1, 0. That's the y equal minus x reflection times 0 minus 1, 1, 0. That's the rotation matrix. So that is the B times the A. T is equal to the last, the second one times the first one. All right? Let me make this a little bit smaller and do the calculation for you. Then now remember, you multiply the matrices the same way. You're gonna get a 2 by 2 matrix in the answer with 4 values. Using the rows of the first matrix times the columns of the second matrix. So this first value is positioned in the first row and the first column. So to get it to multiply this first row by this first column, first row, first column. And we multiply them, first element in the row times the first element in the column, second element in the row by the second element in the column. So it's first element times first element, second element times second element. That's 0 times 0, which is 0. Negative 1 times 1 is negative 1. So the value here is negative 1. Then this value is going to become 0. Something I can know the answer already. You know. That's going to become a 0, and a 1. You can know the answer because the ones are always on the same diagonal. And it has to be a positive 1. But anyway, let me not get into explaining that too much for now. So we need this value here now. That is positioned in the first row and the second column. So to get it to multiply this first row by this second column. Right? And we go. First element times first element. Second element times second element. First element times first element. Second element times second element. 0 times negative 1. And negative 1 times 0. So you see that this is going to be 0. Then we'll come to this value here. This position in the second row and the first column. So to get it, we're using this second row with this first column. First element times first element is 0. Second element times second element is 0. So this value here is 0. Then the last value out here is positioned in the second row and the second column. So to get it, multiply this second row by this second column. First element times first element, second element times second element. First element times first element, second element times second element. -1 times -1 is a positive 1. 0 times 0 is 0. So this becomes a positive 1. That's the answer. And you must know what this transformation is on site. That is the y-axis reflection matrix. Reflection in the y-axis. And I ask us to describe it down. You see there? Describe it. 2 marks to describe it, you know. Easiest 2 marks ever. I just knowing that matrix. Why go in the exam and not just know the matrices? We can get 2 marks, we just know the matrix and describe it like that. Make other people figure it out. You don't need to go in the exam to figure out stuff that you can know. The more things you know, the better. And it makes sense to know the things that they will always be asking in an exam room. So this is a reflection in the y-axis. A reflection in the y-axis. That is it. Reflection must have a mirror line. See there, that's a mirror line. And sight. Then we come to this part over here, which is now matrices. So this part tells us that this matrix C, the scalar quantity K right here, determine the value of K if C is singular. But must know what singular means. Singular means that the matrix has no inverse. Has no inverse. So instead of telling that it is singular, I could have said it has no inverse, you know. Has no inverse. Instead of using the word singular to your question, could have said, given that C has no inverse, means the same thing. It is singular. And when it is singular, the determinant of C is equal to 0. And when the determinant is equal to 0, the first diagonal product is equal to the second diagonal product. Remember, to get the determinant, you are subtracting them. So the determinant is 0, it means that 2 diagonal products are the same. So therefore means that this product, which is 3 times 4, using the determinant equals 0 now. It means that the 3 times 4, which is 12, is equal to the 6 times K over here. So. And if this is 12 and this is 6 times K, 6 times 2 is 12. It means that the K is equal to 2. That's the answer, right? Better good? Better good at that? Yeah. All right. Which question are we doing next? Which question are we doing next? Matrices. Any question from any question 10? You got a question 10? Which question is it? 21?
Oh no, sir. I wanted to do the seedbed question for last year.
You want to do which one?
The seedbed question from last year, sir.
What question number? Or the seedbed question? Oh, seedbed question.
Sir,
yes, sir.
That is weird on a question. That is weird on a question 2. We're doing that tomorrow. Question 2 or 3. That we're doing that we're doing those topics tomorrow.
Sir, I have a question.
Hold on. Somebody asked a question 2019. Hold on, 2019. 2019. Where are you? Oh, all right. You're sending the females in there. All right.
Sir.
Yes.
I was wondering, like, can you explain like collinearity? like before you start or after?
Find a question with it. Find a
Okay,
question with it.
okay.
Find a question with it. And I explain it. Very easy. Don't worry about it. It's very easy. All right. 2019. Very easy. There's an coordinate on this one. Find a question and a password where you can use it. Now, which question you say one? Question 10. This part up here, sir? Well, you have A. This one, the matrices method. All right, that's all. Okay. You don't need more than 5 minutes for this. You put up a clock. Everybody, 5 minutes. Somebody just want this alone. 5 minutes. Don't mean use a matrices method to solve this question. 5 minutes. Everybody, 5 minutes. Come on. Don't need more than 5 minutes for that one. Not even 5 you don't need. Less than 5. What does this alone? 3 minutes. All right, go on. 5 minutes. Come on. Search for your vectors question, mom. Search for your collinear points question. And it was one on last year. 24, 24, and 2021. Collinear points. Collinear points. Somebody wants a collinear points question. So there's a collinear points question on 2020. I do that one afterwards. January 2020. You know, nice collinear points question on that one. I do that one afterwards. All right, after this one. Everybody finished? Yeah. By the way, I'm going to write out the matrices that you are supposed to know. You have them? You have them? You don't have them?
Like, all right, then.
All right, I'll write them out for you. Just. I'll write them out before I do this question. The matrices that you should know in your head and sight. Write them out first. You know, screenshot it and then we do. All right, the matrices that you are supposed to know. On sight. The first one is a y-axis reflection matrix. Reflection matrices. -1, 0, 0, 1. So reflecting in the y-axis. Then for the x-axis, the -1 comes down here. 1, 0, 0, -1. That's reflecting in the x-axis. Then the y equals x. Reflecting line y equals x is 0, 1, 1, 0. Y equals x. Reflecting line y equals x. These are the lines. These are the mirror lines. Then the y equals -x, not hard to know. Because this is that one. Then you put 2 minus on this to get the y equal -x. So it becomes 0, -1, -1, 0. That's y equals -x reflection. Those are the 4 reflection matrices you need to know. Reflecting in those 4 lines. Then we have the rotation matrices. Let's put them here. Rotation. And rotation is about the origin. The center of rotation is the origin for these. Rotation. Rotation. About the origin. First one is the anti-clockwise. So we draw the arrow like that. Anti-clockwise 90-degree rotation matrix. So we draw the arrow like that. That reminds me that the -1 is up here for the anti-clockwise rotation matrix. 90 degrees about the origin. So -1 up here, 1 down here, 0, 0. That's anti-clockwise 90 degrees. 90 degrees anti-clockwise. That's a positive rotation. Anti-clockwise 90 degrees. Anti-clockwise. Anti-clockwise. Anti-clockwise 90 degrees about the origin. See, it's about the origin. So for the clockwise, naturally the -1 comes down here. This is the clockwise. That's a -90 degrees. Remember, clockwise rotation is negative. This is the clockwise 90 degrees. Then you have the 180-degree rotation about the origin. You're basically combining these 2 transformations to get that. Because the 180-degree rotation is equivalent to reflecting over the y-axis and then reflecting over the x-axis. So you combine those 2 to get it. It has the 2 -1s in it here. -1, 0, 0, -1. That's a 180-degree rotation about the origins. Clockwise or anti-clockwise is the same. Because a 180-degree rotation is the same result, whether you rotate clockwise or anti-clockwise. So that's a 180-degree rotation about the origin. Same as reflecting through the origin. They can treat the origin as a point, same as reflecting through the origin. So these are reflection in lines, If we're going to reflect to the origin a point, right here. If we reflect to the origin, which is a point, you get in the same matrix. -1, 0, 0, 1. So a reflection to the origin and a 180 rotation is the same. Same matrix. Same matrix. So those are your reflection and rotation. But no translation already, the column vector matrix, right? Translation. Right? So translation matrix is always a column vector matrix. So translation is like AB, where A is how many units left or right. Remember, I'm put it this way. Positive over here, so negative over here, so that is the A. All right? And then the B is how many units up or down. The B is up or down. We go up, positive. If you go down, the negative. That's the B. That's translation. Then we have enlargement about the origin. Enlargement about the origin. Only the enlargement about the origin has a matrix. Enlargement about the origin, meaning the origin is the center of the enlargement with a scale factor of K. Enlargement transformation. Enlargement. About the origin, meaning the origin is the center of the enlargement. The matrix is K0, 0K. K is the scale factor. Scale factor is K and the origin is the center. Scale factor is K. That matrix works very, very easy. It takes a point, XY, and it maps it to a point, K times X, K times Y. When it's a reflection about the origin, that's what it does. So for example, if you have a point 2, 3, and you map it to that scale factor of K equals 2, it's gonna go to 4, 6. Just like that. But the scale factor can also be a fraction, can also be negative. But all they do when the enlargement about the origin matrix is this, here's the scale factor. It maps a point by just multiplying the coordinates by the scale factor to get the image point. And there's one important thing about enlargement that you must remember as well. And it is this. Enlargement, scale factor in an enlargement affects the size of the object, but also affects the distance of the object from the center of enlargement. For example, if the scale factor is 2, the size on the object is going to be twice what they were before. So the image is going to be twice as large. But additionally, the distance from the center of the enlargement is also going to be multiplied by 2. So the scale factor does not only affect the object itself, it also affects the distance from the center of enlargement. All right? And then another thing to remember about enlargement is that when it comes to length, length of an image is the scale factor times the length on the object. Length, L means length, L means length. This is for length. Length on the object, this is for length. For area, area on the image is K squared times the area on the object. I can remember that for enlargement. Plenty of people made the mistake and apply the scale factor to the area as well. You have to apply the scale factor squared. Can't bother going to explaining it now, but that is what it is. We reach a stage now. We don't have an explanation for this by now. If we go to the exam, just arm with the knowledge of it. And this is now when it is area. area. Oftentimes, CSEC will ask a question, for example, they give you an enlargement question, and ask you a question like, what is the area of the image over the area of the object? Like, for example, they might say, okay, suppose the thing was ABC. They might say, what is the area of A prime, B prime, C prime over the area of A, B, C? That's the area of the image. That's the image over, that's the area of the image. That's the area of the image over the area of the object. If you look at this formula, but take the area of the object and divide it on the area and get this ratio. That is always equal to the scale factor squared. Scale factor squared. The ratio of the image area to the object area is equal to the scale factor squared for enlargement. More things you know, the better. You don't have to go in the exam to figure out stuff when you know things. All right, so those are the things I would want you to remember for transformation, and these are the matrices. So I give you reflection, rotation, translation, enlargement. That's it. All righty, not a lot of matrices to know. You must know those matrices on site. So they give you a matrix. For example, they give you a matrix. Half, 0, 0, half. This is in the K position. This is in the K position. So that's an enlargement matrix of scale factor half about the origin. This one. They put -3 and -3. That's an enlargement of scale factor -3 about the origin. And you have to say about the origin. I can say with the center of the origin or something like that. All righty? Very good. Can you erase this now? One last chance.
Sir.
All right, beautiful. All right, let's do this question now. This is use a matrix method. Solve this simultaneous equation. I only need to see it done once. Don't need 10 of them. All of them done the same way. You don't need to see 10 of them done. You just need to see one of them done. All that will be different with other questions are the values. The process is the same for all of them. First, you have to write the matrices equation. And some questions will ask you to write the matrices equation. This one did not ask you to write it, but you still have to write the matrices equation. Convert this into a matrices equation first. So you always check, but they always give it that way. You have the x value first and the y value second in the first equation, x value first, y value second in the second equation, and they have a constant term on the right side. They must always have it set out like that. But they always give it like that. But if CSEC change their mind and give it to you another way, you have to transpose it, make it look like this. X value, y value constant. X value, y value constant. Make sure. Then you get a 2 by 2 matrix. This becomes a 2 by 2 matrix times a column matrix XY. That's how we need the x followed by a y. So we can write this column matrix XY like that. That equal to a column matrix with those values, the 5 and the 13. Then the values that coming in here are the coefficients of the x and y from up there. Those are what coming in here. The coefficients, meaning the number in front, the x and the y, in the same order that they appear. So this is a 2 and a 3. So that's 2 plus 3, 2 and 3, 2 and 3. If this was a minus, then this will be a -3. Simple as that. Then this is a -5, and there's no number in front this y, so it's a 1. You don't go put in a y down there. You put in a coefficient. So when there's no number in front, it's a 1. And if this was a -y, it would be a -1. You can only put values inside here. coefficients are numbers going inside here. So when there's no number in front, the variable is a 1. So this is a 1. This is a 1 in front, that y. And then it's a -5 right here. That's the first step. Then you want to make this a subject. Matrices transposition says that this, the inverse of this is going to come in front here. Can't bother go over explaining why that is so now. But that's how it is. When you transpose a matrix from this side of a matrices equation, if it is in front, you put it back in front on the next side. Because matrices multiplication is non-commutative. I put in the inverse over there to leave this as a subject. Simple as that. Watch this. If you had a matrices equation, AB, and this is on the syllabus. If you have matrices equation AB equals C, like, I'm put some numbers on it. So let's say our matrices, I'm going to do 2 by 2. Let's say our matrices equation, and this is the unknown, X, put A, B, C, D. A, B, C, D. And you have 1, 5, minus 3, 2 equals put 0, 5, 8, -1, for example. And this is what I'm trying to find. I have to transpose away this. Since this is second on the right side, I have to put the inverse of it second over on that side. So to do this transposition, I would have to take this, transpose it over to the second part of this, and it is the inverse that I would have to put there. So this now be equal to that calculation. The inverse, I put the -1 on it. The inverse of this matrix I need right there. Right? This is what they normally give. 99%, 99.9% of the time, they give you this format where this is the matrix you have to move, the one that is in front. So the inverse goes to the front. So if it is on the front on the left side, the inverse goes to the front on the right side. If it is second on the left side, the inverse goes second on the right side. Very important. So I'll give you one setup like the one that I just gave you a while ago. This was here. And as you're moving, because it is the second matrix of that multiple, the inverse would have to go second over here, not in front. Second. Inverse would have to go over there. To the -1. But understand that. Now, this is on the syllabus, on the specimen paper. I don't see them set it on in the exam paper, but I'm exposing it to it just in case. And then now, to work out the A, the B, and the C right here now, in this one. To work out the A, the B, and the C right here. You have to calculate this inverse here so first. In the normal way. And then complete this multiplication. You see what the A, the B, and the C. If they give you one like that. I don't know if I'm going to give you a stick. I never did before. So, what's on the specimen paper? That's a funny thing about it. So, back to this now, guys. So, I was saying now, I want to leave this as a subject, so I need to transpose this away. They put in the inverse in front here. Right? And that's why I'm going to get into why that is so. But just know, so that's how it can put it. So, it means then, teacher, now, let me set up for you. The xy that we want here to be the subject is equal to the inverse of this in front. See here, I'm going to write it. 2, 3, minus 5, 1. I'm going to put the -1 on it in red so you can see it. That's the inverse of this coming here. And then multiply that now by this. 530. See? So this matrix, the inverse of it goes in front on this side. So have to work out this inverse. We have to work it out. We have to work out what that inverse is. The inverse now is 1 over the determinant multiplied by the adjunct. the inverse of this matrix now. You see it here now? So this xy becomes equal to, I'm doing the inverse of this now, is 1 over the determinant. The determinant is always the first diagonal product minus the second diagonal product. The first diagonal product right now is just 2 times 1 is 2. Minus this second diagonal product is negative 15. And here you have to be careful. It is a minus negative 15. We understand that we are subtracting a negative 15. I can put it in a bracket, I can leave off the bracket. But this minus actually becomes a plus. This minus is really a plus right there. And then you're multiplying that now by the adjoint of this matrix. We form the adjoint. You interchange the elements on the first diagonal. Switch them around. The 1 goes here, the 2 goes there. Leave these 2 elements where they are. Don't switch them around. But you change the sign of each of them. So you change the sign of this 3 in the same position, becomes a negative 3. Change the sign of this negative 5 becomes a 5. This right here is simply this inverse. Underline it in red for you. All I've done so far is the inverse. I need to multiply that back by the 513 out here. So you put it back to 513. But it goes so far. And I always say, when you're doing this calculation, this time is a work out to 17 now. Remember that becomes a plus. Do this calculation with the whole numbers first. And leave the 1 over 17 for last. Do the calculation with those numbers. I'm going to write back the 1 over 17 first. I'm going to put the matrix where I'm going to now multiply these 2 inside here. And multiply those 2 matrices the same way how you always do them. Use purple this time. It's going to give you 2 values. The first value here is positioned in the first row of the final matrix and the 1 column. So to get it, we're using this first row with this 1 column. So you always multiply the rows of the first matrix with the 1 column. So to get this first value, I am using this row with this 1 column. You multiply them the same way again. First element times first element, second element times second element. First element in the row that you're using times the first element in the column, plus the second element in the row times the second element in the column. So it's 1 times 5 and minus 3 times 30. 1 times 5 is 5. The minus 3 times 13 is negative 39. Negative 39. Then the value that we want down is positioned in the second row with the 1 column. So to get it to multiply in this second row with this 1 column. Same way again. First element in the row times the first element in the column. Second element in the row by the second element in the column. So it's first element times first element. Second element times second element. 5 times 5 and 2 times 13. The 5 times 5 is 25. And the 2 times 13 is 26. And see, these come out to be nice multiples of that 17. So you know you're on the right track. That's what normally happens. Now, all the time, we get fractions sometimes. Most time we get nice multiples inside here. Right? So this ought now to be equal to 1 over 17 times. This is negative 34. And this is 51. So dividing each of these now by the 17. So negative 34 divided by 17 is negative 2. And 51 divided by 17 is 3. That's XY. Now, this is not your answer. Your answer is when you state explicitly what the X is and what the Y is. So don't leave this as your answer. You're solving the simultaneous equations Your answer is to state what the X value is and what the Y value is. So don't leave this matrix and say that this is the answer. But once you get to here, it means that your X is -2 and your Y is 3. So you have to state that X equals -2, Y equals 3. That is the answer. This is the only answer. But I got it that. All right, mom. You don't need to say no more though. Them do the same way. Just the values will be different. Set up the matrix. You just have a transpose the inverse in front and the right side. Calculate the inverse is the normal way. 1 over the determinant times the adjoint. Leave the fraction 1 over the determinant. Leave that for last. Do the calculation with the numbers first. And then make sure that you state explicitly the value of the X and the value of the Y. But good? But all right, online?
Yes, sir.
Yes,
All
sir.
right. Beautiful. So somebody asked for a collinear points question. What time is it now? Start about half hour later now. Don't rush. It's 5 minutes to 11 now. So the first break at 11. I'm taking some half an hour breaks in between. So it's 2 hours, half an hour break. 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 That's what we plan out to do. But we can catch it up with, I think, the question 7. And the question 8, no, the question 8, it says 10, 9, 8, 10, 9. Question 7, we don't spend 2 hours for the question 8. So we can catch by the time of the question 8. So I'm going to do one more question, which is a collinear points question, this segment, and then we'll take a break. And then we'll start back with another question. All right? So in the break, find the questions on the one to explain. The question on do so far, and the gut feeling tells them I really fully understand. But do it, you know, I'm kind of get it right in about something missing. You know, you have some questions like that. You just feel like, you know, fully grasp this thing. Something just missing. There's something about it where you feel like if CSEC changes question, you're going to have problems. Yeah, find the question and we'll just take one last shot at explaining it. And if our exams are around the corner, I just feel like you listen a little bit more keenly now. All right, so let's bring up the, I think I said 2020, there's a collinear points question on 2020. So let's bring that up for the young lady. And for everybody, let's do it. All right, and then we take the break after this. All right, I'm giving a half an hour break. So foodie, get your food within half an hour. Don't want to eat in during the time. You're foodie. Foodie. Mr. Malik Mills, I'm putting it online with everybody here. Yes, I'll send this video to your mom and your dad. So anything you're doing, do it within half an hour. Please, we have about 4 half-hour breaks during the day in between the doing other questions. Is this because I must say, oh, it's January 2020, we say, right? January 2020. January 20, oh wait then. Yeah. See here somewhere, see it here, so. All right, I'm gonna put this up on the screen, guys. All right. And you do it, giving you 10 minutes to do it. Collinear points question. Here we can. Now I drop my kitchen and return. Yeah, this thing can go up a Calabar. Yeah, this thing can go straight up a Calabar. We'll get it. So all that. Yeah, you get it, master. So all that in a sir. All them barking that they did that mean. All right. All them barking did that mean. All that grade 1, sir. So I'll tell them now. So in the break, guys, search for your question 9 that you want me to do. We're moving on to section question 9, which is the bearings, trigonometry, circular measures, and so on. All right? Circular measures. Remember, a lot of these things just you taking time to learn the rules. There's rules beaten out a lot of you. Don't take time to learn the rules like with the circular measures. You're just not fair to yourself. All right, so this question does have these three parts, right? Sit here. Come on, 10 minutes. And then the last part is to show that, write it out down here. Oh, it have another part down there. So. See the collinear here. See the collinear here, ma'am. Collinear, this one. Last part down here asking for collinear points. So I'm gonna do this for you one time. And all of them do the same way. All right? So I'm gonna work out this one for you. All right, see the questions on the screen there now. 10 minutes. Let me bring up the clock. 10 minutes. Right in there, put in the clock. 10 minutes, everybody, start. There's a question. Everything is there. Nice vectors question, this one. You get a vector question like this on exam, supposed to smile and be happy, you know. Supposed to smile and be happy. Because this is a standard question. There's no little sugar on it. Just normal. Go on, 10 minutes. 10 minutes, everybody. Get it, do it. Do it. Go at it. Go at it. Food it. Yeah. Yes, that's just when the general group, the can't send them on the streets or well, can in the group. I'm gonna zoom it up. All right, the QM, the second part, the QM, and then zoom up to it. So this second part of this is QM. So also find in part B the vector QM. QM. That's better. All right, and then you can see this over here, all right? You wrap these points are falling here, this part over here. So that is it. Put the clock forward to the right. All right, there you go. That's what they're doing. Come on, 10 minutes. I'm gonna change the time. One more time. Pause it a little bit. Pause it a little bit. Yeah, a couple of minutes. So now, I want to start. Sketch a diagram from that side, Mario, started with the diagram. Look at that diagram, put the diagram, put down, look at the diagram, so you can see where you're wrong. The diagram. Huh? Huh? 4 minutes to go. 4 minutes. Guys, what do you do? Let's see how you know. Huh? Did you look at that? Yeah, man, I'm take leave from work and I'm gonna come class every day. We don't take time for doing this. Supposed to finish this already. I want something to concern more. Uh, 2 minutes left, 2 minutes. Thank you, Melon. About 5 seconds to go. Excuse me, I done. Let me come and put one on some pinch. Now walk on the room and look on the paper. Anything must say good must pinch. I'm on them something too easy, man. I can send out 50 times already. I don't have a problem, man. So I go home and work over the first time and don't beat. That's the problem you got. Anyway, time's up. Soft with a capital T. Soft. That's what this question is. Let's go. Question says, it's a parallelogram. You're supposed to feel happy when you get a parallelogram question. Populate the diagram so you can see your way around. You're reading up here to populate your diagram so you can see how you go around from point to point. That is what vectors is about. Since it's a parallelogram, the opposite sides are equal vectors. This side and this side equal vector. So since the vector here is V, then the vector up here is also V. Same length, same direction, same vector. Similarly, the vector over here going up is U. This side is the same length, same direction, so the vector up here also is U. And the line that is in the same direction and the same length is the same vector. Because it's the same direction and the same length of the direction. So the same vector. And if we go half of this here is half of the V. So it's distance and direction combined. That's what vectors is. And just discard how you go. It's all right. So I'm going to populate the diagram with information. The first is a parallelogram. See, this vector is U and this vector is V. So the opposite sides are the equal vector. Populate it. So over here is also the vector V right here. V, just like this. And up here going up from S going up to R is the vector U. Then they tell us about this line down here now. It's in the ratio 1 to 3. So the total part on the line is 1 to 2, sorry. The total part on the line is 3. Look at it. Watch this. Watch this. 1 to 3. So QM is one part. See there, QM is one part of the line. MS is 2 parts. MS is 2 parts of the line. So the total number of parts on the line is 3. It means then that right here is 1/3 of the entire line. 1/3. And right here is 2/3 of the entire line. 2/3 of it. 2/3 of the QS. When you practice this, because you just know the question will ask about traveling along that line. The whole line, you want to know it. A piece is just 1/3 of it, and that is 2/3 of it. Easy like cheese. So you put on information on it. This one out of one of the two, 1 part, 2 part, 1/3 of the line is at 2/3 of the whole line, So I'm leaving the ratio of the line so I don't forget. It's at half and half. Ready now? First part say, you must calculate the vector QS. How do I go from Q to S on this diagram? See that already must show you this, so? I can come over to here, so using the V, and then come down here, so using the minus U. Why is it minus U? Because I'm going in the opposite direction to the U. U going up this way. But to go down, I have to come down this way against the U. Or you can go the other direction. I can come down to P with a minus U, and then go across here, so with a V. Your choice. So it's either minus U plus V, or the V up here, so minus the U down there, so. No calculation you need upon that. It's too easy, the diagram show you. So this is just V minus U, easy like that. This is V minus U, done. Like 3 marks that. V minus U is the answer. Diagram show you how you go from Q to S. So it's like you now know this road. You now know it. Can you have it here? You now know it. So if you know it, you can go part of it if you want. More here, so it's 1/3 of this now. To go from Q to M. And the more I go from M to S, is 2/3 of this. 2/3. I now know how to go across this road using this vector. So that's another direction that I now know. I can go along it. I can go the whole length, I can go part of it using this vector. Let's continue. Next part wants QM. Q to M. Look at the diagram. I want to go from QM, the master, easy like that. QM. See this up? QM is just this. I think it's something more interesting to ask. That's just 1/3 of the QS. 3 marks that. QM is just 1 out of 3 parts of the whole QS. It's 1/3 of this. So it's 1/3 of the part there and 1/3 of the part there. See there? 1/3 of the V and 1/3 of the U. 1/3 of the whole thing. That's why I want mark. It's so easy. But I go to that so far. The next part now wants us to find MR. Look here. When the question tells you to show that MR is this enough, just find MR in a normal way and show staticity equal to. If the question says show that MR is that, they could have said find the vector MR. So whichever way them ask the question, you're going to find the vector MR and show, say, when you find the vector MR, this is equal to. So to show that MR is equal to this, you're going to have to find MR. Let's go back on the diagram now. How are we going to go from M to R? That's what this is. How do I go from M to R on the diagram? Let the diagram look and see how we go from M to R. Your choice. I want to go from here to there. You can't go across this, so no road there across it. No vector across there for me to go from M to R. I have to go along the vector direction that I know. What are my options? I can come down to S down here, so, and then go from S to R up this. So. That's one route. Or I can go the other direction. Whichever direction I choose to go, the answer is going to be the same enough. I can go M to Q up there, so, and then go Q to R out there, so. Whichever way you want to do it, that's your business, that. But me, Mr. Shaw, me prefer to come down this way. Why am I prefer coming down this way? Because this is in the same direction as this vector that I have. I don't want to go in the opposite direction to that vector that I have. Because if I'm going in the opposite direction, I have to introduce the negative and I have to be careful when I introduce the negative. I'm going to do it that other way, the two ways, just to show you that the answer is going to be the same. But I'm doing it in the exam. I'm coming down to S first and then go from S to R if I'm in the exam. But I'm going to go the other way as well and show you that I can go M to S, M to Q, and then go Q to R. I can go that way as well. Let me do the way I would prefer first. I'm going to do it right on the screen so you can see it. Right here. I need to over the side here. So you're going to see it. I need to over the side of the screen. So the diagram and the calculations are on the same page. Let me do it over here. I'm going to try it first. So I'm saying, we go from M to S on the diagram. It's not complicated. Diagram shows me. I'm going to go M to S, not M to S. M to R I want to go. M to R. I'm going to go M to S first. M to S. And then the plus means and then I'm going to go S to R. S to R. That's the first thing we need to appreciate. Better go to that. Good. Now, what is the MS? The MS is just a fraction of this whole vector that we know. It's 2/3. It is 2/3 of the QS. I can write it here if I want. It is 2/3 of QS. That's what the MS is. This piece right here is 2/3 of the whole QS. Plus, what is the SR equal to? The SR is U. Plus U. That's what the SR is. It is U. And then 2/3 of the QS is just 2/3 of this vector. So it becomes 2/3 of the part there, which is 2/3 V. And 2/3 of the part there is a minus 2/3 U. And then I'm adding back this U. Plus back this U. Oh no, that's space. Okay, it a bit larger, the smaller. Right, so I'm adding back this U now, plus U. Then again, I need to consolidate these values. Right? This becomes 2/3 V, and then a whole U minus 2/3 U gives me 1/3. But can I say that? This is a whole U, you know, and that's minus 2/3 U. A whole minus 2/3 is 1/3. Or if you like, I can turn this into 3/3U. Then 3 minus 2 is 1/3. So anyway you want to look at it, it's going to be 1/3 U. These two things become 1/3 U. It's plus 1/3 U. That's the answer now. That is what MR is. But them say must show it in a particular form, right? So what they have done in the question, all they have done down here is that they have factorized 1/3 from the two expressions here. They have factorized 1/3. So see here, so now we have this. We factorize 1/3 out of this and out of this. I'm gonna get 1/3 out of this, the 1/3 gone. I'm gonna left with the 2V. 2V. And out of this, I'm gonna left with the U. If I factorize 1/3, I'm gonna be left with the U. Plus U. So it's 1/3 2V plus U. Whichever way down, tell me I have the U plus 2V, but it's the same thing. Yeah, they have the U plus 2V, but it's the same as 2V plus U. See there, same thing. This is the same thing. Same as 1/3 U plus 2V. Same thing. That's your you get me? So that is it. Shown. Same thing. Let's go the other way now. So this is how I would do it in the exam. So I'm going to have to introduce a negative, right? So Mr. Sean in the exam and some Mr. Sean. But let's say, all right, your brain to go the other way. Let's see where you have to go. Let's go. I'm going to cut this and paste it down here. Let's put it here, so. Make it smaller. All right. Let's go the other way now on the same diagram. I'm sure that answer going to be the same. So instead of coming down here and then go up there, I am now going to go the other direction. I'm going to go back to Q first and then go from Q to L. Oh, by the way, before we're going further, I'm sure so. Before we're going further. We said the answer that we get was, the answer that we got was we just want to check if the answer makes sense, right? It's something that is good to do. We said the answer is 2/3 V plus 1/3 U, don't it? That's what we got. Let's look at it. 2/3 V plus 1/3. You see there? 2/3 V plus 1/3. I take it back answer that makes sense. Because your calculation and your diagram must match. They must be in sync. They must be consistent. When I check if this is correct. So this equation is saying to go from M to R and into the 2/3 of a V and then 1/3 of a U. That's what that's saying now. So watch this now. Let's test it. Now this is a whole V. So if I take that whole V and divide it into 3 parts like that, then this would be 2/3 of a V, don't it? Approximately, don't it? No, so that would be 2/3 of a V. So I'm going to move it in place. Move this 2/3 V in place and put up here some bang. So you can me. And then now I need a 1/3 of a U. I need a 1/3 of a U. No, this is a whole U. All of that is a whole U. Right? 1/3 of a U will be about this. That's about 1/3 of a U. I'm going to take that now, add it to my 2/3 V. Up here, so. See? I'm straight to R. See there? 2/3 V and my 1/3 U carry me from M to R. That tells me that that calculation is correct. Now, suppose, for example, they make a mistake with the sign and put a negative right here so instead. Right here, so. So we make a mistake and put a minus here, so. Let's say make a mistake and put a minus. That minus 1/3 U will be telling me that after I do my 2/3 V, after the 2/3 V, after this 2/3 V, this 2/3 V takes me from here to here. I reach right here, so. This minus 1/3 U will be telling me to go down, so. 1/3 U, because of the minus, which will be taking me away from the R. So I would know that this answer can't write. You get me? It will be taking me away from the R. So I know that I make a mistake. All right? So when you do this calculation, quick check if your calculation is correct. All right. So that is showing that you can use your check. Use the diagram and check if your calculation and diagram consistent with one another. The diagram and your calculation must match. All right. I'm still going to go the other way now, right? Let's go the other way now. So move this out the way and show you how we can go the other way now. I'm going to go M to Q up here and then Q to R out there to go from M to Q, M to R another way. So going from M to R using M to Q first and then Q to R. You see this M to Q is a negative of this QM that we just found, you know. See that? Okay, this is QM. MQ is a negative opposite direction of this. So the opposite direction of this means that we'll be applying the negative of this vector. So it's actually minus QM. MQ is minus QM because it's the opposite direction, right? So this MQ, I can change it to minus QM because I've reversed the direction. So I introduce the negative. Opposite direction in vectors is with a negative. Inverse of a vector is a negative of the vector. Opposite. Negative in vector means opposite direction. Then I add in the QR. And the QR clearly is this V. See there, Q to R is V. So adding this V plus V. Now what is minus QM? Minus QM is the negative of this QM that we just calculate. So you got negative that part and change this negative into a plus. Because I'm negating the entire vector. Right? So minus QM means minus this, so minus a third V. Minus a third V. And then this minus a third U becomes a plus third U. Plus 1/3 U. That's what this is. This is just that. And then I'm adding back this V, plus back this V. So you see now I have this only U term, there's a third U. And then I have a whole V minus a third V. A whole minus a third needs to be 2/3. That is 2/3 V plus 2/3 V. See? Same answer we get up here. So that's how we have the other way around. See there? It's 2/3 V and 1/3 U combined to give you that number. So you see, it could go the other way. Get the same answer. What is it? Same thing. And then you just factorize this. You see, you get the same answer going opposite direction. But as I said, I would prefer to go go in the same direction as the vector that I already have, rather than have to do this gymnastics with the negative. You get me? So you see, you get the same answer down here. Bang. Bang. All right. So somebody really wanted the collinear part or the collinear points part. That's what somebody really wanted. Oh man. Sure. So this is get the same thing. 1/3 into U plus 2. Yeah, factor as a third. All right. Collinear point part now. Ready now. So the question says, gives us some additional information. It said T is the midpoint of PQ. Populate the diagram. Put everything where them step on the diagram so you can see your way around. T is the midpoint of PQ. As somebody doing the question and now populate the diagram. We're doing a question with a diagram. Populate the diagram. If it's trigonometry, populate the diagram. It is whatever question you're doing with a diagram, measurement, vectors, transformation, bearings, whatever it is. Populate the diagram with the information so that when you look at the diagram, you can see what you need to do. Don't leave the diagram bare. Put the information on the diagram so you can see what is happening. The diagram talk to you. Don't leave the diagram bare. Don't depend on the wording. So first, I'm going to put this T on the diagram so I see it. T is the midpoint of PQ. Prove that the points are collinear. Collinear means that they are on a straight line. They could say show that the points are on a straight line as well. Or they could have said state a relationship between the points M, R, M, and T. And to be that they are collinear. They can have this question in multiple ways. All right? But they mean the same thing, collinearity. All right. I'm going to put the T on the diagram. Populate in the diagram. So the T is the midpoint of this line segment right here. So the T is somewhere right in the middle of the line there. So what I'm going to do, I'm in the exam room, I'm doing this as well. I'm doing this. I'm stretching out this U on the exam paper. And I'm dividing it half and half. I'm going to put the T right there. In the exam room, I'm doing this. Put the T right there. And say U is the point right there. So right in the middle, in the midpoint. And then that since that's a midpoint, it divides the vector half and half. So from here to here is half U. And from here to here is half U, the other half of U. So you cut the U half and half. Now, I need to show that these 3 points are collinear. And you can see that they are collinear even on this diagram. So draw a straight line, you see that they're collinear. Those 3 points on a straight line. Yes, push the door. What happened? What happened? What happened? Oh. Close the door, please. Close the door. All right. So to show that those 3 points are collinear, sorry about that, guys. To show that those 3 points are collinear, you need to show two things. To show that 3 points are collinear, you need to show two things. You need to form two vectors between the 3 points. Show that those two vectors are parallel by getting one as a multiple of the next. And there will also be a common point. So to show that 3 points are collinear, you need to show that there are two vectors between the 3 points that are parallel with a common point. So we need to establish two vectors between these 3 points and then show that they are parallel. And there will also be a common point. That's how you prove collinearity. Person online, you hearing me? Who asks the question?
Yes, sir.
All right, let's do it now. Let's do it. I have to do it and make it make sense and have sense. So between these 3 points, we need two vectors. We have one already because we just calculated the vector between M and R. We just calculated it a while ago. So I'm going to write down that one first. Let me do it over this side of the screen. So the thing is on the screen. Let me do it over here. Let me do it over here so you can see what I'm doing. Let me do it over here. So first thing I will do, write down the two vectors that I'm going to use. Pay attention now. I'm going to use the MR vector that I just found, which is, what is it again? It is 1/3 U plus 2/3 V. That's what this was. Same as 2/3 V plus 1/3 G, but I wrote it that way for a particular reason. I want U to be in front. I need another vector between these 3 points. Must now include the T, because I already have a vector connecting the T, the M, and the R. So I need a vector connecting the T to the M or the T to the R. So the question is, which one would you use? Would you use the TM or would you use the TR as my next vector? And I'm going to show that they are parallel. What I say? She said TR. She would use the TR. Anybody else? Anybody else? Anybody would use, you say you use the TRSS or TRSS, sorry, TR. Anybody else? Anybody would use the TM instead? Everybody said TR. Good. TR is a better vector to use because you don't need to calculate anything for the TR. It is obvious on the diagram how you go from T to R. You go from T to R, you come up to Q with the half V, half U, and then you go straight across here with the V. If you choose to use TM, you have to calculate, you have to work out this plus this 1/3, I have to do some calculation to do TM. To use TM, you do have to do some calculation and waste time. Any two vectors between the 3 points can work. Any two vectors between the 3 points can work. So use the two vectors that you can find the easiest way possible. And right now, it is easier to find TR, sorry, because you can see how you go from T to R on the diagram. You go half U this way with this half U, and then you add this V. So I'm going to write that down. So to go from T to R, I'm going to go half U plus V. And that's why I wrote the half U, the 1/3 U there for. I want them to be in the same order. Then now it's a matter of comparing these two vectors, expressing one as a multiple of the next. We want to express this as a multiple of that. And we have two vectors with fractions in them. Let me zoom up on the screen and do this now. And I'm doing this just one time. It's the last time I do this. All right? Because the same way all of them, you do all of them. So pay attention now. You only need to see it done one time. So I'm lining them up just to show you the process. So I'm now trying to compare these two vectors to show that one is a multiple of the next. Problem is that when the vectors have, for example, fractions in them, it's kind of difficult to see the direct relationship, the multiplying relationship between them, or the multiplier, or the factor relationship between them. So I always say to the students, get rid of the fractions first. It is easier to see the relationship between numbers when they are whole. So for example, if you have 12 and 3, it's easy to see that that's a multiplier by 4. But if you have a third and 2/5, a third and 2/5, it's harder to see what the multiplier relationship is between those two numbers when they're in fraction form. So always say get rid of the fractions first, because you want to be able to see the multiplier relationship between them. So to get rid of the fractions out of this one, you're going to multiply by the lowest common multiple of the denominator, which in this case is 3. You have a question? Hello? You have a question? So to get rid of the fraction of this one, you multiply by 3. See it here now? Multiply this one by 3. Now the only reason why I'm multiplying by 3, because I don't want them in fraction form. When they're in fraction form, it's more difficult to see the relationship between them. So I multiply this one by 3, I multiply each term by 3, multiply this by 3, you get 3 MR. Multiply this one by 3, the 3 cancel and give me U. Multiply this one by 3, the 3 cancel and give me 2V. So I've gotten the fraction out of the first one. Then I need to get the fractions out of this one. To get the fraction out of that, that's the only fraction. Multiply by 2, the fraction will be gone out of that one. Multiply this one by 2. Fraction will be gone. When I multiply that one by 2, multiply this by 2 first, I get 2TR. Multiply this one by 2, I get U. Multiply this one by 2, I get 2V. Then voila, I brought them to be the same. So since they are the same, it means that this thing and this thing equal. And so now I can equate. If I did not get them equal at this stage, I would multiply the smaller one up by some number to make it equal the larger one, so that I can equate the vectors. But this one, there's no need to multiply anything. They are already equal. And so now I can equate them. So now I can equate the two vectors. Equate. When I say equate, because the two of them equal this thing, as I said, it means that this thing equal that thing. So I can write that now. It means then that 3MR is equal to 2TR. This statement means that the vectors are parallel, because one is a multiple of the next. I can take this 3 and divide it under here if I want, and put it as 2/3. One is a multiple of the next. Or I can take this 2 and divide it under here, and put it as 3/2. I don't have to do none of that. I can leave it at that. One is a multiple of the next. This here means that the vectors are parallel. So there are two things that mean right here now that you need for collinear points. Because one is a multiple of the next, the first condition is met, which is that you must have parallel vectors. So the MR vector is parallel to TR. That's the first thing that you want to happen for collinear points. And then you have a common point, which is R on the two vectors. Parallel vectors with a common point. Common point is R. So you see the second thing that you must have for collinear points, a common point. See there, R is a common point, meaning that the R is on both vectors. And once you have established these two things, it must mean therefore that the 3 points involved are collinear. So you can draw that conclusion and say, therefore, the points involved. M, the first one was T. T, M, and R. T, M, and R are indeed collinear. They are on a straight line. And that is how you prove collinearity. You must get parallel vectors with a common point. And you have to write this out on the exam paper. You can't just get this and say, yes, them collinear. You have to write out these two things, because those are the conditions for collinearity. These are the two things that are causing you to be able to draw that conclusion that the points are collinear. So you have to write them out. Very good? 3 marks for that, but you have to want the 3 marks. You have to do it. Online, you okay with that? Student
Yes.
online,
Yes, sir.
that's how you do collinearity for all whatever vector they get. Get the vectors, find 2 vectors between the 3 points. Don't bring in no other point. Don't use no vector from any other point. Whatever the 3 points are, you find 2 vectors from those 3 points. Any 2 vectors will work. Be smart about the 2 vectors that you choose. Sometimes you will have the 2 vectors already in the question. Sometimes you will have one of them, you have to find another one. Find the other one in a smart way, the quickest, shortest way possible. Then you go about showing that the 2 vectors are parallel. And the steps in showing that the 2 vectors are parallel is that 1, the first thing you do, you get rid of any fractions that is in there. Because if there are fractions in there, fractions make it more difficult to see the relationship of the numbers. So you get rid of fractions. Multiply it, lowest common multiple of the denominator, get rid of fractions. Then if after you get rid of fractions, they are not yet equal as they were here. Look which one of the vector is smaller. You multiply the smaller one up to make it equal the larger one. Then when you get the vector component sides equal, then you equate, as we just did, equate this vector expression to this vector expression. Equate them. And once you equate them to establish a relationship that looks like that, it means then that the vectors are parallel and you can clearly see the common point on the 2 vectors, which would then mean that the points are collinear. And if you are proving that 2 vectors are parallel, it's the same thing you do. But you would stop right there, so. Same thing you do. When you want to show that 2 vectors are parallel, you get rid of fractions same way. They multiply up the small one to make it equal the large one so that you can equate. And then once you establish a relationship like that, it means that the vectors are parallel. But additionally, if you have parallel vectors with a common point, then in addition to being parallel, you now also have collinear points. And that is it. All right, guys, we're going to take a break. We want half an hour? We want full half an hour? So we're going to, huh? It can't be 45 minutes, and we're late already. I just don't know what this. We're going to be 45 minutes, and we're already late. We should have been in the second session now. We're supposed to stay third, all right, 10 minutes, half an hour. Yeah, what are we doing here now? What's up? All right, no problem. You get a book already?
Yeah.
Where you get a book? Where me get a book? Oh, should I write today?
I'll be back by 4.
All right. Joyce, have you done the book already? Why not? Why? Then why not? Video? Oh, yeah, video. Yeah, videos. All right, no problem. Once you learn, you everything. All right, starting back in 30 minutes, guys. And come with your question 9. No, yeah, come with your question 9, please. we're doing the same rate, 10 minutes per question. Okay, guys. Ready to start? Some people still having lunch, but we're gonna start. When they finish, they come on. All right. So anybody having a number? Oh, this number, what's over there? Number 9. So somebody sent in the chat that they wanted number 9 from 2024. So can we start with that? Somebody wanted, and I cannot see the chat. Okay, so while I'm doing the class, I cannot see the chat in the Zoom. So you guys have to talk on the screen. Just talk here. I cannot see the chat. I'm not watching the chat. Somebody wanted 2024 January, question 9. So they wanted 8, 9, 9, 9, and 10. We're going past 10 already. So number 9. January, somebody wanted January 2024. Let's see if I can find that paper. January 2024. January. Where is that paper? Where it is. Question 9, somebody wants it. Question 9. Where are you? There you go. Somebody said number 9. I think maybe it's right here, I wanted. And then it's a 9A or B and like that. So let's assume it is 9A for the time being. 2 pages. Is number 9 is 9A wanted or 9B online? First online.
9A, sir.
9A. Circuit theory. I'm opening it up over here again. This is the second page of question. Just to calculate these angles. Huh? Any number 9 question for about 2 hours, maybe 1.5. That will miss some time. And this question I want you to calculate these angles and give reasons for this question. Then ask for those angles right there. All right, 10 minutes. Yeah, 10 minutes to do that. Ten minutes to do this question. You have any seat? I see the way that. I see the last part. Okay. You finished? Yeah, look at that. Huh? Go to that. All right. All right. What I'm going to do with this question, I'm just going to populate the entire diagram and show and see how we get each of the angles. All right. That's what I'm going to do. Populate the entire diagram. All right. The first question we is asking us for the angle at the center right inside here. KLO. That's this angle. All right. That's what it's asking us for. Let's look at the reason behind it. All right. So the question is asking us for this angle. First question. So I always say, find what is subtending the angle and see what else that thing is doing. So we find what is subtending this angle is by tracking back until you reach a circumference. And so that angle is being subtended by this chord right here. And what jumps out at me in terms of what that chord is doing is making an angle of 48 degrees with this tangent. So there's a rule that says angle between a tangent and a chord right here is half the angle subtended by the chord at the center. But that rule is hard to use. But what else is this chord doing? That chord would also be subtending, majority in purple, this angle at the circumference, that blue chord up here. So this, since this angle is 48, then this angle up here so is also 48. But the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment. So this angle up here so is 48 degrees right here. Same as the angle between the tangent and the chord over here. And then now, because this angle of circumference is subtended by this chord, which is subtending that angle at the center. Angle at the center is twice the one at the circumference, subtended by the same chord. So it means that this angle inside here is actually 2 times 40, which is 96. This is 40 degrees. And circumference subtended by this chord subtended twice as much at the center. That's what we call the center rule. So it means that this angle in here so that angle is 96. That's the answer for down here. That's the answer for this part. The reason is that you can say angle between a tangent and a chord is half the angle subtended by the chord at the center. So the angle between here is half of the one at the center. So one at the center is twice. Or we say, okay, angle between a tangent and a chord is equal to the angle subtended by the chord at circumference. And then now the angle at the center is twice the amount at the circumference. And so that is why that is 96. All right. And then now, question went on to ask for these angles. So it wants LMN. LMN is all of this angle. And we have a piece of it already. So it would be nice if we can find this piece. This piece. Well, that piece inside here to add to this 48, right now is being subtended by this chord, that in blue. And that chord is clearly making an angle of 56 degrees with the tangent right here. It means then that the chord is going to subtend the same 58 at the circumference. And so the angle inside here is 58 degrees. 56 degrees. That angle is 56 degrees. And therefore, the total angle over here that I want is sum of these two. 48 plus 52. So this angle that I want here, not 52, 56 is 48 degrees plus 56 degrees.
104.
104. The next angle they're asking for is KLO. KLO is KLO. It's this angle right here. Now, this is an isosceles triangle. It's a sector triangle. One is a sector is an isosceles triangle because this is a radius. And this is also a radius. And therefore, these two angles down here are equal. And if you know one angle in an isosceles triangle, you're blessed. You can find the other two. And so this angle out here is going to be 180 degrees minus the 96 degrees. Because these two angles are the same, you can find it by dividing that by and get that one. That by one next. So that's the calculation over here. So 180 degrees,
42.
96 degrees, divided by 2, which is 42 degrees. All right. That is why that is 42 degrees. Because an isosceles triangle, 2 angles down the right equal. So that's 42 degrees. Let's populate the diagram. And to find something, you put on the diagram. So this whole angle here is 42 degrees. All of this is also 42. What is the piece here is 12 out of the 42. So I just need to add the remaining piece right here, which is 30 degrees. 42 minus 12 is 30. So that angle between those two sides is 30 degrees.
Sir, could you
Next
just
angle.
put that right there for me, please, again?
So again,
Could you just go over that area for me again, please?
I'm saying this angle, remember, is an isosceles triangle.
Yes, agree.
42. And all of this is 42. All of this is 42 as well.
Right,
But
yeah.
it means that this little piece in here must be 30.
Oh, awesome. Okay, thanks.
All right. So this angle inside here, so it's 30 degrees. All right. The next angle I want, next angle I want is MLKF. This is 42. 42 easy, man. Because remember that this sector triangle is isosceles. So these two, they are radii, radius and radius. So them equal. So since them two sides are equal, it means that these two angles equal. And since you know one angle already, you can find these two. Because they're equal. Huh? The 96 in the middle there, so the 96, I got it because we said that this angle is 48. So I'm gonna get this angle to be 48 because this angle up here is subtended by this chord. If you come back to reach the circumference, this angle is subtended by this chord. And that chord is making this 48 degrees with the tangent. You know, the angle between a tangent and a chord is equal to the angle subtended by the chord, circumference. So that's why this angle is the same as that one over there. Then now, this angle is at the angle of the center that is subtended by this same blue chord. This same blue chord. The one at the center is twice the one at the circumference when they are subtended by the same chord. That's why this is 2 times 48, which is 96. Get that? All right. That's one way to do it. That's not the only way, but that's one good way to do it. All right. The other way, I'm showing another way to get the 96 inside here without doing this out here. Without doing this, there's another way to get the 96. Okay, watch this now. This is the radius. That's a tangent, right? And between a tangent and a radius is 90 degrees, don't it? So this whole angle here is 90 degrees, right? So that whole angle is 90 degrees. And this part of it is 40. The whole of this is 90, you know. Of this total angle, which is 90, this is 12, and this is 48. So the two of them right now are to 70. So this piece to complete this is going to be 30. But the total across here says 90, right? And then now, as I said, this is isosceles. Let's assume that we never know the 96, right? That's I blue isosceles triangle. So because this angle here so now is 30, it means that this angle here is 42. If that is 42, then this also must be 42. Then total of 42. Total angle in triangle is 180. So this angle up here would be 180 degrees minus 2 times 42 degrees. Right? That's another way to get the 96. You get me? That's another way to get the 96. Let me put back this thing and so far what will do. There's more, a lot of the time these questions can be done in multiple ways. Putting in back what you know before. All right, so one knows that this angle here is 42. And inside is 30. Right here. The next question I want is MLK. 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 That's all of this angle. The one next. MLK. But it's kind of easy because we know of this purple triangle. We take off this 42. Then in that purple triangle, we have 2 angles in it. And we try to find this one. See that? So it's 180 minus. And those 2 add to 78. It's 180 minus 78. All right? So that's how we can get it. So this angle here, from 180 degrees minus the 30 and the 48. What I work out? 180 minus 78.
102.
102 degrees. So it means that all of this angle now is 102 degrees.
No, sir. No, sir. Sorry. Yeah. When you add that,
Correct.
yes, it is right. Add both and then subtract. So, yeah.
Just say it right, you know. And answer I'm going to be inconsistent. I'm not checking anything now, depending on it. The next angle I want is angle KNM. Angle KNM. KNM is this angle over here. You can find that angle 2 neat ways. Watch this now. One way to do it is to recognize this is what we call cyclic quadrilateral. 4 vertices and a circumference.
Right. Opposite angles adds up to 180.
Those 2 angles are supplementary. And so this angle over here, 180 degrees minus this 102.
Mm-hmm.
I'm going to give you 78.
Right.
All right, watch this now. More maths equals better maths. Another way to do it, to go back to the traditional approach, which is to say, all right, find the chord that is subtending this angle. So if you want to find this angle, come back along this side until you reach the circumference here. And also come back along this side until you reach the circumference here. So that you know that that angle is being subtended by this chord. This chord is subtending, we'll draw it in a different color. This purple chord is subtending that angle up here now. That purple chord is touching the tangent, making an angle with the tangent. Angle that is making the tangent is this one. 30 and 48, which add to 78 degrees. So since angle between the tangent and the chord, 78, then this chord subtends the same amount as the circumference over here. Same 78. So that's another way to get the same 78 degrees.
I didn't see that one at all. I saw the cyclic quadrilateral. I didn't see that one. I didn't saw that one at all.
Yeah, whichever way you see it, good. Another question might become relevant. Wasn't needed in this question, but that would more ways you know to do it, the better. And that finishes that question. So this angle is 78 degrees. I saw at it. All right. So I'll show the two ways. All right. Which other question? That one finished, you know. Which other question somebody want to do? So the person who asked for the 2024 paper, they also wanted this part B.
Yes, sir.
You want that part B? All right, 10 minutes to do it. Let me see what it says. It's a bearings question. So let me bring it up on the screen over here. And it's a two-page question. Right. So I'm gonna leave this part of it over here. Give you all 10 minutes to do it. Second part over here. If you can see it. Let me write this last part down here. Down here, they also want to bring off G from each. Let's put this part B. One G from bearing of G from each. That's information. I want to calculate those two bearings with that information. 10 minutes. Right in the middle here. This first part is to show that this angle is 29 degrees. Angle X inside here is 29 degrees. 10 minutes, guys. Come on, you can do this. All right, didn't catch that. Huh? 2024 in the group. Sure, it's in the group. Let's search for 2024 to come up. But I don't look it that way. Let's search. I just sense it. Mechanism of missing here now. Huh? I'm sure no leave a mess there, because you have to have it outside. Here. You got to get to the work, get to work. Okay. Yeah, survive. No problem. Huh? No. No, answer. No, we're told. Which part? Part one? Part one, tell you must prove that angle is 25.5. No problem. Ever get it negative? Just our next part yet. Huh? Come on, hurry up, taking too long. About 3 more minutes. You can do the work upstairs, that's no problem. I'll watch your work questions tomorrow. Ready? Huh? Question. It gives us this diagram. It said there are 4 points on level ground. Diagram below gives information about the distance and angles between the points. Now, what we have to recognize about this diagram is that it's like you're up in the sky looking down on the ground. That's what this is. You're not at ground level looking at this diagram. This is a diagram of you being in the sky, like in an airplane or a drone or something, and you're looking down on these points on the ground. So because you're looking down on these points on the ground, you're not going to see vertical objects. Vertical objects will be coming up towards you from the ground. And this question speaks of a vertical object, GT, being right here at G. So to you, because a vertical object is just going to be just a spot, a dot. You're not going to see you're not going to see the vertical section of it. Because you're in the sky looking down, you're going to see the top of this thing. We're not going to see the actual G and the T like that. But you're not on the ground, you're in the sky looking down. So the vertical thing that is right here is still going to look like a spot, like a dot. If you're in the sky looking down on the ground. At the vertical tower here. All right, but let's deal with the first part of the question first. But remember, guys, bearings question, bearings are angles on the ground. They're on level ground, now you're up in the sky looking down on the ground at these things. You're not on the ground looking up at these things, right? You're in the sky looking down, and so these are just like points. And if there's a vertical tower here, you're not going to see the vertical, you're not going to see the vertical side of the vertical tower. You're just going to see the top of it, right here. All right? You're not going to see the height of it if you're in the sky on this diagram. All right, it says, show that the value of, so everything is here. They say all the distances on the diagram. So we trust all the distances that we see on the diagram. And we have to show that the angle X inside here is 29.5 degrees. So we're going to have to come and work in this triangle to get that angle. Now that triangle is not a right angle triangle. And since it is not a right angle triangle, you have to use sine rule or cosine rule in it. In this case, you don't have any angle, so it's must cosine rule you have to use. Because for you to use the sine rule, you must have at least one pair of angle and side opposite each other. And in this case, you don't know any angle. So we're going to have to use the cosine rule. Remember now that the cosine rule starts out like Pythagoras' theorem. So this starts out as if it is a 90 degree, and this starts out as if it is your hypotenuse. That's how Pythagoras' theorem starts out. And then subtract a piece. So your angle and side opposite each other would be this and this in your cosine rule. Starting with this like is an hypotenuse, and then these are the other two sides. And that's the angle between them. All right? So you have to use cosine rule to find that angle X. Cosine rule. cosine rule to find x. And you're gonna have to transpose. All right. So start like part of the system as if you're saying the hypotenuse squared, which is a 6.9 squared, is equal to the sum of the square of the other two sides. That's how the cosine rule starts out. It's equal to 5.3 squared plus the 11 squared. But because it is not part of the system, you have to subtract that piece. It is always you're subtracting twice the product of those two, 5.3 and the 11, and then taking the cosine of an angle between the 5.3 and 11, which is the x right here. So in this question, this is the x that they don't know. They're trying to make it the subject. So we're gonna have to transpose. They don't give a lot of space to work. They don't want no 1 million lines of transposition to do this. So I'm going to show you the steps to transpose now to make this x the subject. So the first thing I'm going to do is take this negative expression, everything that is negative here, and put it on the right side, on the left side, sorry. And take this 6.9 squared and put it on the left side. And these two remain where they are. All right? So I'm going to copy the line down and then move the things around so you can see. So let's just copy this, paste it here. I'm going to use a device and just move this stuff around. So this expression here, that is now negative. I'm going to come over the next side, I'm a positive, so I can just move it alone. I'm going to come over this side and become a positive. Then this 6.9 squared, I'm going to go over this side and it becomes the negative. So it takes up this negative right here. All right? Takes on that negative. So right now, we have this equals that. So far, so good? Very good at that transposition so far. Very good? Remember now, don't try to transpose everything away from this x, So then I'm going to take all of this and divide it on this side, like I've divided both sides by it. So next step is to take all of this and divide it on this side. Divide it on this side. That's the next step. All right. All right. So this is now equal to that. So far, so good. Here are the steps in the transposition. But go to that. Then now, if the cos x is equal to that, then the x becomes the cos to the minus 1. And I'm transposing the cos and taking the inverse cos on this side. But it's a cos to the minus 1 of everything. That's what x is equal to. And those are the steps in the transposition. But I go to that. And you just put everything right here in the calculator and work it out. And the x is going to be 29.5 degrees. All right, I'll bring up the calculator and show you. Put everything in the calculator right there. Come up calculator. I'm going to do cos to the minus 1, a fraction. In the numerator, I have 5.3 squared plus 11 squared minus 6.9 squared, dividing that by 2 times 5.3 times 11. There you go on the screen. 29.5 on the answer line right here. 29.5 on the answer line right there. So that is 29.5 for you. That was short. I think I need a character for this question. You normally use a character for the tricks question, so let's leave it. So I'm going to put that on the diagram at 29.5 degrees. Let's put on the diagram. So I was going to populate the diagram with any information, you know. So I'm just going to scribble it in right here. This is 29.5 degrees. Let me make the pen a little smaller, right? The pen. I'm up to the same thing. 29.5 degrees, right here. 29.5 degrees. That's this angle right here. All right, you know that. Now the next part of the question is on the next side of the screen. Gives us all this information. But let me bring it up on the next side of the screen. So the diagram is in front of us while we work. All right, so it says, see a vertical tower. You can't see the vertical side of the tower because this diagram is from above. So you're not going to see the vertical side of the tower in this diagram. You have to imagine that that vertical tower is right here. So it looks like a dot still from the sky. The G and the T looks like one spot in the sky, from the sky. So it's constructed at point G and it's pivoted to the ground at points E, F, and H. So you can have a vertical thing right here and then have it pivoted to the ground. So if I were to kind of sketch it, for you and show the vertical tower, so if I were to draw that GT like so, just to show an elevation view of it, GT, this is G. Then like you have F out here, you have H behind it, and you have E down here. And those 3 points are on the ground. And they are connected with these wires. But this line is horizontal. So for example, this line is horizontal. And this line is horizontal on the ground. And this line back here is also horizontal. And therefore, let me put this one up a little bit further around this H. I'll put H right here. And show a little bit better. I'll put H here. Right. So this line is also horizontal. And then this red thing is my wire. And so the angle inside here says 90 degrees. Because this blue line is horizontal and this one is vertical. So the angle inside here says 90 degrees. Angle back here is also 90 degrees. And this angle, this is vertical, and this is also horizontal. And so this angle is also 90 degrees. So it means that is a vertical right angle triangle. This is a vertical right angle triangle. And this is a vertical right angle triangle. So I can draw the elevation view of this thing for you. And the question now is giving us an angle of elevation from F up to T. So basically talking about the angle inside here is 35 degrees. The bearing, no, 31 degrees. So this is 31 degrees looking up. So if you're on the ground and you're looking at the foot of the tower first, you have to elevate the line of sight, it's 31 degrees to look up. And so you form a right angle triangle. Remember that the distance between G and T, G and F is 6.9 meters. That's this same distance is 6.9 meters. And so if you pull out this triangle here and put it by itself, it would look something like this, a normal right angle triangle. Where this is F, this is G, on top there's T, and this is 90 degrees. And angle of elevation is right here, looking up. 31 degrees is the angle of elevation looking up. And then the distance here, so it's 6.9 meters. And so you know, we're working a right angle triangle right here. So now a right angle triangle. So I can take this off now. I just did that to show you what was happening. Like to visualize it. So we're now working in that right angle triangle. The question is asking us what they said. What is the length of the wire? What is the length of wire that joins T to F? That is this length they want, which is the hypotenuse. So in this question now, we're now working in a right angle triangle, so we can use so-called tower. And what it is that we have the adjacent and we want the hypotenuse. Adjacent and hypotenuse are connected with the cosine, trig cos. So we're going to use that to calculate the hypotenuse. Simple as that. We're going to say cos of the 31 degrees will be equal to the adjacent side of 6.9 over the hypotenuse side, which is the TF that I want. TF. Then to make TF a subject, we're going to take it and multiply it up here and take the cos part one and just divide at the same time. The transpose to make TF a subject. Cross multiply and divide. So simply put, the TF becomes 6.9 divided by the cos of 31 degrees. Put that in the calculator. So we're talking now. Come to the class. It's class going on. Hey, come on to the class and see a class about. Cos of 31. And that answer, wait. 6.9 divided by cos of 31 degrees. Hey. That is 8 meters. 8.05 meters. 8.05 meters. So far, so good with this question. So far, so good. Online, okay?
Yes, sir.
All right. The next part now says, they give us some bearings now. Ready now? Bearings time. No bearings yet, no. Ready now. So the question now says, they're giving us some information. The bearing of E from H is 228 degrees. The important thing with bearings is you must always note the from position. So I'm measuring the bearing from H to E is 228 degrees. You have to put it on the diagram. So you see how it will help you. My old, hey. Right. You don't see the class going on? All right, we start. This is what happened out there. Huh? Come, let's go. So the bearing of E from H is 228 degrees. You need to put it on the diagram so you can see it and see how you use it. All right? So I'm going to draw it on the diagram here. Remember, it's at the from position here, and you want the bearing down to E. They're telling us the bearing down to E right here. From this point. The bearing is measured clockwise from the north line at the from position. So that 228 degrees is the clockwise angle all the way around here to this line that will take it down to E. That angle that I've drawn in red is the 228 degrees. Make it a little bit thicker again. and drag it over. So this angle right here, clockwise from the north line, that will take you to the line out to that direction, out to east. That is your 228 degrees. You put it on the diagram so you see how you use it. Note now that this angle inside is a part of it. This angle in here that we found initially is a part of it. The 228, and this 54 is also a part of it. So right now, we are able to calculate this angle if we want it. But that angle will be 228 minus the 29 and minus the 54, the 29.5 and 54. That's what this blue angle would be. And that blue angle happens to the bearing from H down to F. That's what that angle is. The bearing from H down to F. But it is a clockwise angle at H, from the north line at H to the line that will take you down to F. If they happen to want that angle. They don't want that. Let me tell you this off. That's what I wanted here. No, they want from E to H. All right. So here now, they're asking from E to H. I have to put this angle in the diagram and see how we get it. We must measure at the from position. So they actually want from E all the way back up to H. That's what they want. All right. So I'm seeing two ways to do it right here now. I'm going to show you both ways. So remember, bearing is really a direction, you know. Yes, it's an angle, but it is the angle of a direction. Not just a line. It's an angle of a direction. So they're asking us in this question for the bearing of this direction right here. I'm taking it right through my diagram. We want the bearing of that direction, because that is the direction from E to H. I can actually measure the bearing right here now. Let me extend this north line and show you what I mean. That's my north line. So if I can find this angle right here, then I would have the bearing of that purple line, this angle. That is the angle, you know, it's the same direction, you know. Because if I'm measuring the bearing down at this place, extend this north line as well. This is the angle that I asked me for. These two angles are the same. They are corresponding angles because this is the north line and that's a north line. And then this purple line knows one straight line connecting both of them. Which one? Which angle? Which angle? Which one? All the angles that I know is written on the diagram. I can't find the one in blue by subtracting 228 minus this and minus that. Which one over here? Over here. Yeah, I know. I said I was going to show you two ways to do it. Yeah, I said I was going to show you two ways to do it. That's what I said. So I'm showing you a nice way to do it without doing that. That other way is more work. But watch now. Because this purple line is a straight line, don't it? Total on a straight line is 180 degrees. And everything around here is 228, don't it? So this angle in here that you want is actually 228 minus 180, which is the answer. You get me? That is the angle. The bearing in this angle inside here becomes 228 degrees minus 180 degrees. But you understand that?
Yes, sir.
Huh?
Yes.
Good, because the whole red angle around here is 228, and the purple line, which is the direction line I want the bearings of, is 180. So the angle up here, that which is still the bearing angle, becomes 228 minus 180, which works out to be how much?
48. 0.0.
Go, you have to put the 0 on it. Go, 0.48. That angle is 0.48 degrees, guys. That's the bearing angle. But most persons would do the way that you're saying, which is to come down here. Most persons would do it this way. Let me leave this part up here. Most persons would try to actually get the angle right here. We'll do that part in green. Most persons will actually try to get the angle right here by calculating this angle right here. And to do that, they would say, okay, the total angle around here so far is 228. So the remaining piece over here is 360 minus 228. And then these two angles must add up to 180. Pointer angles, which is fine. But I don't show you that quicker way to do it. Because more maths equals better maths. Every time. Eh? No one sees it. That's why I'm a teacher. That's why I have to teach people. Easy way. Yes.
Go again. So you're saying this is 228 and all the way around with adds up to 360 degrees, right?
Over here in the green part.
Mm-hmm.
So over here now is 360 minus 228 already.
Mm-hmm.
This is what most people do, because most people focus their brain and find an angle here. But I'm saying to you that this direction is the same bearing everywhere in the diagram, even up here.
Okay.
And so this angle is the same bearing angle down here. Because bearing is a direction.
Oh.
You get me?
So
Yes,
so with that.
we're gonna do it how most people do it now. Most people find this angle first.
All
By
right.
doing 360
I had a
degrees.
follow-up question. All right, go ahead.
Well, I'm gonna just finish this first. Minus 228, which is what?
132.
132 degrees. And then these two angles now are co-interior angles. We call them U angles in this class because
What kind of angle?
they call it U, because it look like a U. Look, down this line. Oh, it's a different color. It's a different color. Let's use the blue. Down this parallel line, up this line, and then back up this parallel line. It looks like there are angles inside a U. These two angles down here, this one and this one.
Okay.
Always add up to 180 degrees. So, you know, we say Z angles, we call these two U angles, which are really, the proper name for them are co-interior angles.
Co-interior.
Co-interior angles, they add up to 180 degrees. So since this one up here, since this one up here is 132, then the bearing angle down here that I ask, you know, for this one will be 180 degrees minus the 132, which is the same 48. We have to put the 0 on it because it's bearings, and bearing must all be expressed in 3 digits. But that is more work than what I just did over here. And so that's why you have to learn new ways of doing stuff sometimes. Easier way to do it. All right, so that is how we can get the 0.48 degrees. So that is the answer over here. I'm just going to write it because I explained it on the diagram. So this is 0.48 degrees. And I would say C diagram in the exam. That's what I would say. Because I've done all this calculation on my diagram, but do it that way. Whichever way I use. All right. The next angle I want, the bearing of G from H. The bearing of G from this H. Let me find a different color for that one. Let's use this brown. So the bearing of this G from this H is kind of easy. Because now this is an outline at H. You want the bearing down to this line. This is the angle that you want that I'm marking out in brown. This angle you want. And that angle is just the 228 minus this 54. That brown angle. The whole thing around here is 228. This piece in here is 54. So this answer is just 228 degrees minus 54 degrees. That's the bearing angle.
Yes, sir.
What I work out to?
174.
174?
Yes, sir.
Yeah.
174 degrees. And that will be that. And that finishes that question. Yeah. All right, which one you want to do next? Another number 9. All the food in them will just come in. Which number 9 I want to do? Let me send you no woman now. Huh? 20? 19? January 2019? Oh, yeah, the 2019 king. All right, let's go. King of 2019. January 2019, I'm saying. January 2019, where are you? Looking for it. Looking for it. There you go. January 2019. All right. Number 10, right? Number 9. Number 9. Number 9. Number 9, right? Number 9, yeah, number 9. Which part of number 9? This part? Part B or B? Which one? Want this part?
30 at the A, sir. Right. 30 at the A.
Want A. All right. A. Somebody say A. Let me see what A want. A want. All right. So let me see if we put stuff on the other screen as well. Hold on. 2 pages. And I give you 10 minutes to do it. You guys working out every question here today. And some of you not doing anything, you know, need to know. I don't know what. I thought walk around the room and make sure them show me no work. And by now, guys, you have to do the exam paper yourself come Friday. You know? Watching me do it is not enough. You have to put pen to paper. Watching me do it is not enough. Hey, tell people all the time, you know. Watching somebody solve question was good enough. Everybody in the Caribbean will get one straight A's. Because every teacher in the Caribbean is solving questions for people. You get me? Everybody doing it. Just have class with just solving questions, and nobody learning nothing. Because you're not putting pen to paper. You can't watch somebody solve question and learn anything. I'm telling you. You have to do the work yourself. You have to do the work yourself if you're going to learn anything. All right, here's a question. Part A and part B. That's it. I think that's it. Part 1. There's 3 parts this question has. Come on, 10 minutes. Starting now. 10 minutes. Come on. Leave it over here, sir. Minutes. Come on, come on, come on.
Sorry, what I hit with the computer just number.
Part A, part 1, 2, and 3. Part
All right. So angles on the
10
same.
minutes.
Okay. Angles on the same chord in the same
No,
segment.
no, don't read it out, please. Mr. Mike, just do it.
Just write down my answer? Okay.
No, just do it, just do it. Mute the mic and just do it, please.
Oh, all right.
Do the work and stop look. We have to look for more. Door, man. Just a minute, class, I'm gonna go on here. I'll put the roll on here and just see with people, man, and I'll go. Some nice man, I don't get upset. Let me do it now. I do it now. All right, guys, let's do this. All right. So this question gives us this information. Let's see if what they have up here is also on the diagram. That's what you normally do, right? Make sure everything that they have said is on the diagram. All right, so P, Q, R, T, and V are points on the circumference. Those are there. That's a straight line, this one. It's not a tangent. Notice it's not a tangent. All right, so you can't treat it like a tangent. And the PVR is 75 degrees, that's inside here. And then this angle TRS is 60 degrees inside there. All right. Question said determine the value of each of the following, show detail working where necessary, give reason support your answer. First thing I want is angle T, PTR. PTR is this angle up here. All right. So I want us to tell them what this angle is and give a reason. Oh, I always say if you can't see the angle, the first thing you want to know is what is subtending angle. So what you do, you come back until you reach a circumference, come back until you reach a circumference. Remember, an angle is subtended either by a chord or by an arc. There's no chord shown there, but there must be an arc. So this is the arc that is subtending that angle right now when you join the 2 points. What else is that arc doing? This arc is also subtending this angle up here at the circumference. If I were to put in a chord, then these two angles will be in the same segment across from this chord. And so this is the same segment rule. These two angles are equal, but they are both subtended by this chord that I put in orbit by this arc. So that angle up there is 75 degrees that I want. So this angle is 75 degrees. And the reason that angles in the same segment are equal when they are subtended by the same chord. So this angle is 75 degrees. Same segment rule. Angles in the same segment are equal when subtended by the same chord or by the same arc. Angles in the same segment are equal. So this angle up here is 75 degrees. Let's put another diagram. All right. Next angle I want is angle TPQ. Leave the diagram on the screen and do it over this side. So the now one angle TPQ. All right. So that angle is TPQ. T to P to Q. That is this angle right here. Again, we can go back and find what is. All right, so that angle is opposite to this one. So those two angles are supplementary angles. All right? So those two angles are up to 180 degrees. But then these two angles also are up to 180 degrees. So if them two are up to 180 and them two are up to 180, it means that this angle equal this one out here. It means that this angle is equal to the angle out here, 60. Now there are two ways you can look at it. You can say, okay, total angle on a straight line is 180, so this angle is 120. Then these two angles are up to 180. Because they are supplementary angles, opposite angles in the cyclic quadrilateral. So this angle is 60 degrees. Good? But there's also a rule that says the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. You can use that rule as well. A straightforward rule. Rather than do the straight line first to get this 120, and then do the cyclic quadrilateral inside there. Let's look at the external angle aspect of it. So if we focus on this cyclic quadrilateral, open that door, please. Right, give me a second up here. Let's finish this question here. Give me a second, please. All right. I'm going to take this and extend this side. Instead that I extend that side, then this is an exterior angle. Good. That exterior angle is equal to the opposite interior angle of the cyclic quadrilateral. So this angle over here is also 60 degrees. So we can just write that straightforward rule. Let's write that rule straight. All right. That angle is 60 degrees for that. So we can just write it straight and just say it is 60 degrees. Exterior angle of the cyclic quadrilateral. This angle equals 60 degrees. And we can just write that the exterior angle of a cyclic quad means quadrilateral equals the opposite interior angle. Equals the opposite interior angle. The last part now says, we have to find, let me take this off. We have to find the obtuse angle POR, where O is the center of a circle. So they did not show the O on this diagram. So what we can do is kind of estimate where the O would be. So the O might be somewhere around here. Let's put it on so we can get a visual on it. And if I draw the angle that I want, POR, P to O, let me take off this angle 60. I want P to O to R, P to O to R. So they're asking us to find this angle right here. So that angle, if you come back again, join from PR. Join from P and R. So this is the R that is subtending that angle, and that is an angle at the center. This same arc is subtending that 75 degrees at the circumference now. So the one at the center is twice. Angle at the center is always twice angle at the circumference when subtended by the same arc or chord. You can even join the chord as well if you want. That chord is subtending that angle at the circumference twice as much at the center. So this angle inside here becomes 2 times 75 degrees, which is 150 degrees. So we're going to write that it is 2 times 75 degrees, which is 150 degrees. That's because angle at center is always twice angle at circumference. Angle at center is twice angle at circumference. And that finishes that question. All right, this one now. You want this one too? Want this one too? All right, so this question actually had an error on it. Let me show you the error on it. And it happens in CSEC sometimes, guys. You have to be smart. So watch me now. The question said the bearing, the angular depression of S1 is 12 degrees. I think that's a little bit more. So, and the other one is 20 degrees. Now, clearly, this one is smaller than this one. So it means that these 2 points are the wrong way around on this diagram. All right, so do it this way. Do it with this as S2 right here. And this as S1. All right, so I'm going to bring it up on the screen. Let's put the screen again. Same thing over here, S2 and S1. All right, so S2 and S1. All right, 10 minutes. Let me see what it says. That's the part A. And the part B is just to find the height of the lighthouse. That's all. Ten minutes. So what you know want it? Yeah. 10 minutes. How about I start in the night, please? Four minutes to go. Ready? 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 No more than you ready? Right. All right. So we're gonna look here. We're gonna break from this question after this, right? Nobody have any more of this type of question I want to do? I know I think I short break after that. I should have started the third. You don't know. You should have the third question now. You know. I'm gonna do this as the last question for them. Take a short break. Can't take half an hour break after this. 15 minutes break after this. I wrote some number here. All right, guys, let's go. Let's go. Time running out. Time running out. We're late. All right, let's do this question. And we're coming off this. We're going to number 8 next after this. All right, question says, first at the top of a lighthouse, TB, so that's a lighthouse, TB. That's vertical, right? You see it's 2 ships, S1 and S2 approaching the coast, as illustrated in the diagram below. Angle of depression is 12 degrees and 20 degrees respectively. So because I say respectively, it means that the 12 degrees relate to S1 and the 20 degrees relate to S2. All right, remember angle of depression, the angle below the horizontal when looking down. But also remember that the angle of elevation from the other end is the same angle. So for example, then the angle of depression looking down to S1 is 12 degrees. Angle of elevation from the other end looking up is the same 12 degrees down here. Same thing for the 20. Angle of depression looking down to S2 is 20 degrees. Angle of elevation from the other end looking up is also the same 20 degrees. You could work the Z angles to see it, Z angles to see it. Same thing with the blue one, see, Z angles, alternate angles. All right, so that's the first information. Let me put them on. Put them in here. So the angle inside here is 12 degrees. Looking down. Angle looking down here is 20 degrees. And so we can deduce the angle between these two right here is the difference. 12 minus 12 from 20 is 8 degrees right here. And then now, as I said, using the Z angles and alternate angles, angle up here is 12 degrees as well, right here. And the angle up here is 20 degrees. This way. All right. What else did they see? They said the distance between the two ships is 110 meters. That's this distance down here, 110 meters. Let's put on the diagram. So right here between the two ships is 110 meters. So based on that information, we can only work in this triangle right now. Because we only have an angle in this triangle, we don't have any distance. So we can only work in this triangle, and if we're going to work in that triangle, we have to use sine rule or cosine rule. In this case, we are able to use a sine rule because we have an angle and a side in the triangle that are opposite to each other, where we know both of them. And once you have that, you can use sine rule. Once you have an angle and a side in a triangle, opposite each other, you know the angle and you know the side, you can use sine rule. And so we can use this angle, for example, with this side over here to find this side over here, which is what the first question is asking us to do. So you see, if you notice, I populate the diagram with all the information. Put on all the information you can on the diagram from the word. Everything that I don't tell you about, like the 8 degrees. Once you know something, put it on the diagram. They didn't give me this angle down here of 12. Put it on there because you know that the angle of depression from the top looking down equal the angle of elevation from the bottom looking up. Put them on the diagram. Put on the distance there. Because when they are on the diagram, you will see how to use them to get what you want. You get me? Don't leave all the information in the word in no place. Populate the diagram. Question said, determine to the nearest meter the distance TS2, that is this distance right here. And so we're going to use sine rule as I said. This angle with this side, and then this as my known pair. Sine rule we're going to use. Let's do it. Sine rule. So we're using sine rule. And it's going to be the unknown side that we're trying to find over sine of an angle opposite to it. That is the TS2 over sine of the angle, which is 12 degrees, equal the side that we know, which is the 110, over sine of the angle opposite to the 110, which is the 8. You see the 8 had to be put in on the diagram. 8 degrees. And then to make this the subject now, we're going to take this sine of 12 and multiply it up here. We must always put it behind the multiplying constant. Don't put it in front. The calculator will get confused. All right. So take this and multiply it behind that 110. Put it behind. So it's going to be that the TS2 becomes 110 times the sine of 12 divided by the sine of 8 degrees. And then put this in the calculator. What you get? Anybody did it? 270 point something. Let's put 203 significant figures good enough. 270 meters. That is it. And then again, as you find it, put it on the diagram. As you calculate something, put it on the diagram so you see how you use it. So that length is 210. So I'm going to put on the diagram up here. This is now 210 meters right here. Put on a different color. This is 270, we say? 270. 270 meters. That's this length right here. Now that we know that length, we can now work in that right angle triangle. Right? This becomes the hypotenuse in that triangle. We can find this or this if we want. Because we have an angle in there as 20 as well. And that, again, that's why it was so important to transfer that 20 degrees inside the triangle. So we can use it. The next part wants us to calculate the height of the lighthouse over here. The height of the lighthouse. So basically, we're going to just work in this triangle. With this angle, the lighthouse is the opposite side, and this 270 is the hypotenuse. Opposite and hypotenuse are connected with the sine of an angle trigonometry. So when I say the sine of 20 degrees equal the opposite side, which is the lighthouse TB, over the adjacent side of 270. Find the TB, you take the 270 and multiply it up here in front of this. So we're going to get the TB equals 270 times the sine of 20 degrees. Put that in the calculator and write the answer. TB equals what? What is it? Who did it? Nobody ever did it. So we're going to get the 270. Huh? 56? 56 meters. That's it. Question done. All right, guys, we're going to take a 15 minutes break off this now and go on to number 8. Number 8 is like the functions and so on. So you tell me the question you want me to do now. You tell me the questions I want me to do. I have done choosing questions for you. 15 minutes break and I will start back. Fifteen minutes means 15 minutes, please. Huh? Not yet, well. Hey, what do I want inside the park? What the fuck gonna do now? What do I go over there for? Huh? Yes, January 2020. Did you want it?
Don't want it.
Somebody else have January 2020 question here. It will.
Oh, yeah.
Oh. Some of the equation that you pet people.
Oh, I don't ever mean asking about my arts, obviously one more after one before the native.
No. More people need math. More people need maths. These are the big ones of the
Maybe close, it's 1502. 1502, because.
Come on, sit down up here. Sit down there.
Sit there if you're gonna go on, 10 seconds, please.
Well, sit down. Close the door, close the door, close the door. All right, guys, ready? All right, so I'm gonna put up the first question on the screen here. Don't need 10 minutes for this now. I'm gonna put up 7 minutes for it. This question right here. Simultaneous equation. See there? 7 minutes to do it. Come on. One a line and one's a curve. Have you used the substitution method, eh? Oh, this is 2020 January. Yeah, do it. Don't tell me, do it. Solve them simultaneously. This one's a curve, one's a line, and one's a curve. Use the substitution method. Let me see, Miss. Who asked me for this question? Who asked me for this question? Which part of the question you want? This part? Oh, one. Try it. Just this part, right? Just this part of this question. Other person who wanted number 8, they need to get it from now. Start getting the number 8. That's what I want me to explain. Hello. If not, stay there and don't do no work. No, you can go home now. No, feel like I keep my class come on. Yeah, my no for true. What was asking for that question? Number 8. 24. Miss not doing any work enough. Lisa needs to do your work. Forty seconds. All right, guys, let's do this. So it's having these two equations simultaneously. This one is a curve and that one is a line. Remember, at the point when you solve them simultaneously, you're trying to find the point on the curve where they intersect each other. All right, that's what you're basically trying to do. You're trying to find a point where they intersect each other. And the points where they intersect each other, the x and the y values are the same, they're equal. So to solve the equation simultaneously, that's what you can do. You can equate the x values, equate the x, or you can equate the y. But in this case, it is easier to equate the x. So you make this, the line is saying x is equal to this. And you can use it and substitute for the x in the curve equation right there. That's a quick way to establish an equation in one of the variables, one of the unknowns. Two unknowns is x and y. You want to establish an equation with just one of the unknowns. You can get an equation with x alone and get an equation with y alone. You can use an elimination method, you can use a substitution method. Generally speaking, when you have a line and a curve situation, oftentimes it is better to use a substitution method. So because the x is equal to this, it is easy to substitute for the x in the curve there. Remember now, at the point of intersection, the x value on the line and on the curve is the same. All right? So we're gonna make that substitution and then proceed, and that will eliminate the x for us and give us an equation in y alone. All that means here is that we're gonna be finding the y values first. All right? So we're gonna solve for x. So make that substitution, we're gonna get y squared plus 2y plus 11 equals, and this x becomes this, 5 minus 3y. That becomes a quadratic equation in y, meaning y is a variable. But to solve your quadratic equation, you want to get 0 alone on the right side. So you can use one of the methods with a factorization of the quadratic formula. So we need to transpose this over here and consolidate them with these values. All right. So I'm going to get y squared. This is only y squared in there. This minus 3y is going to come over here and add to this 2y. It's going to become a plus 2y. Plus 2y plus 3y give me 5y. And then this 5 is going to come over here and subtract from the 11. Minus 11. 11 minus 5, which is 6. Equals 0. Then no, this is easy to factorize, because the only factors of the y squared is y and y. They want factors of the 6 that add to 5. Or no, is add a 1 and 2 is a plus. Meaning that you want factors of the 6 that add to 5. You don't have to go to the lengthy process of factorizing these. So I'm going to factorize them like this. Y and y are the only factors of y squared. Factors of 6 that add to 5 is clearly 2 and 3. 2 and 3. Signs are the same. They are both positive. Positive here, positive here. You want to check it and make sure, remember, that this times this gives me the y squared. The second value times the second value gives me the 6. Now this 5x, 5y inside is obtained by multiplying the far product and the near product and adding them. The far product is 3y. The near product is 2y. They add to this 5y. So you know you factorize it properly. And that's all equal to 0. Then now, if the product of these two things is 0, then either this bracketed term equal to 0, or this bracketed term is equal to 0. Now, if this one is equal to 0, then you go take the 2 and transpose, it becomes a negative 2, and you'll be left with y equals negative 2. Or if this is the one that is equal to 0, then you will transpose this positive 3 and become negative 3. And so y is equal to negative 3. So those are the two y values you're not done yet. You have to find the x value to go with this and the x value to go with that. And you do that by substituting them in the easier equation, which is this one. That will give the x value easier than the top one. Both of them would work, but I want to do it the easiest way possible. So I'm going to substitute in that x equals 5 minus 3y. Sub into x equals 5 minus 3y in order to find the x values. All right. So first, this one. When y equals negative 2, the x becomes 5 minus 3 times negative 2. This minus minus becomes a plus 6. Plus 6. Minus 3 times minus 2 is plus 6. 6 and 5 makes 11. So x equals 11. So it means that one point has this x value. I have to put it first in the bracket. If you can get the y value first, you still have to put the x value first in the bracket. And this is the y value then, minus 2. The second pair is where y equals minus 3. Our second value is where y equals minus 3. At y equals minus 3, the x becomes equal to y. You plug the minus 3 inside here. And it becomes 5 minus 3 times negative 3. That's a positive 9 minus 3 times minus 3, a positive 9, 9 and 5 make 14. So the x is equal to 14 at that point. And so you have the second point, 14, the x value goes in the bracket first, and minus 3, the y value goes in the bracket second. So those are your answers right there. These two. This one is a point and that one is a point. 2 points. Intersection between the line and the curve. But I got it that. All right. So somebody said, yes? Have a question online?
No, sir.
All right. So somebody online said they wanted to do number 8 and the 2024. I don't know if the whole question person is there who want the number 8 is the whole question. They want part of it, which part of it they wanted. Person online who wanted number 8. Number 8 and to January 2024. See it here on the screen. So there's a part A, which is coordinate geometry. Then there's a part B, which is quadratics. That's it, a part A and a part B. All right, let's do both of them. January 2024. Recent exam. Let's do the part A first. Give you I don't think you need 10 minutes, but anyway. January 2024. And let's bring it up again over here. January 2024. Where are you, January 2024? All right, so giving you doing the part A first. I want to give you 10 minutes to do this. So the first page. This is the second page. All right. So this is it. Page 1 and page 2. All right. All right, guys, I'm going to start the clock now. I don't think you need 10 minutes to do this, you know. I give you 8 minutes. Come on. 8 minutes to do this question. 8 minutes to the part A. So the question there. All right, 8 minutes. Come on. That's part A. January 2024. You can look at them. A simple coordinate geometry question. Simple coordinate geometry. Paper in the group, you know, you can search for the paper in the group. Search for 2024 SC. 10 seconds to go. Want another minute? Want another minute? Huh? All right. Don't want no more minutes. All right, let's go. Ready, Malik? Question says, diagram below shows the graphs of two functions on a pair of axes. The lines G and H are perpendicular. So once they are perpendicular, it means that they have negative reciprocal gradients. Gradient of one is the negative reciprocal of the other one. Or the product of a gradient is -1. So if you know one gradient, you can find the other one. All right? Note these points. This is at -6 on the x-axis. This is at 3 on the y-axis. This is actually a y-axis intercept right here. So this is a C value on this line. This is a point on this x-axis. That point is 40 on the x-axis. All right? Question said determine the equation of line G, which is this one. To find the equation of any line, you want to know two things about it. The gradient and a point. If that point is the y-axis intercept, even better, because then you just use y equals mx plus c. So since we want the equation of this line, we know this is going to help us because that is a c. The next thing we want is the gradient. And since we have these points, we can actually calculate the gradient, but we can also just count out the gradient. Remember, gradient is just rise over run between 2 points going from left to right along the line. Just count the rise and count the run between these 2 points and you have the gradient. Let's set it up. So to go from this point to this point, I would have to rise by 3 units like this, because up here is 3, you know. So I would have to rise 3 units. Then from -6 over here, to reach this point, I would have to run 6 units this way. So I'm running, I'm rising 3, and I'm running 6. And so the gradient of line G, let's write that better. The gradient of line G is this rise over this run. It's 3/6, which is a half. Remember also that the C value on G right there is 3. So half of this line G, the C is equal to 3, that's a y-axis intercept. And the gradient of line G now is half. And once you know those two things, equation good. It is y equals mx plus c. And so it becomes y equals, the gradient is a half, so you get half x. And the c is 3 plus 3. That's the equation of that line. You have to calculate nothing, as everything is on the graph. I like coordinate geometry questions where they give you the graph, because you can count off stuff on it. Count off the gradient, see the y-axis intercept, and so on. When they give you on graph paper. So you get a coordinate geometry on graph paper, you're blessed. A lot of the time you don't have to calculate anything. Just count off. Count off the rise, count off the run. Remember, the rise is negative. The rise is negative, then if the line slopes down, then the rise is negative. So for example, if the line was like this, if one of the lines was like this, you want to measure the gradient from left to right. So you're going from a point on here to a point down here, for example. So it means that you'd have to come down. That's a negative rise. So if I, for example, if that is 3 down, it will be -3. The rise will be -3. And then you run this way. That will be your run. And then suppose you run 4 units. And that gradient will be -3/4. Just like that. All right? If you had a negative sloping line like that one. But anyway, back to this one. So the equation becomes that. The next part is over on the screen over here, which tells us to get the equation of line H. So same thing again. To find the equation of line H, you need to know two things about line H. You need a gradient and a point. The point is the y-axis intercept, then that is your C. The point is not the y-axis intercept, then we have to use what we call the point gradient form for the equation of a line. So now, since line H is perpendicular to line G, we know, let's write it out. Remember now, we need a gradient and a point. The gradient of line H is -1 over the gradient of line G. The gradient of line G, we just work it out as a half. This calculation is done by flipping this one and changing the sign. That's a quick way to do that calculation. Let me write it out here. When you want to calculate a perpendicular gradient from one that you have already, you flip the one that you have and change the sign. See there? Flip the one that you have and change the sign. That's how we do this negative reciprocal calculation quickly. Flip and change the sign. When I say the sign, I mean positive or negative. The two lines are perpendicular. One gradient will be positive and the other one will be negative. If they are perpendicular. That's how we change the sign. And so, gradient of line G, line H then. We take this and flip it and then change the sign, that will become -2. Because first it's going to become 2 over 1 when you flip it. And then change the sign from positive to a negative. That becomes -2 over 1, which is -2. So the gradient of a perpendicular line is -2. Then a point that it passes through this point, see here? That point is 4, 0. Because it is on the x-axis, the x value is 4 and the y value is 0. I'm going to use that point. Since this point is P, let's call this one Q. Let's call that point Q. So I'm going to be using the point Q, 4, 0. Using this gradient and this point to get the equation of line G. Then we're using what we call the point gradient form for the equation of a line. It's not only y equals mx plus c. You can use y equals mx plus c here as well. We don't have to. We can use a point gradient form, which is this. Y minus the y value at the point that we know. The point that we know is Q. Equals the gradient of the line that we want. Gradient of H. Into x minus the x value at the point, which is Q. That will give us the equation of the line straight. So it is y minus the y value at the point is 0. So it becomes y minus 0. Equals the gradient is this -2 right here that we want. -2 into x minus the x value at the point that we know is 4. That gives you the equation. This is y minus 0, which remains y. It's -2 times this x is -2x. It's -2 times -4, give me a +8. So that is the equation of line H. Done. Just like that. The last part says we have to calculate the coordinates of P. Show all working. If you look at the diagram here, P is the point of intersection of the G and the H. So to find P, you have to solve those two equations simultaneously to find the coordinates of P. Because P is the point of intersection of the two lines. So we can see something like this. At P, the two lines, the two equations are valid at P. Two equations work at the point P. P is on both lines. The first line we got was half x plus 3. Y is equal to half x plus 3 at the point P. And also y is equal to this at P. Y is also equal to -2x plus 8. Because P is a point on both lines. So P satisfies both equations. When we solve these two equations simultaneously, we will get coordinates for P. So since y is equal to this, and y is also equal to this, we can equate them. Just equate this to this. So we can say, therefore, the half x plus 3 is equal to -2x plus 8. Just equate them. If we have the fraction, we can multiply 2 by a 2. I was solving this now. Multiply 2 by a 2 to get rid of this fraction right here to simplify it. Multiply this by the 2, I get x. Multiply this by the 2, I get 6. Multiply this by 2, I get negative 4x. Multiply this by 2, we get 16. Consolidate, take this 4x and bring it over here and add to that x, we get 5x. Take this 6 and bring it over here, subtract from the 16, we get 10. If 5x equals 10, divided by the 5, the x equals 2. We're not done yet. We have to find the y value as well. Take that value of 2 and substitute it in the equation right there, for example. With a half of 2 equals 1, 1 plus 3 is 4, so the y value is 4. Or if you substitute it in this one, you're going to get minus 2 times 2 is negative 4. Negative 4 plus 8 is still 4. So anyway you want to look at it, the y is going to be equal to 4. So we can say x equals 2 and the y equals half of 2. That's when I plug it in this one, plus 3, which is equal to 4. And so this is the x value at P, this is the y value at P, and therefore P has coordinates 2, 4. And that is it. Very good at that. Nice and easy. Very good. All right, let's do the next part now, part B. And the person does a question 8. I'm going to just do all of it. So now the part B for me now. Part B now, which is a quadratics, and they want you to sketch a graph and thing right here. Simple as that. So we're gonna sit here. This is the question for part B. Oh, okay, so let's start. All right, I need a two side. So this part of it, and then the second part is for you to sketch a graph. And then right there, equation of axis of symmetry. All right, you need 8 minutes for this one. Don't need 10 minutes for sure. Come on, guys. Don't need 10 minutes for this. God no. I know I don't need 10 minutes for this. I know it. Hold on, I'm giving out something, man. Oh, that is it. That's all. Right, that's in that form. And sketch a graph. And that is the graph on the right side of the screen. And then down you must state the axis of symmetry. And then the question done, right? All right, let me start the clock now. Come on. You don't need more than 8 minutes. Start. 8 minutes to do that. Come on. 8 minutes. Now I start. All right, 8 minutes. Go. 8 minutes. Come on. Do it, do it, do it. Complete the square up there, right in the vertex form. And then sketch a graph. And then state the axis of symmetry. Easy question. Come on. Easy like cheese. Soft with a capital T. That one. Yeah, one paper for your brother. Yeah? I guess you take your paper for your tomorrow. Do some work. Here's some soft with it so you can relax. Sure. What's up? Relax. Am I right, man? Over my speaker. Come on, it's all right. I'm gonna start. Flap up early. Come on. Okay, go on, sit down. I'm good. Not connecting. Sure. All right, ready. Let's do this. Everybody finish? I want another minute. One minute. Athena, script by it. All right. Let's go. So there are many ways to complete the square, right? That's what this is, completing the square, going from this to this. When I teach add maths, I teach this a different way than I do in CSEC. The method I teach in CSEC is based on the subsequent questions that are always asked. All right, that's why I do it the way that I do it in this class. Now, most teachers, a lot of teachers that teach calculating the H using a formula B over 2A and calculating the K using the same thing, 4AC minus B squared divided by 4A. With A, let me understand the coefficients of this. All right. But when they calculate the H that way, then the vertex point is minus HK. And the axis of symmetry becomes X equals minus H and stuff like that. So to avoid having to make those adjustments, and also another reason why I do it the way I do it, because I've seen questions where they actually put a minus in here on the question. And so if you calculate the H, same way as you normally do, B over 2A, and don't change that minus, you run into problems. Get me? And sometimes as well, they will give you the function, for example, in the form A into X plus P squared plus Q. Sometimes they change it up, and sometimes they put the Q in front, like they might give you a B C plus A into X plus B squared. All kind of different ways they present. They present this same expression. This same expression. They present this in multiple different ways. So because I keep presenting that in multiple different ways all the time, we just use one standard way of doing it here, regardless of how they present it. We use A into X minus XT squared plus YT. Note I put a minus. The XT is the X value at the turning point. The YT is the Y value at the turning point. T means turning point. All right? And oftentimes with this question, the part B and the part C, and the part 2 and the part 3, they're always asking you values relating to these, questions relating to those values. That's why we use this method in this program. All right? So in that case, the XT is minus B over 2A. Note, it's not B over 2A anymore. It's a minus because I have a minus on mine. Using the H, because it's a plus, it will just stay B over 2A. Note the difference. And the B now is the A, the B, and the C comes from the standard form. So if you look at it, the A is the coefficient of the x squared, which is a 4. The B is the coefficient of the x, which is a negative 24, not just 24, negative 24. And the C is a constant term in expression, which is 31. All right? So those are the values we're using here. Now, this is going to work out to minus B, and the B is negative 24. So this is where a lot of people make mistake. They might put back those 24 here. But it's actually a minus negative 24. That minus becomes a plus divided by 2 times A. The A is this 4 right here. This reduces to positive 24 over 8, which then just becomes 3. When we get a whole number for your xt, a quick way of finding the yt without using the formula method is to plug this xt value back into the function where x is. I don't have to use the formula way to do it. Especially when the xt comes out to be a whole number. We can find the yt by the substituting xt. Remember now, xt and yt are the coordinates at the same point. So yt is the y value when the x value is xt. And so the yt value that I need for here would be equal to 4 times, I put in the x value here, which is 3, minus 24 times 3, plus 31. And work that out with the calculator. And somebody can tell me what they get. Somebody can tell me what they get for this yt value right here. All right, let me write it out. So it becomes 4 times 3 squared is 9. Can't be my fair myself in this. Minus 24 times 3 plus 31 equal. I'm getting negative 5. So this is the y value at the turning point. This is the x value at the turning point. This is the minimum value on the function, the lowest y value. I know it's minimum, but the A is positive. When the A is positive, the graph will have a minimum value at a minimum point, and the minimum value is the lowest y value on the graph. That point, that value occurs when x equals this x value, the xt value. So this function up here becomes, the answer becomes, the A is 4, x minus the xt right here is 3. Don't forget the square, and the plus yt is negative 5. So this in red is the answer right there. This expression becomes that when you write it in the vertex form. All right. Next part now says we have to sketch a graph. And when we sketch a graph, we have to indicate the maximum and minimum point. It's going to be a minimum, so we can cross out the word maximum. It's going to be a minimum. And we also have to put the y-axis intercept though. The y-axis intercept is the c value up here. That's 31. Because it's the point on the y-axis when x is 0. And put x equals 0 in this, you're gonna wipe out those two values and be left with 31. So that's a c value. And I also want us to put the minimum point. It's a minimum that we have. The minimum point is xt yt, which becomes 3 negative 5. That's the minimum point, 3 negative 5. And the graph is going to have a smile shape because, as I said, the A is positive. When the A is positive, the graph will have a smile shape and a minimum point. That's what we're sketching. So the question is, let's draw it in blue. Where would this minimum turning point be? It will be where the x value is positive and the y value is negative. Positive x and negative y is somewhere down here. So you know the graph turns somewhere down here. And then where is the y-axis intercept? This y-axis intercept, the 31 is positive. So you know that is somewhere up on the on the positive side of the y-axis. So you need a smile that crosses up here and turns down here. Remember, it's not to scale. That's what you want. Not to scale. I didn't put any scale on it, just a sketch you do it. See? A sketch. It's not to scale. Let me draw it in perfect. I'm just going to draw one. So this is it. That's it. So it crosses up here and turns down here. So this is the y-axis intercept. 0, 31. 0, 31. No price. And this is the minimum point. 3, -5. It's just a sketch. At the minimum point, 3, -5. I'm saying if this all the way up here is 31, then this down here is good enough for 5. All right, and that's a sketch. The question also asks us over here for the equation of the axis of symmetry. The axis of symmetry, remember now, is this. Let's put it in red. The line that passes through the vertex and is vertical, it divides the graph into 2 equal halves. It's like a mirror line in the middle of the graph. So it's vertical like this. And it is, the points are equidistant from that line. It's a line of symmetry on the graph. The equation of that line is always x equals whatever the xt value is. Xt value is 3. So it's actually x equals 3 is the equation of that red vertical line that passes through that point. So the answer down here is x equals 3. As simple as that. That's the equation of axis of symmetry. It's always x equals whatever the x value is at a turning point. That is always the axis of symmetry. That question done. Everybody good? Everybody good? All right. Talk to me. Which other question you want to do? Which number 8? Come on, give me a ear. Give me a ear. Somebody about 2019 first. 2019. Which one is 2019? January or January or May? Anyone? January 2019. Number 8. There we go. Right. Pose some question. All right, this question like a lot of parts, a lot of pages. Includes this question wants to complete that table and then draw this graph. Number of things I wanted to do now. Complete the table first, then draw the graph. Let me write the other things that they wanted to do over here. Let me write them over here. Next thing they want the minimum point, a maximum point rather. Let me write them over here. I'm leaving the graph on the screen. So part 3 You're gonna get the quadrant of maximum point. And you want the range, part 4. This is got a part 4, right? Right, part 3, you know what you want the range of x. All right, maximum point of f of x. Then I want the range. This is A, this is B. What else I want? Then part C, that's a nice question. I want the gradient at x equals 1. And that is it. We're not doing nothing later now. Linear programming. All right, that is it, guys. I'm giving you 10 minutes. 10 minutes. Never sketch a graph. No, no, wait for draw. No, just sketch it. So the graph that I give you, they wanted to plot the points. What do the calculation part mainly? I deal with the graph part. 10 minutes. Go. Oh, no work, no work, no work, no work, work. Come no work, no work, no work, no question now. So pull the table, sketch a graph, and then get the maximum point, the range for f of x greater than 0, and get that x equals 1. Come on. Easy question. Come on, 10 minutes. Yeah, we'll get the one stop dance. Huh? You don't know man. Every work no man I stop talking. Everything we're gonna do, we're gonna get distracted.
La vita con le fatture elettroniche. Prova Fatture in Cloud, il software di fatturazione semplice e veloce che ti aiuta a gestire la tua partita IVA comodamente da PC, smartphone o tablet e ti permette di far accedere il tuo commercialista alle fatture in tempo reale. Così puoi sentirlo sempre vicino, anche se siete lontani. Forfettario, vai su fattureincloud.it e scopri l'offerta a te dedicata.
Huh? No. Someone must be down with it. But I hear that they didn't have to, I hear that they take to, by the mouth, come on, everybody have about 50. All right. Anyway, ready. I 15 seconds left. All right, guys, ready? Let's do this. All right. So the question wants us to complete this table, right? For this function. You can complete this table very easy. There's only 1 mark for it. Because remember, the values are symmetrical as a quadratic function. The values are symmetrical about a line of symmetry, the y values that is. Right? In particular, once the x values are in the same interval from point to point, which are all 1 unit apart, all of them 1 unit apart. And so these y values are going to be symmetrical about a line of symmetry. You actually do have to calculate everything. So I'm looking for some values that are the same in the table. See them here? 0, 0. The values are symmetrical outward from the axis of symmetry. And so it also can be inward towards the axis of symmetry. So because this is 0 right here, sorry. The value to the right of this is 0.5. That's outwards from the axis of symmetry. Then the value over here is also 0.5. So this is 0.5. No, I'm -5, sorry. -5. Then the value inward from 0 to this is 3. So the value inward from this to this is also 3. So I can populate the table without calculating anything using the symmetry of the values, just like that. But I'm going to still calculate them just to prove it to you that they are correct. All right? So for example, this one is where the x is -2. And so to get this y value, by calculation, you could plug the -2 in the function here for the x. And it would be 3 plus 2 times -2 minus -2 all squared. This is a -4, this is a 3, so this is 3, that becomes a -4, minus, this becomes a 4. That becomes 3 minus 8, which is -5. There it is, there you have it, -5. And then to prove this one, I could plug 2 now in this function. In that case, it will be 3 plus 2 times 2 minus 2 squared. It will be 3 plus 4. Then this will be a negative 4. But remember, I'm not squaring this negative enough. I'm only squaring the 2. And so it should be 0. And so 3 plus 0 is 3. See, that's a 3. So you can't calculate there, but if you pick up the symmetry of the values, then you can populate the table just to see it. Remember, the values are symmetrical. All right, so you see it. Nice and easy. The next part down here says we have to populate this graph, or draw this graph for the function. And what they have done, they have put on all the points on it, except these 2 that they didn't give us. All the points are on there. All right. So this point is negative 2, 5. So I can put it on there, negative 2, 5. Negative 2, negative 5. But I'm going to talk about the axis symmetry first. Over here. So what is going to be the axis symmetry right here? Right here is going to be a minimum point. Okay, I say these 2 x values, these 2 y values, coming from that, those 2 x values, it means that the axis is halfway between them, which is 1. Halfway between 0 and 2 is 1. So it means that this is a vertex right here. This is a vertex. The vertex is at a maximum or minimum. In this case, it's a maximum. Why is it maximum? Because the square term is negative. So that right there is your vertex, your turning point. That maximum turning point at 1 4. Some questions don't give you the turning point in the table. You have to work it out. This one did. All right. So I'm going to put on those points as I said, but I didn't give you. The minus 2, minus 5. Put on in red. Minus 2, minus 5 is all the way down here. See, it is right across from this one. The axis of symmetry would be at x equals 1. That's a symmetry. So everything is symmetrical about that line. All the points are symmetrical about the line x equals 1. Say 1 here, so that will be this vertical line here. If you notice, this 5, those 2 points are symmetrical about that line. All the values, all the points are symmetrical about that line. Where the y values same. Like for example, these 2 roots, same distance. All right. But I want us to put in for the negative 5 down here. That's 1 point. We now need to put in the 2, 3. 2, 3. So 3 here, so 2, 3 will be right here. Again, these 2 y values are symmetrical about this line. So they're the same distance from it. And then this point up here is your vertex point right here. I spoke about 1 4. That's your maximum turning point. And so those are all the points you're going to draw the graph through. Let me mark them out for you. The ones that were given and then the ones that we added. See them here? And down here as well. So you're drawing a smooth curve through those points. Let's draw it in blue. All right. So I'm going to let it turn up here. Let's come down through these points. And turn up here and come down through these points. That's my sketch. Just like that. All right? What is the one? The maximum point is clearly up here. No, the one, yeah, the maximum point, right? That's what it said. So the coordinates of the maximum point. It is the point up here, which is 1 4. 1 4, right up here. And saw it in the table. The marks for you. See there? 1, 4 is the maximum point. So this answer here is 1, 4. And this says now the range of values of x for which f of x is greater than 0. Range of values of x means that you want an interval of x values, or a range of x values, for which f of x is greater than 0. Now, f of x being greater than 0 simply means that your y values are greater than 0. You want to part of the graph where your y values, f of x is your y values, that are greater than 0, means above the x-axis. So it's actually, if you look at the graph, this inequality is referring to this part of the graph. Mark it out in a different color. It's referring to this part of the graph. Purple. Let's go for the purple. That is above the x-axis up here. That's what that inequality is referring to. And that part of the graph is obtained by x values that are between x value here and x value here. In other words, any x value inside here is going to give you a y value up there. See it? Giving you a y value up there. All x values in between here, in between this point and this point, will be giving you a positive y value. And so the function is greater than 0. The y values are greater than 0 when your x value is between these two. Between these two. Between this -1 and 3. That is the answer now. Your x value must be between -1 and 3 for you to get a positive y value. So the answer for this is that the x value has to be less than 3 or greater than -1. That is it. Now, suppose the inequality was instead less than f of x less than 0. I will put it equal, less than equal to 0. Suppose that was it. When this inequality will be talking about the part of the graph where the y values are less than equal to 0. But you then now be talking about this part of the graph down here, the y value is negative. And to get those negative y values, you'd have to go to the left of this root to get a negative y value down here. And you'd have to go to the right of this root to get a negative y value down here. So in this case, your x values will have to be greater than this x value, which is 3. But because the equal is on this inequality, including the equal. And over here, your x values, to get these negative y values, your x value would have to be to the left of this one, which means your x value would have to be less than or equal to -1. So that would be a solution. It would be x less than or equal to -1 or x greater than or equal to 3. If this is what they gave you instead of that. And if there was no equal on this that I gave you, then you just would put an equal on that in the answer. All right, so they could give you this as well. So this is the if it was this. And the reason why I'm putting two separate inequalities, guys, is because there's actually two separate range of values. Two separate range of values. And the fact is, you a value cannot be less than -1 and greater than 3 at the same time. So it's an or situation. Either you're less than -1 or greater than 3. In the first case that we did over here, this is an and situation. Because a value like 0, for example, is at the same time less than 3 and greater than -1. So this is an and situation. That's why we can put it as one inequality, one range of value, one interval of values. When it's between those two rows. All right. So that's why we can do that. So for this one, I can represent it as one interval. But if it was this they give you, you have to write two separate set of values. And that is it. What else I wanted? I wanted the gradient at x equals 1. Let's look at it. Now to get a gradient on a curve at a point at this level, you have to draw a tangent to the curve and find the gradient of the tangent. So basically trying to find now the gradient at x equals 1. Where on the graph is x equals 1? X is equal to 1 right at this point. Wow. Right at this point. That's where x equals 1. And a tangent at that point is going to be horizontal like this. If you draw a tangent there, it's going to be horizontal. You try to draw a tangent. If you want the gradient at x equals 2, like right here, you'd have to line up your ruler against it like so. Put your ruler against it like that. And then draw the tangent line. Like maybe like this. Against the ruler. You draw the tangent line. Youngsters, I'm going to run out of the class. I'm telling you, man, you're a clown. Right? And then you have to draw a tangent line and then find, for example, another point down here. And then use these 2 points to calculate the gradient. If they wanted the gradient at the point where x equals 2, for example. That's what you'd have to do. But this one only wanted it at x equals 1, which happens to be that turning point. Right up here. So the tangent on this line at this point would be a horizontal line. Like this. That would be the tangent at that point. Horizontal lines have a gradient of 0. So the gradient at that point is just 0. That is the answer, 0. The gradient of that tangent will be 0. But that's a horizontal tangent to that. The answer is just 0 this time. That finishes that question. I think I'm gonna break. Want to do this part B? This is a linear programming kind of a question. What time is it now? I want to catch by the time I'm breaking at 4 because it's 4 o'clock now. All right, we'll go break now. Anybody want any other question 8? Let me throw it out there. Anybody want any other question 8? Nobody? Nobody wants the question. If I'm breaking now for half an hour, it's 4 o'clock. We're catching back the time. But we did say in the original schedule, we're going to break at 4 o'clock. Now look here now. Okay, now, we're going to come back. It's decided if not do the class or not do the class. If not do the class, I'm going to go see. I'm going to go do my mountain. Alright? Because I'm here and I will participate. You just here. So if you don't know do the thing, just tell me just in the class and go. Let me know now. Alright? So we decided no matter what. You see one class where the people are serious and I think one of them in a joke I don't understand. But I'm confident. I'm going to have question I can do. No, false confidence. All right, half an hour. Starting back at 4:30. Any foolishness, I just anytime from here. I'll call off tomorrow, nobody with it. I don't have to do it. I do not have to do this. I do not have to do this. I don't have to do it. At all. I don't need to do it. I don't have to. Yeah, you guys, my youth. We was at the whole time, yeah. Anyway, we start back 4:30. Just gonna I didn't have that. You let me waste myself, honestly. You guys don't feel like I'm wasting my time. I'm over about one, and I'm going to yeah, I'm over and I'm going to
Ordering your favorite pizza at Domino's is as easy as that. Once you place your order, it goes directly to our main plan. Our pizza experts get to work creating your pizza with fresh ingredients. After just 6 minutes in the oven, your pizza is baked to perfection and ready for pickup or delivery. Seamless. From order to oven to you. Visit Domino's.com and place your order now.
Here's why holding your breath is the key to supercharging your health and increasing your lifespan. Okay, sounds crazy, right? But you've been told, don't hold your breath. It's bad. Well, what if I told you that that's completely wrong? Because the science shows that when you can hold your breath in various ways, you can do some pretty remarkable things in your body. Science now shows that controlled breath holding, meaning holding your breath in various ways, especially one which creates a positive stress response in the body by invoking a state of intermittent hypoxia, is one of the most powerful tools you can do every day. I'll tell you why. Because it stimulates nitric oxide, the miracle molecule in the body that has a plethora of different health benefits. And intermittent hypoxia means you create a brief period of less oxygen just for a short moment. And this makes your body think, oh, you're running out of oxygen. So what does it do? It makes you really efficient at using oxygen. So you need the least amount of oxygen to make the same amount of energy. So having less oxygen means the body adapts to a low oxygen environment. This simulates high altitude training, which has already been shown in numerous studies. People go up and down mountains to have remarkable health benefits. But people tend to use expensive machines to get these benefits, or go and find mountains to climb up and down. But what if I told you that just with your breath, you can do this in the comfy of your own home, free of charge, where with a sequence of breathing techniques, we can invoke this state of intermittent hypoxia that dramatically increases your fitness and stamina by rapidly increasing the amount of mitochondria, the energy, the battery packs of your cell, but also increases the number of red blood cells, the transporters of oxygen in the body, but also creates natural heart bypasses, which helps if you have any heart blockages, but can also help improve the blood flow to your brain, making you have more cognitive powers and better brain health. And what it also does is acts like a natural Viagra. So if you suffer from things like erectile dysfunction, that can resolve too, just with the power of intermittent hypoxia. And so much more benefits. Now, if you want to learn more about these benefits, I've got this amazing video for you. We go into this. There's so much more of the power of this breath. Now, the technique for doing this has been hidden up in the Himalayas. In fact, you have to climb up various levels of yogic training in ashrams to learn these secrets. But I want to tell you that you don't need to go and do that yourself, because I have done that hard work for you. I've gone and studied with yogis up there in those regions, and I've done the work with science that validates exactly what I'm saying. I put them together in this course. So go and check this out right now.
So I met Niraj in an abandoned fortress in Croatia at an underground party. Niraj was DJing, and picture this. You're at a party and you're listening to a DJ. You're probably drinking something. or popping some sort of pill. Niraj didn't have any of that. As he was DJing, Niraj gets everyone to stop on the dance floor, switches up the music, and has people breathe. They breathe in, they breathe out, they breathe in, and they breathe out. And people are going crazy because somehow, combining music with breath work, he's taking people to an altered state, a joyful, happy, and breathing compassion. They almost feel like they just came out of a deep spiritual experience. That's how it became a fan of Niraj Naik. Now, here's the story behind this man. Niraj Naik was a former pharmacist until one day Niraj was hit with a horrible disease. In his own words, he had to run to the toilet to poop blood 14 times a day. Doctors told him it was incurable and they would have to operate and remove his colon, which basically means having to have a bag attached to your stomach for the rest of your life. It is absolutely debilitating. Now, Niraj was about to resign to his fate until his mother, who is of Indian origin, told him about a speaker who was traveling through his country. And the speaker from India was teaching a concept called pranayama breathwork, an ancient Hindu tradition. Now, because Niraj had Indian roots, he decided, I'm going to check this out. He goes to this class and he gets dazzled by this methodology. He starts practicing it. In 4 months, he heals himself and his life goes back to normal. Now, he had a hobby. He dabbled in music. He was a part-time DJ. He noticed that breathwork works on cadences based on rhythms. There's a rhythm to which you breathe in and you breathe out. He starts composing music, combining it with breathwork, and this sets him off on a whole new field. He invents Soma breathwork that has become widely recognized as one of the top breathwork modalities in the planet. Niraj has now composed music with superhuman proponents of breath, like Wim Hof, with incredible musicians like Satori and Black Coffee, and he's created raving fans across the world, speaking on stages like Minecraft and TEDx. More so, tens of thousands of people have taken Niraj's Soma breathwork course and transformed their lives. And you're about to meet this remarkable man.
Back in 2010, I was diagnosed with autoimmune disease called colitis. It left me housebound for a single year. Many days I woke up wondering whether this was my last. So because all the treatments had stopped working, I'm left with 2 choices. 1, a guinea pig for a drug that hasn't been tested, or 2, have my collateral and poop in a costume. I'm only 30 years old. To hear this news is like the most depressing thing. You see, I went from being on top of the world, living and breathing my passion. I was a DJ, an entrepreneur, running some of the top club events in the UK for 7 years.
No. Ask somebody for a home. Huh? Ask somebody for a home. The canal is somebody for a home. Yes. Huh? I was asking. The number one was asking. The number. Sorry. So, play that file. From CSEC process. No, I so we don't have it. We don't want to have work in the environment to somewhere. No, you don't know. Where does come from? Huh? Where does come from? How much time? How do I pay for? Somebody I don't. Next week, I'm supposed to have some experiment. I'm not going to joke with all that. I joke, I don't know. The first problem is where this makes you somewhere like an outside. What are the statistics next? Further 30 minutes. Huh? Five. Number five, number five. What number six? Hold on, you sure? Let's start to add tomorrow. I thought the statistics was number six. I can't. Oh, number six, a measurement. Oh, tomorrow already. Let's switch it still. Oh, number five. Okay, well, I'm not gonna use it. Hmm? Oh, right. Taking to the cleaners. Taking to the cleaners today, man. Or number six is measurements. Number six is measurements. Can see the showing the statistics now. Under the measurements tomorrow. You want to drop down to number five. The statistics. It is. Number tomorrow. But is tomorrow supposed to be the number six, number 36, man?
You have to ask for it.
Why? No, it's tomorrow supposed to be the number five. 5, 4, 3, 2, and 1. No, that is one person.
It wouldn't hurt them. We're just gonna do it.
Yeah, but we don't schedule, what's the matter? We don't plan it already. So that's statistical only one.
Just to the subject.
Let me not pay attention anyway. Like it's not man.
Exactly. So you know how to buy a passport?
Huh? How much the number 5 from 2022? Jump down to number 5. Number 5. Number 5 and number 6. These are the deals. I'm stuck over there tomorrow. I'm going to start with number 6 tomorrow. The number 5 now, and number 8. Number 7. Number 5. And then number 6. 5 and 7. Huh? January. I wish you could now. Which one you want? I want June. I want January. 2022. All right. Then I'm going to know the program and I'll be just coming first. Just I got to keep you beginning. When it's been 2, Call them for 1 minute, 1 minute. It's time. Let's start now. Come on, girl. Let's see. It's time. Ah. Da, 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 da. Da, 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 da. Alrighty. Call them. I just sent the 2022 to the group. So people online can screenshot this. This is the first question on the screen. I'll do this question in 10 minutes. First part of it to complete the table. Screenshot it. We have part B. Right here. Talking about standard deviation. The next page. Here. Screenshot that page. Next page is to complete that graph. Screenshot this as well. And then I'm given 10 minutes to do it. Where? Say anything about the group. Huh? The phone charging over there? Here, buy this on charge. That's it. That's it, brother. That's it. But the first time I go 4 pages, we can't put the biography. I'm not working. Hey, ready. Yo, stop. Come on, start working, start working. Send the question in the group, because this question about 4 pages. I sent it in the group. June 2022. Huh? Send it in the group.
Is your laptop there?
The power bank.
Ordering your favorite pizza at Domino's is as easy as that. Once you place your order, it goes your way.
No, what the bathroom key? Check if somebody already. All right, guys. Let us do this question. Where you going? Where you go? You outside, eh? All right, let's go. Let's go. This question says, a nurse records the height 8 centimeters of each of 150 students in class A who was vaccinated. Table below shows information. All right. So we give it a range of values. These are like boundary values. Let's see where this one ends, this one starts back same place. All right. And you're good. And see. So this 100 does not belong to this group. The 100 belongs to this group. But don't worry about that. And then this is the frequency that must add up to 150. All right, so it must add up to 150 to 150 students. It says complete the table below and use information to calculate an estimate of the mean height of the students. Give the answer to one decimal place. So to estimate an estimation, because you don't know the actual height of the babies. So for example, the 4 babies in this group, you know 4 students in this group, thinking about babies, they measure between 60 and 80 centimeters. We don't know the actual measurement of them. So what you have to do is assume that all 4 of them measure the midpoint height in this group. That's the approach. And CSEC sometimes will ask you, why is this an estimated mean and not a true mean? And the simple reason is that you don't know the actual height of the babies. And you're taking the midpoint height as the height of all the babies in group 1, which is not true. It is not true that all the babies measure the midpoint height in any group. All right, but that's why you have this here. Now, this column is what I call a sum column. When you multiply the frequency by the score, the data. That's how we have estimated the sum of the height of all 150 students. So the sum of the height of all 150 students divided by the 150 students gives you the mean height. All right. So they have started for us. So the 4 students in this group, we assume that all of them have a height of 70, which is the midpoint here. And so they multiply this to get this figure over here. And so the trend continues. This times this, give it that. And then this time this, give it that. And now we're supposed to fill out this one. Now, we need to fill out this line here for the midpoint first. And you can look at the trend. He's increasing by 20. So naturally, the next one is going to increase by 20 to 130, which continues to increase by 20 to 150. You will notice that the upper boundary value is increasing by 20, the lower boundary value is increasing by 20, the class width is going to be 20 as well. So everything is going to be uniform by a width of 20. So the value right here is 20 on this, gives us 130. And then to get the value over here, we multiply these 2 to get this figure over here. Somebody can do that one for me? It's 67.
8,710.
8710. And then now we need a sum. We need a sum of the sum. Sum of that of all the students. It's the sum of effects. Go in here. You add up all of these values now. To get that value. Anybody did that? 2280 plus 1800 plus 3850 plus
I think 18,220. No?
You get what?
I think it's
1820.
220, I think. Yeah.
Good. This is the approximate height of all 150 students. Total height. All 150 students approximately. We divide that number by the number of students to get the mean height. That's what I want us to calculate here. So the mean height, which is with X bar, is equal to the sum of the sum divided by the sum of the frequency, the total number of students down here, which is 150, same as n, equals 150. So it's 18,320 divided by 150. That gives you the mean height, which is the average height of the students. Just keep marking an extra line. And you work that out.
122.1.
How much?
122.1.
All right, 122.1. Question says 1 decimal place for instructions. Right, so 122.1. You have to say centimeter to give the unit of the data. Is in centimeters. So you cannot just put 122.1. You have to put the unit of the data. All right, it's the mean height. Mean height is 122.1 centimeters. 3 marks for it. The question asks, so why is this an estimated mean and not the true mean? Same thing. You don't know the actual height of the students. And so what you did, you assume that all the students in a group measure the mean height, which is not true. And this is why this is just an estimate and not the true mean. All right. This part says, in class B, the mean height of the students is this. And the standard deviation is this. So this is class B, standard deviation, class B. For class A, the standard deviation is this. This is for class A. It says, using information provided and your response in A, comment on the distribution of the height of the students in class A and B. So this is you comparing the standard deviation, and it's not complicated. The higher the standard deviation is the wider the spread of the height of the students from their mean height. The smaller standard deviation is a comparative thing, right? You're comparing one with the next. The smaller one means that the height of the students in the group with the smaller one are more closely spread as compared to the one with the higher standard deviation. Standard deviation is a measure of spread from the mean height. You have to say from the mean height in your description. So it's simple. The one that with a higher value is more widely spread. So this one, because the standard deviation of this one is higher, group B students, the height of the group B students, more widely spread. This one is a larger value. So this one is more widely spread. More widely spread. Means that the heights are wider, more widely spread from the mean height. And because this one is smaller, if you're referencing this, you say more closely spread. More closely spread in compared to the students in class B. It's a comparison you're doing. This will be more closely spread or less widely spread, more closely spread. You're looking for terms like this.
Sir, what about clustered?
Huh?
What about clustered?
Clustered? What do you mean clustered?
Like closer together.
Yeah, if you want to use that, no problem. But these are the standard terminals that they use in these questions. Widely spread, closely spread. Those are the terms that you use. Keep it simple. Right? Those are the terminals that I use when you have this situation. Right? So just keep it simple, keep it standard.
Why?
Every subject have certain terminologies that I use. So in physics, there are certain terminologies that I use. In chemistry, same thing. In accounting, same thing. Mathematics have some terms that I use. That's just how it is. Statistics, there are certain terminologies that you use as well. All right. So you measure and spread dispersion, and you have to say from the mean height. So you can answer this using the class B as a reference, or you can use the class A as a reference for your statement. Right? It's only 1 mark for it, but you want to get the mark. So key thing you want to say, which one is more widely spread? You have to say from the mean height of the group. Even though they have 2 different mean heights, the spread is measured the standard deviation is measuring spread from the mean height. All right, so let's write out something. So we're going to reference B, because B is more widely spread. So we're going to say the height of the class B, I have a higher value now. Height of a class B students, stop talking please, are more
Widely spread.
widely spread. I have to say from their mean height. So if their spellers look wrong. As compared to the class A students. That's it. If you write, or you could write with A as a reference. If we say or, you're not going to write both of them in one or the other. If I'm referencing the A, then I'm going to say more closest spread. So I could say same thing I write, almost the same thing. Yeah? Heights.
You don't seem to understand.
Mute the mic, please. Mute the mic, please. Of the class students are more closely spread. And if standard deviation is less. You have to see again from their mean height. Standard deviation is measuring spread from mean height. Compared to the class B students. The one mark, guys. So I want to make sure you put in the key things. So the key things in the statement is if it is more, since it is less, it's a smaller standard deviation. This one is more closely spread and it is from the mean height. You have to put the statement in there. From the mean height. You're measuring spread from the mean height. You cannot just say it is more closely spread. I cannot just say it is more widely spread. You have to say from the mean height. Now I'll say it again. It's measuring spread from the mean height. When you calculate, you don't do it in CSEC. When you calculate standard deviation by calculation, the method involves calculating the mean. And you start to do some calculation to see all the other values. That's the difference between all the other values in a kind of way from the mean. So it's a comparison with the mean. That's what it is. A way of measuring how wide the data spread from the mean. So you have to say that. Please don't leave it out. All right. It's 1 mark. We want the 1 mark. We want it. Don't give it away. We want it. All right. That finishes that one. Next question says, the cumulative frequency table below, it says, complete it. Complete the cumulative frequency table below and use information to construct the cumulative frequency curve on page 19. So only this we need to fill out. So the top stuff. So that over there. Like that. Okay. Still on over there, right? All right. So figuring out this one and figuring out that one. So remember, the cumulative frequency column, remember, is a counting column. It's a counting column. You're counting the number of students you have total as you go from group to group. Count out the 100 students, right? So we have so far, say this total 24 year, and then you put in the next group of 35, say add the 35 to this, say adding these two to get the next value here. That becomes a 59. Keep chipping out. No, I wonder what happened. This is 59.
Yes, sir.
And then now, if you add the 59 to this, you're supposed to get the 126. They were adding the 126 to get to the 20 to get this figure. It's 146. And if you add the 4 to this to get the 150, so you know you're good with those figures. Everything consistent. All right, so we have completed the table and I want us to use it to draw the cumulative frequency curve. I'll complete the cumulative frequency curve, which I'm going to bring up over this side. Mute your mic, please. Mute your mic. Mute your mic. Mute your mic, please. All right, so this is the table right here. See the graph. All right. So started first. Remember, we're doing the cumulative frequency graph, right? You're either doing upper boundary values against cumulative frequency, because your graph is supposed to show you how many students measure less than or equal to any height. Why you draw that? Because that is the only information you can get from the graph. Why this thing keep chipping out? Right? That's the only information you can get from the data, sorry. I don't know the actual measurement of the height of the students. But you know, for example, that 4 students measure less than or equal to 80. You just don't know what they are. Right? These 4, I should say. You know, that total of 24 students measure less than or equal to 100 in total. I don't know the actual measurements. Why is this point down here so 0 on the graph? And I can ask you about this point down here. Why is this point down here at 0? But that would be the value before this one to be 60, put on in red. So that would have been 60. The value before this one would have been 60. Less than or equal to 60. But there's no data for that, so that is 0. Number of students here is 0. Remember, the data start at greater than 60, you know. So it means that there are no students who measure less than or equal to 60. And CSEC can ask you what this point means. They can ask you what is this point, what's the significance of this point when you bring the graph down to 0. Interpret that point in reference to the height of the baby, height of the student, and the number of students. Remember now, here, remember this graph is measuring less than or equal to height. That's another thing, you know. If you don't put it there, always remember that the graph either shows less than or less than or equal to. This one is less than or equal to because I'm seeing the data in here. It's a less than or equal to graph. So this graph is showing how many students measure less than or equal to any height. That's what this graph is showing. So this point is, come on, man. This point is 60, 0. Less than or equal to 60 students. Less than or equal to 60 centimeters, no student. That's what that means. Less than or equal to 60 centimeters, no student. So this point means that no student measure less than or equal to 60 centimeters. That's what this means. No student measure less than or equal to 60 centimeters. That's it. The data started at more than 60 right there. So no student measure 60 centimeters or less. The data started at greater than 60 right here. So that is true. So they can ask what this point means. No student measure less than or equal to 60 centimeters. That's what this point means. Because the point is 60, 0. Less than or equal to 60 centimeters, 0 students. All right. They didn't ask that in this question, but I'm just prepping you. But they can ask you something like that. All right. I want you to get it if they ask you. All right. So we need to put on these points now, guys. And it's only 2 points that's missing. That's for this one. All right, so we look at it now. This is 10. So remember now also that these are the 150 students up here. Let me remind you. These are the students down here who measure the short heights. These are the taller students at the top with the higher heights. Taller students at the top. The students are placed in ascending order from the shortest one down here to the tallest one at the top. That's how it is set out in ascending order. All right. And so we're looking for the scale. Let me go back to this now. So I'm saying that there are 5 of these intervals up to, so it's 10 by 5 means that each of those intervals is 2. 2 students. Put a mark on it so you don't forget. This represents 2 students. And then horizontally now, this is 20. Between 60 and 80 is 20 is the interval. 20 centimeters, and there are 10 lines there. So it's 20 divided by 10 again, that's 2. So each of these is 2. So this will be 62. This will be 62. I'm putting it there so I don't forget. Each of those intervals is 2. I want to make sure you read the graph carefully. Sometimes the X scale is different from the Y scale. All right, ready now. So looking for 120. The second part 120 is 59. 59 students. So see here, 120 is the 129 here. I'm looking for 59. This is 50. Remember, each of these lines is 2, get it exact. 52, 54, 56, 58, 59 is right in between here. Look at it good. That's where 59 is. So you come across on the graph until you reach the 120 line. And the 120 is going to be right here. That's where that point is. 59, 120, 59 is right here. All right? It's a 120 line. Yes. The next one is this. Let's say equal to 160, 146. Let's say equal to 160, 146. So the 160 line here, this line is the 160 line. This line we want to use. I'm looking out for 146. 146. Let's look at it. So 140 here, so 142, 144, 146 is this line. 146 is this line right here. It's clear where you can see it. It's 146. So the point you're talking about is right here. And those are now all your points. All right? These are your points. These are your points. Let me here. On the x-axis. And draw the smooth curve through the points, the O-give curve. Another name for the cumulative frequency curve is the OGIVE. OGIVE. That's the shape of the curve. That's an O-give shape. All right, so I'm gonna draw the smooth curve, must look like that S-looking thing. So you go like that. Da, 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 da. Da, 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 da. Let's do it again. Da, 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 da. Da, 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 da. Better. Good. Draw it. Practice to draw it and draw it. Nice. There are some little curve rulers I've used to use in the past. Put us line it up, but another time for that. 60, you get your mark if you just draw it. But don't put a straight line on it. Don't put a ruler on it. Don't draw no part of it with no ruler, no straight edge. No part of it is supposed to be straight. It's a curve. So don't put no ruler where you have a straight line and so, straight line there so, straight line there so, and straight line there so. And no, don't do that, please. It's a curve. It's a smooth curve. Draw the best smooth curve you can draw. Everything important. Don't put no ruler on it. It's a curve. No straight line segment must be there. Next part now says, estimate the median height of the students. No, remember now, these are the 150 students. The median height is approximately the height that the 75th student is less than or equal. So you're looking for the 75th student. Half of the 150. Remember, I know it's an estimate, you know, everything on this is estimation. So looking for the 75th student, come across, read out the height from the data, and it will say that 75 students are less than or equal to that height. That's a median height. Because 150, half of 150 is 75. The student in the middle, 75th student. All right. So you find the student up here. That's not the median, that's just the position of the median, the 75th student. So 70, 70 and 80 years old. So 75 is right in between here. So that is the position of Q2, position of the second quartile, which is the median. Read across on the graph, use your rule and draw a straight line over to the graph, right in between these two lines. Make sure you fall right in between these two lines till you reach the graph, and then now you use your ruler again and draw this down. I see the question say using your graph. So drawing these lines is how you show that you use your graph. All right? Don't just read it off. You have to show these lines on the graph. So the examiner will see how you use the graph. This is to know what the height is down here. That's 124. So right here is 120, 122, 124. So this is 124 centimeters. That's Q2. It's 124 centimeters. Don't just put 124, the height. All the measures of central tendency and all the measures of spread carry the same unit as the data. Data is in height, mean is in height, median is in height, mode is in height, quartiles are in height, the interquartile range is in height, semi-interquartile range is in height, range is in height, which is in centimeters. They are all heights. Centimeters we use for the height. All right. So this now we're gonna just write Q2, the median Q2 is equal to 124 centimeters. Done. Next question says, the probability that a student use the graph this one again. Now sometimes you can use a table even. Probability that a student chosen at random would be taller than 130. The graph is going to show you how many of them 130 or less. Wake up. Can't learn nothing while asleep. The graph is going to show you how many of them 130 or less. Especially until they get that grade one, the boy. So you want more. So the graph is going to show you who measure 130 or less. Remember that, less than equal to graph. You know. The rest of them measure more than the 130. So you come on the graph to find 130. 130 right, that's out. This is a 130. Thing to start chipping out the device. But like this part of it is okay. Phone is what is chipping out. Why? This right here says 130. I'm gonna put this the other way. And put this the other way. This thing over here. And draw this the other way. Then the 130 now. Let's do the purple for the 130 now. All right. Unstable. It's unstable. Back. Go back, right?
Yes, sir. Yes, sir.
All right. So come again. You want to know how many measure more than 130. 130 is right here, right? So the height of more than 130 is out here. You really want to know how many students measure that height out here. All right, so we'll come up on the graph. I'll put the graph. We'll get the table. No, I will do a 130 in the table. The thing just get the table all of a sudden. The phone. So we'll come up this line till reach a 130 and 30 to reach a graph. We'll kind of right there. Yeah, it's got very unstable, very unstable. That just gotten very unstable all of a sudden. What is wrong? What is wrong? All right, so coming up at 130, guys, it's going to show us how many students measure less than or equal to 130. The rest of them measure more than 130. You see there, 130 take us up to the graph right here, counting off the number of students over here now. So it looks like about right here, so. Looks like about there. But the answer might be a little bit different. You know? Not everybody going to draw the graph the exact same way. We have to just give the answer that you get. And that looks like 94. That's 94. So if 94 get less than or equal to 130, then the rest of them up the top up here measure more than 130. The rest of them at the top. Remember the graph is showing you how much measure less than 130, less than or equal to 130. So it's 94 measure less than or equal to 130. The question is asking for how many measure more, taller than 130. This means greater than 130 centimeters. Probably have getting on that. So it's these students at the top. 150 minus 94 is how much? How much is that? 150 minus 94 is what? 40, then minus that's what? 36?
56.
36. Huh?
36.
How much?
Wait, 56.
6.
Let me get 36. 56 of them at the top.
Yes, sir.
So this probability down here becomes 56 out of the 150. And reduce that to lowest.
Sir,
Yes?
would the 94 be for the you said for the 130, right?
94 is how many measure less than or equal to 130. See there, the 130 give me 94 on my graph. But your graph, somebody's graph might give them a figure near that, but not exactly that.
All right,
But
sir.
not everybody gonna have this blue graph the exact same way. You get me? Some person might be a little bit high up here, so some person might be a little bit low down here, so not everybody gonna draw the graph exactly the same. We just have to give the answer that you got. But the answer should be around the same place. I'm getting 56 over 150. You put as the lowest, reduce at the lowest terms. I'm getting 28 over 75. That's what I'm getting. That is it. Next question. We're done. Done. Very good. Very okay. I'm gonna put up the January 2022 now, because somebody asked for that one. January 2022. January 2022, I'll give it 10 minutes to do it. Let's bring up the January 2022. January 2022. Where are you? Grab it here. So, all right, let's try it another way. (2022) January. There you go. What am I have? Beautiful. 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 It's true. We are going this number thing you're doing. Anyway. My the measurements after this, number 6. Is the pattern question for tomorrow. Here we go. Here we go. So this one gave you a graph. You might have a screenshot. I sent it to the group as well, this one. See it here. They gave you the graph on that page. All right, give me the frequency curve and ask us this first question. Right here. How many students walk at most 1 kilometer? So that's usually this first question usually tells you if your graph is a less than to graph or a less than or equal to graph. What does at most mean? At most 1 meter. Means 1 meter or less. The graph is, it means less than or equal to 1 meter. So that is telling me that this is a less than or equal to graph. But they're asking me for a less than or equal to information from the graph. So it means that's still indicating to me that this graph gives you less than or equal to data. All right. That's it. So, and then now the next part is to do all these things. I'm going to have a screenshot it, guys. I'm going to have a screenshot it. So this is the graph. I sent it to the group. That's the first page. You're going to have a screenshot it, please. Then this is the second part of the question. This is part B over here. To get the median, the interquartile, the lower quartile, the interquartile range. And then answer this question down here. Answer this question down here. A student is shown that random, say, walk more than 1.5. That means greater than 1.5 kilometers. See? So the graph is going to tell you how many walk less than or equal to 1.5. It is the rest of them that walk. So this that also confirm that less than or equal to graph. All right. And then the next part down here is for us to estimate the mean. See? Estimate the mean. And start the table for us from it and estimate the mean. All right, that is it, guys. Come on. Screenshot this for me. Screenshot this. Students who are at home, screenshot it and do it. That's the graph on the left side. Part B is for you to do those things. The median, the lower quartile, interquartile range, and then probability that a student walk more than 1.5. Very similar to the question that we just did. And then down here again, to calculate the mean, estimate the mean, and start the data for you. Your time. I'm giving you 10 minutes to do it. 10 minutes. Start. Allow me to retire the class and discuss that. Come on, do it. 10 minutes. Do it. Hold up, for now. Wait me up after 10 minutes. All right. I'm able to pour on that yet. Hey, we get the 10 minutes in and get 3 more hours with that study, you know. The 10 minutes for one up, you know. What you have to do is don't fall into deep sleep. So like that, just fall off asleep because you wake up. Get 3 hours. If you make somebody wait, you can't wait yourself. But tell somebody, wake me up after 8 minutes, or wake me up after 10 minutes. You have to, hey, look here, don't leave no mess over there now. Work, you don't stop. Stop, don't work, man, work. Put it out, put again. So you see my reach. I reach, you know. Put it. I need I put it down. Got it, that. Got it. Let's go. Wow. Eh? Yeah, but so far, you know, so far, no, so far, the exam. So far now, you're gonna suffer on Friday. You're suffer now. Some people not come to paper them not using up. The writing paper them. Let me say not gonna work. I'll tell you, but some people not gonna work. Who on the iPad? You're supposed to have the question and them, what people do 10 minutes for the look. And I don't see anybody taking up any paper doing the work. Paper has not moved all morning. People at the same place all morning. Go on, work, let me see. June 2019. June 2019. Huh? This question is January 2022. Number 5. Statistics. Huh? Yeah, 120. 120 students. Okay, time up in I don't know question here. Yeah, do sir. Come here, go to 5 more minutes. Remember now, guys, on Friday, you're gonna have to do these questions all on your own. Not good enough to watch me do it. You can't learn nothing by watching me do it. You don't learn as much. Do it first, and then as when I do it now, you see where you go wrong if you go wrong. All these things you should be breezing through in all of you. You're breezing through all of this. We're going to 5 more minutes. Aaron, this one work now? You run this way, don't run this way. Where work then? Where fair work then? If a man should there do work, you know, youngster, if a man should there do a work. When you do your work, so paper up yourself. Come man, come get paper man and do your own work. Come. The man should there do a work and you come now and distract her. Come on, guys, man. We have to work with the program. Come on. Watching Sir solve the questions alone, not helping them. So no problem with this, no problem with that. because you're not putting pen to paper. And I've gone through all these questions already. All of them. Seriously, we do all of questions in class already multiple times. More than once. You should run through them questions like breeze. It's not a problem. But you guys don't do what I tell you, which is to redo all the examples that I do in class. So what should be familiar to you looks strange. But I'm going to do that now. Instead of looking at it, you girl. Stop talking to you. You want to just go to your business. Of course, nobody is down here. All mathematical principles can only be fully understood by solving many questions. You cannot fully understand anything in math if you don't do questions. You can understand math by watching somebody do it, or by somebody explaining it to you. But to understand math, you have to actually do questions, do it. Learn it to a point, and then you do. By doing, that is how you really learn math. And get to that thing. Not fully understand. Huh? You know, go on a group, you say it's a people in a group. Huh? You can't do not no project now, boss. You can't do not both. You can't do not both the quality project. Project are all. Let me get closer and sharper. See better. Use your device. Use your device. All right, time out. No, no. You're not learning nothing. Not learning a thing. Come here today, I'll probably the topic. Go back home next problem tomorrow. Same way. And now do what it takes. Next question says the frequency diagram below, cumulative frequency diagram below shows information about the distance d kilometers that each 120 students walk to school on a particular day. So again, these are the 100 students up here. That's the distance that they walk, less than or equal to. You don't know the actual distance that they walk. The ones who walk the short distance are the ones at the bottom. The ones who walk the longer distances are the ones at the top. They walk the longer distances. The data is in ascending order. How many students walk at most? At most means 1 kilometer is the most. So it's less than or equal to 1 kilometer asking. And that's what the graph shows. How many shows less, how many walk less than or equal to any distance. All you have to do is find the one, read it on the graph, read across, and see how many that is. No adjustment needed. People feel like they have to do some adjustment. No. The graph is showing you how many walk less than or equal to 1 kilometer. So you don't have to make no adjustment. But as usual, you make sure that you establish the scale first. Understand the scale of the graph first. In particular, you want to know what each of these little 1 millimeter lines is. What is that? This is 0.5 divided by 10 of these lines. That's 0.05. So it means that every 2 lines is 0.1. Each of these lines is 0.5. So 0.05, so each of the 2 lines is 0.1. You can check it and make sure. See here? This is 0.1, 0.1, 0.2, 0.3, 0.4. See there? 0.5. So I'm leaving that mark there to make me know that every 2 little millimeter there is 0.1. Then on the y-axis, see there, 20 students in an interval of 10 of these intervals. So it's 20 divided by 10 equals 2. So it means that each of these little millimeter lines is 2 students. I'm sure you can check it. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Establish the scale of the graph before you start to read from it. All right. So you want to know how many people walk less than equal to this distance? Simple. Come up on the graph. This line up here. And you have to use the graph. Show that you use the graph by drawing these lines on the graph with your ruler. That takes you up to here. See it nicely right in that point here. Read it across. Remember, this is 20, this is 30, 32, 34, 36. So that is 36 right there. 36. Answer is 36. No adjustment needed. 36 students. I'm just writing here that this means this. At most 1 kilometer means less than equal to 1 kilometer. 36 students walk less than equal to 1 kilometer. 36 students. Next part says, I'm going to leave the graph on the screen and answer it over here for you. They want the median. The median is the second or middle quartile, Q2. The position of the median is the 60th student because there are 120. The halfway mark of 120 students in ascending order is the 60th one. So you come and you find the 60th one, half of 120 is right here. That right there is the position of the second quartile median. Read it across on the graph. Get to that point, read this down. Remember, every 2 lines is 0.1. So this is 1, 1.1, 1.2. This is 1.3. Want to make sure continue. 1.4, 1.5. So yes, this is 1.3 right here. No mark it. So right here, Q2 is 1.3 kilometers. We can write over here so now. Q2 is 1.3 kilometers. That's the median. Then the one, the lower quartile. The lower quartile is in the position of the 25th percentile. A 1/4 position, 1/4 of the total students. 1/4 of 120 is 30. Or you could say it is the midway of this first 36 students. That's where the position of the Q1 is. The halfway mark of that first 60 students, half of the half. So the 30th student, all you want to do, 1/4 of 20 of 120, which is 30. So the 30th student is in the first quartile position right here. Right here is the 30th student. Right here is 30. That is not the Q1, you know, it's a position of Q1. Position of the first quartile. You know the measurement of that first quartile position. You come across on the graph. Until you reach a curve looking like right here to me. That one, right there. That is 0.5. Every line is 0.1, 0.5, 0.6, 0.7, 0.8, 0.9. Two more taking it to 1. So yes, that is 0.9. So this is Q1, 0.9 kilometers. That is it over here. Q1 is 0.9 kilometers. Then the interquartile range. Interquartile range is Q3 minus Q1. We know Q1 already. We have to go find Q3 now from the graph and then subtract the Q1 from it. So come up on the graph now for Q3. Q3 now is just 3 quarters of the 120 students. Or you could say it's a halfway mark between these, the halfway on the top, which is the 90th. If you want to calculate 3 quarters of 120 or 75% of 120, that's 90. So you're looking for the 90th student, which is right here. That's the 90th student. That is the position of the third quartile. That's just the position of the third quartile. You have to get the measurement for the third quartile. You come across on the graph. Right on that line there. Use your ruler and draw this line down. It's right down on this line. We have to put it on the graph to show the examiner that he used it. That looks like 1.55. Remember, this would be 1.6, right here, 1.6 right here. This right here says 1.6. And right here says 1.5. Halfway between 1.5 and 1.6 is 1.55 kilometers. That is Q3, 1.55. So this calculation over here, make this a little bit smaller. Becomes 1.55 minus 0.9. What that work out to? How much? 0.65
0.65
kilometers. That's the interquartile range. And after the semi-interquartile range, I will divide this now by 2. A semi in maths means half, like semicircle, half of a circle, for example. All right. Then now, come down here, and it says a student is chosen at random. What is the probability that the student walk more than 1.5? They want a student to walk greater than 1.5. Remember, the graph will show you how many walk 1.5 or less. So the rest of them above that now would have been the ones who walk more than 1.5. So just come on the graph, find a 1.5, say 1.5 here all the time. Let's use a purple for that one. So 1.5 here now. You come on the graph, it's going to tell you how many walks. Less than or equal to 1.5. Remember, it's less than or equal to graph. It's giving you less than or equal to information. That's a 1.5 line. Use the ruler and draw it up there on that line. Show the examiner what you did. Don't just read it off and don't show the examiner. Like it right in here. And you come and you read them across here, so now. Bam. Use the ruler and do it. Don't do it the fear and the lightning. That is 82, right? And one of these lines was 2? Yes, 82. So right here says 82. This is 82. So 82 students walk less than or equal to 1.5. 82. You don't want to walk less. You want the ones who walk more up here. That's what? How much is that? 38. That's 38 students at the top walk more than 1.5. So on a probability of getting one of those students. So it's 38 out of the 120. That's the probability. That's the answer.
It can further be reduced to 19/60.
19/60. Beautiful. Oh, some people get some answer right now. Nice. Yes? Huh? That's all right, but practice to give your probability as a fraction. Let's give it as a fraction. Can we put that a decimal? Sometimes the answer not exact. Right? You want to say how much out of how much. Get me? So leave that as a fraction. All right. Anything else on this question? I don't know. Want the mean, right? Want the mean no, right? So the question says, complete the table below and use information. This is one standard question. You know? Question has no sugar on it. You know? The question is straightforward. You know? There's no sugar on this question. No twist and turn on this question. This question is straightforward. Normal stuff to ask. Nothing special about it. Complete the table below and use information to calculate an estimate of the mean distance walked by the student. To calculate the mean. This is your sum column. F times X is your sum column. You see, we are summing the total distance walked by the 120 students. So you multiply these as usual to get this. You multiply these to get that. Multiply these to get that. Then we have to populate this now. So these are the midpoint values. What are they going up by? They're going up by 0.5. You see that? The lower limit going up by 0.5. The upper bound going up by 0.5. The lower bound going up by 0.5. The midpoint will also increase by 0.5. So 0.5 on this is what? 1.75. And add 0.5 to that, add 0.5 to that. No, we need to populate this now. How many students in these intervals? And we have to get it from the graph. We have to get it from the graph. So we need to know how many students is in the interval 1.5 to 2 to fit inside here, so 1.5 to 2 to fit inside here. Right? So see here now. What was the 1.5? The 1.5 just gave us 82, don't it? That's all. And let's put in what 2 give us now. 2. So 2 here, so this is the 2 line. So we're gonna put in for 2. This is the 2 line right here. And some students get less than the 2. Let me erase this. So 2 here, so now. All right, so like it come in between here, so. That's what 2 is giving us. Let's read what that is. 100, 110, 102, it's a 102, and it's a 104. So inside it's a 103. Yeah?
Sorry, mistake.
Yeah, 110, my mistake. Let's go again. It's a 110, yeah. This now 112. Oh, you guys bright. And this now 114. So inside is a 113. All right, good. 112. You know, check it still enough, guys. You know, check this total. Make sure that there's a 113, right? 113. So it means that this interval inside here is the difference between these two numbers now. This minus this. How much is that? What's that? What that up to? 130 minus 82 is how much?
31, sir.
31. So this is 31 inside here. And then now the interval up to this one up to 2.5. Let's just confirm it and see what is in here. Now, okay, I'll figure out this figure now by doing 150. Remember the total is 150. Add up all of these right now and subtract from 150 to get the figure for here. Somebody want to do that for me? Get the by calculation. I'm going to check it on the graph. Add up all of those and subtract from 150 for me. I could just check it on the graph and make sure everything is consistent. So it's add up all of these, Subtract from the 150 to get this figure right now. What is that? One again. And I'm going to check this interval on the graph to see if it matches that figure that we get by calculation. What you get? Huh? No, man, you want to know inside or so? Oh, you have the 180 minus 72. Add up all of these figures, add up all of these we have so far and subtract from the 150. No, 120, name 150.
Yeah,
120.
120.
It's 120 the total. How much you get?
115.
No, man, come again. Add up all of these and subtract from 120. 5.
Oh, 5, sir.
Let's check if this interval is really giving us 5 now on the graph. All right. So we already know up to the 2 is taking us up to 113. Let's see what the 2.5 takes us up to. See 2.5 line here. Hey, stop talking now. I'm not getting my mad. See 2.5 here. From right up to here. That is just 2 below the top mark, as you can see. See that? 2 below the 120. So this is 118. See? 118 minus 113 is this 5. So the calculation, I say the top part, no, the top interval is the 2 right here. All right? So you can accept that figure. And I realize recent times, CSEC did certain questions, we have to read these frequency values from the cumulative frequency curve. Just calculate the values in the intervals. The difference in the intervals, and that's your frequency for each root. So anyway, so that's the table now. Now that we have these values, we can just multiply these to get this. Somebody want to do that for me? I multiply these to get that. Somebody want to do that for me, please, and thank you. This times this. And this times that.
Yes, sir. The one there 52.5 and the other one 13.5
52.5
and 13.5.
13.5.
Yeah.
13.5.
One question.
Yes. They have
One
the
question.
sum of this.
Sir.
What you get for this?
Oh, 150, sir.
150. 150 flat.
Yes, sir.
And remember now, this is the sum of your frequency. The sum of F is 120. So the mean is this divided by this now, right? What you get? 152? What? For this one? Take that again for me, Anderson. 1.75.
Oh, sir, no, that wrong. Sorry.
All right. 54 points how much? 54.3. And then this total then is what? Add up all of those figures and tell me again.
Sir.
Yeah.
One question, sir. Me did get 30 and 6. That's why I did actually tell you that. You would have still right or wrong?
30 and 6. Yeah, man. 6, you will give you a marks to me.
All right.
If you got 30 and 6, they will give you a marks. Yeah, man.
That's why I did get it wrong.
Yeah, man. No worry about it. No worry about it. So I'm getting now, I'm getting 151.8. So this is 151.8 now. And so the mean is the mean is the sum of the sum divided by the sum of the frequency, which is the total number of students. So 151.8 over 120. And then we're
So, you know, so the 13.5 I got changed to, right?
Huh?
13.5 I got changed to 11.25.
Oh, this our change?
Yeah.
Oh my, if I use the wrong
Yeah.
figure,
Use my one. So I said that mistake. You can change to 11.25.
Oh, 11.25. All right, this figure is 11.25, guys.
Yes, sir.
11.25. So what is this total now then? What is that total now? What I mean, you guys in here don't do it. So somebody at home doing it. 140 what? And it's not home doing the work. It's not coming up when I do the work. He's at home getting serious. You guys here and joking. Remember that come from. Don't stay home like him. 1.25. Let's put 3 significant figures. 1.25. What's the unit of measure? You put the unit of measure. Kilometers, remember?
Kilometers, sir.
Yes. Put down here. 1.25 kilometers. That is it. Another question done. All right. So somebody said they wanted what, 2019? Yeah, January 1, June 2019. All right, let's go. See if there's any sugar on that one. June 29th. Let me see if there's no sugar on Instagram. June 2019. Here you go. Number 5. What time is it now? There you go. Now bring it up on the screen. June 2019, right?
Sir, I mean.
Yeah, man, May, June, same. May, June. Hey, stop talking now. All right, yeah, this is a nice question. Aha. That's a nice question. This one is a nice question. Yeah, this one have a little bit of sugar, a little bit. Just a little bit of sugar. A little bit of sugar, not too sweet, just a little bit. All right, see there? Give me that information. So the cumulative frequency distribution of the volume of petrol needed to fill tank of 150 vehicles is shown. No, they give you the cumulative frequency distribution, not the frequency distribution. They gave you the cumulative frequency distribution, not the frequency distribution. So if I were you, I would work out what the frequency distribution is before I start, so I can know what frequency is on each line. So you reverse the calculation. That's not a frequency distribution, it's a cumulative frequency distribution. So we normally get a frequency distribution, but this time they give us a cumulative frequency distribution. All right, so that's part 1. You're going to have to screenshot this again. So the first part wants you to do what? Get the lower boundary and the class width. Then part B says how many vehicles were recorded in the class interval 30 to 40. Then it says a vehicle is shown at random. What's the probability that the vehicle more than 150. No, more than 50.5 right here. Leave your answer as a fraction. See, I mean, see, the question says leave your answer as a fraction. Again. All right, screenshot that for me, please. Screenshot that one. And then the last part is this one. To draw the histogram. The last part is to draw histogram at the start with us. To draw the histogram, you need the frequency values. All right, 10 minutes. Ten minutes. It's the clock. Supposed to stop now, you know. No, 6:30 we're supposed to stop. 6:30. Supposed to stop what we're doing now at 6:30. All right. After that, all you need to do is draw the histogram after this. These are the questions, and then they want the histogram. So I'm making the question for the body gone out. I don't know. I think I'm one of the best. Yo, come on, I send a mission. I move you know, come. See us as a judge. We don't send the name for another. Don't come here. I'm ready for this. Papers already in the group now. All of these papers in the group. You know, it's my time come back on that. Yeah, man. I'm here down sleep. There's a jokers. How do they put this here? How do they put this here? You guys are not ready for this as yet. Wasting my time. You're wasting my time, man. Wasting my time. Wasting my time. Huh? No? Look, sure to do for the 2019 paper. I'm sure it's in there. Is it 2 minutes?
So would have finished what we can do the history.
Huh?
Would have finished what we can do the history.
You can't do it.
Yeah, wouldn't can do it because would have like a graph like that, like physically.
Sketch it out, no man. Let's sketch it out. Sketch it out. Sketch it out. Quickly, sketch it out. They started the vertical axis for you. Say let's put somebody on the vertical axis. You have to do the horizontal axis as well.
Okay, no.
No, no, hey. Nationalist have people who can't come out tomorrow. I do come on. Yeah, but I don't know. Serious. I don't know. Upset the spirit. Already. Can't teach good me upset, you know. Can't teach good me upset. I don't know. Anyway, question says cumulative frequency distribution of the volume of petrol needed to fill the tanks of 100 different vehicles shown below. And notice they give cumulative frequency. But how many examples come start with the thing and work out the frequency? Right? Because the frequency gives you information about each line. So I'm working on the frequency by subtracting these values. So I'm going to put a column right way to normal level, right inside the stuff for frequency. And divide it like that. And put in the frequency. So this should have been 24 normally, just to see. So what do you add to 24 to get the 59? So you have to subtract. 59 minus 24 is how much?
35.
25. Then what do you add to this to get this? Remember?
35.
To get this. 35.
35.
Foolish is not, I'm upset now. I'm telling you. 35. Is what do you add to this to get that? What
42.
add to this to get this? How much is that?
42.
And then what do you add to this to get this? Subtract. What is it? Now what do you add to this to get that?
21.
And this must add up back to the 150. The one here. So those are your frequency values now. That said, I'm ready to proceed. First question is for the class interval 21 to 30, which is this one. What is the lower boundary? The lower boundary is halfway between this and this, which is 20.5, 0.5 less than this. Remember, this class, let me point it out for you. This class will take values from 20.5 all the way up to 30.5. And in fact, it is greater than or equal to 20.5 because any value that is 20.5 or more will approximate to 21, which is where this starts, and less than 30.5. Why less than 30.5? Because if it approximates 30.5, 30.5 is approximately 31, which is in this group. So it has to be less than the 30.5. So these two values are your class boundaries. Those are the values between which a measurement can go in this group. All right? So the lower boundary for this group is this 20.5. The upper boundary is this 30.5. Generally speaking, it is 0.5 less than this, 0.5 more than that. When the difference between this and this is 1. All right, so the lower boundary is 20.5 and put the unit of measure on it just to see it. 20.5 liters. That's the lower boundary. Next part says, what is the class width? The class width is not 30 minus 21. It is the upper boundary minus the lower boundary, not the difference of the limits. Because remember, any value between these two values can fit into that group. That is why that is the class width. Class width is from 20.5 to 30.5. You can also know the class width by looking at all these lower limit increasing by 10. Upper limit, sorry, this lower limit also increasing by 10. That is telling me that the class width is 10. Because the data as usual is very symmetrical at this level. Right? But the class width, if you calculate it, is this minus this, which is 10. So it is the upper limit, upper boundary, sorry, minus the lower boundary, that is the class width. That is 10 liters. Don't give it away and put 9. 20 people going to 30 minus 21 and get 9. It's wrong. Next part says, how many vehicles were recorded in this group? That's a frequency, which we worked out already. 31 to 40. 42 vehicles. Good. So it's 42 right here. How many vehicles? 42. Next part. A vehicle is chosen at random from 150. What's the probability that the volume of petrol needed to fill the tank was more than 50.5 liters? More than 50.5. Difference and fraction. So you need to know how many vehicles was more than 50.5. Right? Now, this group starts at 50.5. See? This group ends at 50.5. So this group is from 50.5 up to less than 60.5. But the question asks us, how many was more than 50.5, right? More than 50.5. So 50.5 starts right here. See it here? Let's see it says, hold on. So that's greater than or equal to. Let's read it again. What's probably that the volume of petrol to fill a vehicle was more than 50.5. All right, I think that shows it's more than or equal. But they're talking about down here because remember now, this group is from 40.5 to less than 50.5. So if we're going to be more than 50.5, you have to be in this group. It's actually 50.5 or more. That kind of word question is is that right? But it's this group. So it's this 21 vehicle out of the 150. Right? 21 out of 150 is in this group. Because this way we start to get more than 50.5 right there. We should have been more than 50.5. But let's put it there still. So this one, 21 out of the 150. What are we going to?
Whether simplified to 7 over 50.
7 over 50. That is it. Next one. It says Byron estimated that the median amount of petrol is 43.5. The median is 43.5. Explain why it is incorrect. So what you have to do now, you're gonna have to find which group the median is in and see if this value is a value in that group. Huh? Well, right, as well? Probability. Yeah, the question is saying, must find a probability that a vehicle got more than 50.5. So more than 50.5 means that it's greater than 50.5. So if you look at the table down here, look at the table in terms of the values, right? You have to understand that the groups start from the lower boundary value to the upper boundary value, right? So if I were to write out the measurement that can go in this group, it will be 10.5 up to 20.5. This group will take 20.5 up to 30.5. This group is from 30.5 up to 40.5. It's actually up to less than 40.5. And this group is from 40.5 up to 50.5. Any measurement between here will fit in this group. So 50.5 starts right here. Starts in this group. So you want to know how many, so you say this group, you know, this part of it saying that you're greater than or equal to 50.5. That's liters. And then here now is less than 60.5. So no vehicle not take more than 60.5. But some vehicle take more than 50.5. How many of them? This 21, more than 50.5. Question is asked, you know, what's probably to find one of those 21 cars? This one is 21 out of 150. That's probability. So it's 21 out of 150. That's what we did here. 21 out of 150. That's 21 took more than the 50.5. Then here now, they estimated in the median. So what we have to do is look and see which group the median would have been. Right? And if there are 100 and how many? 150 vehicles, the median vehicle is about the 75th vehicle. You have to know which group the 75th vehicle would fall in. And the median is supposed to be a measurement within that range. So the median that he estimated is outside of that range, then that is what will make his estimate not correct. So the 75th says, as if you're trying to find where the median would have been. That's what you're trying to do. And the median would have been positioned where the 75th vehicle is positioned. All right? So remember, your cumulative frequency column is your counting column. You're counting the vehicles. When you reach right here, you have 29 vehicles. When you reach right here, you finish 59 vehicles. When you reach right here, you finish 101 vehicles. So it means that the 75th vehicle is inside here. So but understand that. When you finish 59 vehicles, when you reach here, so you know, when you finish this group, you finish 59 vehicles. And then when you finish this group, you go past 75 and reach 101. So the 75th vehicle is our vehicle in this group. Yes? You can, but when the data is group, you don't need to go there. You're estimating anyway. The plus one don't make no difference. Get me? That's not exact data. I tend to use the half n plus one for exact data. Once the data is group where you don't know the exact values, you're estimating. You don't need a plus one. But if you use it, you won't get the same thing still. But we just go to the 70, because if you were to put this on a cumulative frequency curve, just think of it. If you were to put this on a cumulative frequency curve, for the data is group, represent this in a lead from lowest value to highest value, you would have to put it on a cumulative frequency curve. When you put on a cumulative frequency curve and you want to find the median, where you go to half n. So the same thing here, sir. So this is where the 75th vehicle will be in this group. So the 75th vehicle is expected to have a measurement between 30 and 40, 31 and 40, or more precisely, between this and this. Between here. The 75th vehicle has to be a vehicle that took between 30.5 and 40.5. Between 30.5 inclusive up to less than 40.5. So your median is supposed to be a value in that range. So the median is out, the median that somebody suggests is outside of that range, then it is a value. Yes. And that's what happened. The person suggested the median. The person suggested the median to be 43 point something. Where is it? 43.5. 43.5 is in the group after that. See? 43.5 is in that group. The 75th peak is not in that group. You get me? That's why 43.5 is not a good estimate. All right? So this is the group. So this is the 1, 2, 3, 4 group. So I would say the 75th vehicle is in the group 31 to 40. 43 point something that the person estimated is not in that group. Therefore, it's not a good estimate on the median. I need to look at it. Get me something like that today. Let me write something for you. And I would leave this on my table. To make the examiner say that, okay, I'm indicating that on my table. So what I would write. You don't want 1 mark for it, but you want to write it properly and get the 1 mark. All right, so I would say something like the median amount was taken by approximately, everything is approximately, the 75th vehicle, which falls in the, which one again? 30, which one again? It falls in the 31 to 40 interval. It falls in the 31 to 40 liters interval, or class interval. This figure that the person estimate, 43.5 liters, is not in this interval and is therefore not the median. Good enough, you don't have to write exactly. Naturally, not going to write exactly that. Huh? Last. No, put it on. No. Huh? Where you are? Where you want me to explain that? Question ask you, how many vehicles measure more than 50.5 liters? Right? So the measurements you made on the table. These are the measurements on the table. You have to understand that, for example, this measurement in the table really is for this measurement. Anything between 50.5 and 60.5. So 50.5 clearly is in this group. More than 50.5. This group starts at 50.5 and ends at 60.5. So more than 50.5 must be a measurement inside here, so. Go it. How many vehicles in there, so? 21 of them. So 21 vehicles got more than 50.5. That's what they're asking. 21 out of the 150. Get me? So the probability of getting one of those 21 is 21 out of 150. Good? All right. So that is it. All right. Then there's a must draw the histogram on it. You have to realize that histogram is, it goes from boundary valley to boundary valley 1, and it's the class boundaries against the frequency for each group. And that's where you draw the histogram. Bars of the histogram go from boundary value to boundary value. There cannot be any space on the histogram. Get me? But they did not give us any scale on the horizontal to use. We have to figure out that scale. Right? I have to be smart about it. So the data starts at 10.5 and ends at 60.5. That's where your boundary is going, on the 0.5 marks. So I'm just going to go 10, 20, 30, 40, 50, 60. See, that will work on this graph. So let's go 10, 20, 10, 20, 30, 40, 50, 60. Good. 10, 20, 30, 40, 50, 60. That's my scale. I'm going to put liters here. That's the measurement, right? It's the amount of fuel in liters on the horizontal axis. Up here, they give it a frequency. Remember now, the bars have to go at the 0.5 marks. We're going to put for 10.5, 20.5, 30.5, 40.5. Put on the 0.5 marks. So this is 10, this is 11, 12, 13, 14, 15, and so on. So I'm putting the blue marks at the 0.5 where the bars of the histogram will go. So this is 10.5 right here. 20.5. 30.5, right in between those lines. If you don't put them there, you're going to get the question wrong and not get the marks for it. Those marks are where the bars will have to go on. Those are the 0.5 marks. 10.5, the 20.5, the 30.5, 40.5, 50.5, 60.5. The first bar has a frequency out. Let me just write down frequency values and then copy them down. Now those bars are going to go up to the frequency. These are the frequency values right here. Must copy them down. So I have them in front of me on the screen. Putting them here. So the first bar has a frequency of 24. First bar is on those blue lines. 24. So based on the scale, every one of these lines is 1, right? So 24 is right here. And you're on this bar. See the bar here? Use your ruler and draw it. Use your ruler and draw it. I like to put the number on top of 24. The next bar goes up to 35. The next bar goes up to 35. So 35 here. This line is 35. This one, the bars join side by side. So you just continue up here. And then you connect this bar down here, so now, this one. Or that boundary to say. And join them on top. That's it. So, the next is put the 35 up here. The next bar goes up to 42. 40 is the 42 here, so it's a 42. So I draw this up here. And the next bar is over here. Sit here, so right up here, so I'm coming down here. Use a ruler and draw it for me, please. Don't draw it friendly like me. And then join it about 42 up here, so. Next bar, the frequency is 28. So dropping down to 28. 28 is on this line right here. See the 28 line. So you're dropping down to this line. And you're joining this bar. So this is one end of that bar, that one boundary. And joining this one down here now. And then connecting them right here. I can erase that. That's it. Put the 28 up here. And then the next bar is 21. The last bar is 21. So 21, so look at 21. 21 is right on this line. That's my 21 line right here. And then one end of the bar is here. One boundary of the bar is here. And I'll connect it back with this. 21. Ta-da! That's the histogram. The bars of the histogram go from boundary value to boundary value. Boundary value to boundary value. If you don't put the values at the 0.5 marks, you're gonna lose a mark on this question. That is it. All right, finishing off this topic now. I'm gonna break for half an hour. I'm talking not half an hour. Started back at 7 o'clock. About 20 minutes. Maybe 7:25. All right, starting back with the measurements question. Number 6. We want to put the boundary by the ball. That's the key thing. I put the boundary by the boundary. You cannot draw it random. You have to put the boundary by the boundary by the. All right. Huh?
The first mission might cost
No, I will not decide. No, sir. I will not decide what we're doing. I mean, you guys tell me which question you want to do. 30 minutes. 25. Ready? There's the one. Ready? You guys lost my key. Somebody pick up the key and go and I said the key in the bathroom. Mess up. They lost the key. Huh? Good girl, good. But everything is recorded now, so you can still. Huh? You know what it. Well, it all depends on what you want. All depends on what you want. Stop if you want to. I'm not find the key, I'm not find the key. And the female no want to the bathroom, you need to go now. And the teacher was like, you want to leave soon. You want to the bathroom, go now. Come in, what I said. All right. Alright. The last part of it. Now, let's read that third. You go to sleep, huh? Go to sleep. But I'm going to run out some report and that. Over report I'm not doing.
Yes, sir, I have it in my book.
Five, 7 more? No, I might get one question. I was wondering, what to eat. 2018. You sure the people them the tune on that? But Samsung had like this like a quarter just look like it. All right, we're doing the measurements question now. Stop talking. Now starting back now. This question has 2 parts. Hey, start back, you know. Stop talking, please. Don't need more than 7 minutes for this question. On the street. Huh? Six minutes to that question there. A measurement question. $21 millimeters. Body finish. All right, see diagram, you find the circumference and the area. That's what you find. Area of the cross section of the disc. That's a square hole in the disc. Giving her 2 more minutes. All right. Time's up. Let's go. Question says, pi is 22/7, so you're doing some circular measures. But to get pi, you're doing some circular measures. It said the diagram below not drawn to scale shows the cross section of a circular metal disc. The radius is 21 millimeters. That's from here to the center, to the circumference. It says a square hole with side 6 centimeters is located at the center. That's a square hole. That's 6 by 6. So 6 millimeters, sorry. 6 millimeters. 6 millimeters all the way around. So it's a square. So the area of that thing will be 6 by 6 millimeters. It says well, to calculate the circumference of the disc. Circumference is 2 pi r. 2 pi r. R is 21. And the pi is 22/7. So this is just equal to 2 times 22/7 is the pi times the r is 21. That's going to give you the circumference in centimeters. What are we report to? 132.
32 millimeters square.
132.
132
Huh? Oh, millimeters. Thanks for that. Millimeters. Thanks. Millimeters. All right, good. All right. That finishes that part. 1 mark for that. Don't give it away, Mr. Shaw. Next part says we want the area in millimeters squared of the cross section. So remember now, there's a hole inside here. So you really want the area of this part around here. So you're gonna have to take the area of the circle and subtract the area of that square. But can I appreciate that? So the area of the cross section becomes the area of the circle, subtract the square hole.
Yo, the man has something important, brother.
Use the mic, please. So it becomes equal to the area of the circle minus the area of the square in the middle of it. Remember, it's a square hole. The area of the circle is pi r squared, as you know. The area of the square is going to be 6 times 6, or 6 squared, 6 times 6. So we have to calculate this area, which is 22/7 times the radius of the circle was 21. So that's 21 squared minus this 6 squared is 36. Where that out and answer is in millimeters squared. Anybody did that?
1,350.
How much?
1,350.
1350. Good. All right. The next part now says, given that the thickness of the disc is 2 millimeters, so like a coin, calculate the maximum number of discs that can be constructed from 1,000 cm cube of available material. And they're telling us here that 1 cm cube is 1,000 millimeters. So what we need to do is calculate the total volume that this is in millimeters, but we have to calculate the volume of one disc in millimeters cubed and then divide it out to see how many discs we can get. Remember, it says the maximum number of discs. They're talking about the completed discs. Right? So let me sketch it how this would look. So with the height of 2 centimeters. So we see it's like a cylinder. So like you have the circular section, and it's 2 millimeters thick. And then you have a square hole in it. So that's my square hole in it. And to show that it's a hole, I'm gonna draw behind here what you would see. That's a square hole. And I'm gonna shade here to show the thickness of it. All right? Just to show that that's a hole in it, and it's a square hole. And the thickness of it is 2 millimeters. I already know the cross-sectional area. Cross-sectional area, which is end area A, was this 1350. That's a cross-sectional area. Millimeter squared. So the volume of one disc is worked out in blue. The volume of a disc becomes the cross-sectional area times the height or the length, the distance between the two cross-sectional ends. This will be your L. This dimension right here. It's 2 millimeters. Cross-sectional area times that length gives you the volume of a disc. So it becomes 1350 times 2. That gives you the volume. What I work out to?
2,700.
So it's 2,700 millimeters cubed. So what we need to know is how much 1,000 cm cube is in millimeters cube. And it's an easy conversion. Because if 1 is 1,000, then 1,000 is 1,000,000. Understand that? And understand that? If 1 cm cube is 1,000 millimeters cube, then 1,000 cm cube is 1,000,000. Make sense? Right? What you can do then is take this ratio, treat it like a ratio, make this side become 1,000. If this side is going to become 1,000, by multiply it by 1,000, you multiply this side by 1,000 as well. So if you take this relationship and multiply it by 1,000, multiply this relationship by 1,000, in order to make this side become the 1,000 cm cube that you want to see. Then when this side becomes 1,000 cm cube, then this side multiply by 1,000 as well. So you get 1,000, 1,000, which is a million. Millimeters cube. So this is the amount of millimeters cube. You want to know how much of this is in it. And this is one disc. Right? So you have to divide this total volume of material by the volume of one disc to know how many discs you're gonna get. All right? So the number of discs comes equal to 1 million divided by 2,700. What I work out?
370.4.
370.
Yeah, 5.
Point something.
Yes, sir.
7 or 0.4.
0.37, but I can just round it up to 4.
Yeah, whatever. Yeah, 0.3, point whatever, whatever it is. So it means that you're not gonna get an additional disc. So the total number of discs, or maximum number of discs you can get is 370. Now I have a little bit of material left that could have made another piece, but the maximum number of completed discs is gonna make is 370. You're gonna write i.e. maximum 370 completed discs that you can get. This is the answer. Not 370.4. Huh? No, think of it realistically, no man. The calculation tell you that the amount of material that you have will make 330.4 discs. The 0.4 means a part of this. The question asks what is the maximum number of discs that you can make. The 0.4 is not a completed disc. The maximum number of discs that you can completely make is 370. So that is the answer. Whenever I do a question, I say, guys, the question asks for a number of something. Just always consider that there must be a whole number. A number of something is a counting number of something. So the answer really is supposed to be a counting number. How many discs can you make? It's 370. The 0.4 is not a disc. How many discs? There's no 0.4 of a disc. You get me? So you're not gonna say you're gonna make 370 points. I ask for the number of something, the maximum number. The number of something is a natural number, a counting number, or a whole number. So you can't put 30.4. There's no point for this. And you can't carry it up to 31 either. Okay, you don't have enough to make fully. You can't carry it up to 371 either. You don't have enough to reach 271. So the maximum you're gonna get is 270. Then you have a little bit of material left over. Well, understand? So the answer is 270 this. That's what it asks for. Maximum is 370. And you can get a little hint, by them putting this word in bold letters. That's a little hint. Anytime you put something in bold letter like that, they're drawing your attention to something. Don't just ignore it. They're drawing your attention to something. Right? So look for a meaning in it. All right. That finishes this question. Which question next? Let us say they don't want this part. What's the next measurement question you all want? Which year? Which paper? Anybody? Huh? No already spot? All right, no problem. No one more than 5 minutes to read that. 2 minutes to read that part here. Let's put up the clock. This 1 mark and 2 marks. A 3 marks question. This is no more than 3 minutes. Let me give you a 4. Let me give you a 4 to do it. Oh. I give you 4 minutes to do this one. 4 minutes. Start doing now. You don't need so much filling now. Very easy question. Find a question that you want me to do next, please. Find the next question that you want me to do, please. Find it. I'm not selecting questions for today. You are selecting measurements questions for the past papers. And I'll give you a couple minutes to do it and then I'll do it. January 2010. Hey, follow instructions, I said between from 2016 upwards, because the older papers I'm not able to write on the exam paper itself. I can't bother with that. I want the paper that you can write on the paper itself. So I said start from January 2016. 2016, that's what we're working from. 2016 up to now. For the instruction that
January 2024.
all right. When I finish, don't have a question here. Ratio, ratio is the easiest thing ever in life. Ratio. But all they do with ratio is multiply and divide by values to get what they want. Now, for nothing else with ratio questions. But them say which paper them say January 2024 next? All right, January 2020. Bring it up over here in the meantime. All right, let's do this question quickly. Question says, a globe is a scaled spherical representation of the Earth. The actual length of the equator is 40,000 kilometers and is represented on a globe by a piece of string, 160 centimeters. That's a ratio. It means that 160 centimeters on the globe is actually 40,000 kilometers on Earth. It's a ratio. So any dimension you want, you can work down from that ratio. So they're basically giving us a scale, which is this. 160 centimeters on the globe is equivalent to 40,000 kilometers on the Earth. This is on the globe, this is on the Earth. And from that, you can find any dimension you want. You can find any length on the globe and see what it is on the Earth, and you can find any length on the Earth and see what it is on the globe. Let's see what it says. It says, what length of string? So we need to find something over here that represents an actual distance of 500 kilometers. You want this side to become 500 kilometers so you can see what is over this side. Simple as that. So the question is, what do I divide this by? What do I divide this by for it to become 500? 80. You don't know, you can do on a calculator. By doing 40,000 divided by 500 to see what I have to divide this by, and that is 80. So if I divide this ratio by 80 right now, this side become 500 that I want it to be. So I'm going to divide through by 80. I divide through by 80, I divide both sides by 80. Divide this side by 80, it becomes 500 kilometers that I want to see. Divide this side by the same 80, it becomes 2 centimeters. It means then that 500 kilometers on the Earth is represented by a 2 centimeter string. So that is the answer. 2 centimeter is the answer. You want a 2 centimeter string is the answer. That is it. But with that, it will be like a ratio. Then this part now says the distance between P and Q, I don't care about the actual names, is represented on a globe by a string of 25 centimeters. What is the value of PQ, the actual distance in kilometers? It's the same thing. Now I want this side to become 25, so I can start by the same pace. I can start back right here, so no matter, I can start back there too. But I'm going to start back with this same way. I still have 160 centimeters equivalent to 40,000 kilometers. I want this side to become 25. What do I divide by for it to become 25? If you don't know, I can just calculate it first. 160 divided by 25. Tell me what I need to divide. 6.4. All right. Or you can break it down step by step and then build it up back to 25. You can do it as well. All right. Any way you want. All right. So I'm going to divide it by 6.4. That's what you say, right? Let me just make sure. So I'm going 160 divided by 25. That is 6.4. So I'm going to divide 2 by 6.4. Because I want this side to become 25 centimeters. So I divide this side by 6.4 as well. As simple as that. So when I divide by 6.4, I get this side to become 25 centimeters equivalent to, divide this also by 6.4. 40,000 divided by 6.4 equals, and I get 6250 kilometers. So 6250 kilometers is the answer for this question. Right here. 25 centimeters on the globe is 625 kilometers between these two places. That's the answer. Very good at that. Nice and easy. All right. Next question is 2024 January. We did this question last week, but no problem. More math equals better math. More math equals better math every time. Measurements. January 2024. I'm not seeing it. 2024 January. I'm looking at May. Let me get it this way. Let me get it this other way. All right, bye. Make sure you join online and watch the video. All right. So now you guys are going to do this number 6 for me. 10 minutes. Number 6, part A you're doing, right? Just part A I want, right? Just part A you want.
Yes.
Elizabeth. All right, cool. Yes, sir. All right, there you go. All right, see, let me make this a bigger. But that is it, guys. Hope you can see. Pi is 22 over 7. Let me come up here. Pi is 22 over 7. That is the question. 2 parts. Hope it's a different question. All right. That is it. I'll put up the clock. 10 minutes. You need 10 minutes for that, though, you know. You need about 7 minutes for that. Let me give you a 7. Remember that question is a 15 minutes question. And that's half of the question. Final question you all want me to do after this one, please? This one we're finishing a jiffy. Find the measurement question we're doing next. Can everybody from now clean up your mess before you leave? Please do not leave the room with all the mess. All the papers and the chair around you, bottles, food containers. Can never carry them outside, put them in the garbage for me, please. Do not walk this then. The room is messy and not keeping in the class in here tomorrow. Telling you. Walk with the garbage, please. Guys, over this room and class. What wants to be, probably and discuss it next. All right, ready? This question says, right, use pi as 22/7. They needing some circular measures. Diagram below shows a hemispherical bowl. That's half of a sphere. That's half of a sphere. Hemisphere, half of a sphere. And a cylindrical tin. That's a cylindrical tin. It said the diameter of the cylindrical tin is 12 centimeters. This is 12 centimeter diameter. We tend to work in radius. So I'm gonna write the radius. I'm gonna write a capital R for this one. The radius of this thing right here, I'm gonna put that 6 centimeters. So the small r is for the bowl, the big R is for the cylinder. That's how we're gonna work it, all right? The radius, we tend to work with radius. It says the height of the cylinder is 17. See there, 17 is the height of the cylinder. And the radius of the bowl is R up here. We don't know the R yet, right? We don't know the R. It says, show that the volume of the cylindrical tin is this. Correct to 4 significant figures. So we need to calculate the volume of this thing. Volume of a cylinder is area of the base, which is pi r squared times the height, pi r squared h. So the volume of the cylinder, let's put C for cylinder, is pi capital R squared, because we're using capital R for the radius of this one, times the height, which is 17. The pi here is 22 over 7. Let's put those values in. This becomes 22 over 7 times this radius squared, which is 6 squared, times the height of 17. Put that in the calculator. I'm sure you're going to get this value. 1923 cm cubed. If you put this in the calculator. What go to that? You want to see go in the calculator though? All right, we put it in the calculator.
Sir, it's gonna give 1923.42.
Right, but I said correct is 4 significant figures. Right?
Yes.
So the 4 significant figure will give you that answer that the one. All right, let me not bother waste time with the calculator. The calculator will give you that figure, right? That is that. That's the volume of the cylinder. All right, next part says, the bowl is completely filled with soup. Remember, as a hemispherical bowl, half of a sphere, completely filled with soup. When all the soup is poured into the cylindrical tin, 90% of the volume of the tin is filled. What that means is that the volume of the hemispherical bowl, the volume of the bowl, that's what this means, you know. All the bowl, volume of the bowl is 90% of the volume of the cylinder. That's what it means. The volume of the bowl, because when you pull the bowl and pour it into the cylinder, you want to fill in 90% of the cylinder. So the volume of the bowl is 90% of the volume of the cylinder. That's what you have to use, 90%. It says, calculate the radius of the bowl. And they're helping us here. They said the volume of a sphere is 4 over 3 pi r cubed. That's a full sphere has this volume. But what we have is a hemisphere. We have half of a sphere. So the volume of the hemisphere that we have is half of this. That's the bowl. As a hemisphere we have. So see, you know, we're using this relationship. So the volume of the bowl will be half of this, because it's half of a sphere. That's this part of it. That will be 2 over 3 pi r cubed. This represents the volume of the bowl. That is equal to 90% of the volume of the cylinder, which is volume of this. 90% of 1923. That's what you're working on. And we can see what this is if we work it out here. At the end of the day, we're trying to find this R, this radius from this calculation. That's what we're trying to find. All right, so we're doing the 90%, 0.9. You don't have to work it out soon, but we can. So 0.9 times
173.7.
and we're getting an exact value. Put the exact value so don't run off anything. So 1730.7. Leave it exact like that. All right. And we're transposing to find this R right now. That's what we're doing. Transposing to find that R. So we're transposing everything away from this R. So let's look at it. When I take this strand here, that is, I can simplify this first and make it to one thing, you know, by putting this as 22 over 7 right here. Let's do it that way. This becomes 2 over 3 times 22 over 7 r cubed is now equal to this figure. 1730.7. Notice don't give a lot of space to work with. 6, you don't expect it to be doing a lot of lines of work. This year work out to be what? 44. This year is 21. Watch this now. I want to take this 21 and multiply it up here, so. Take this 44 and divide it on the year. So I'm going to get R cubed equals 1730.7 times this 21 that I multiply up here. Times 21, I'm transposing. Divided by this 44. 2 times 22 is 44 divided on a year. This is not R squared, it is R cubed. Am I correct that quickly? And then if you want to find the R, we're gonna have to cube root both sides. We'll have to cube root this side to get rid of this cube, and also cube root that side to get the final answer. All right, so we're gonna get R equals whatever this calculation is, because this cube root cancels away this cube. So leave me just the R alone. And this calculation now will give you that radius that they want. Let's do the calculator. What again? All right, let me see now. So we're doing the cube root, not cube, cube root of a fraction 1730.7 times 21 over 44. 9.38. Three significant figures is 9.38 centimeters is the radius of the board. That's it. Next question. Somebody said I want this question as well. I'm giving you 3 minutes to do this. I don't need more than 3 minutes. Huh? The work is done. That's it. All right. Somebody wants this part of it as well. They want this part.
Sure.
Huh?
Yeah, go back up real quick, please.
That's it.
Down to question 2. Yeah, that's it. Well.
What you say?
Yeah, man, say good now.
You good? All right. This question I'm giving you 3 minutes to do this. The question says, this diagram LM and N on the circumference of a semicircle, means half of a circle, that's half of a circle, with a center O, and the radius is 18. The radius is 18. Remember, any line from the center is a radius. So this is 18, this is 18, this is 18. Any line from the center to the circumference is a radius. All of those are 18. Calculate the area shaded. Calculate the area shaded. Come on. You don't need no more than 3 minutes for this one. I'll give you a 4. Huh? That's a easy 5 marks. What's marks it, buddy? The 6 and I give 5 marks, you know. I go about a 4. Come on, this one quickly and come. Quickly. The area shaded. Compound shape. They're doing this in prep school. Like doing compound shape in prep school. They're asking students in prep school to find it. It's serious. And in first form. Honestly. Passing them into area shaded and a compound shape. Those are standard shapes, you know. Semicircle and triangles. Standard shapes those. It's not complicated. Come on. Find the area shaded. Triangle is inside the semicircle and I want the area shaded. Then 2025. All right. We'll bring it up right now. All right, go on, work it first. 3 minutes. Please, do not leave them on the floor. Garbage bin is right over the corner. Pick them up from the please. Leave it. Time. Come on, I do it now. Nothing. Wait till I leave. When I leave it, when I leave for another hour, you know. That's all eager to leave. Whee. You're all very eager to leave here. Huh? All right, come. Question time. Let's go. This question, let's go. That tells us that the radius is 18 centimeters. Very important that you know that the radius is any line from the center to the circumference. All right? But this side is 18, right here. This is also a radius 18. And this, which is the perpendicular height of that triangle, is also 8. And that's also a radius. So you have enough information to find out that triangle. So the area shaded is clearly the area of the whole semicircle minus the area of the triangle inside here. That's all that it is. The area of the semicircle minus the area of the triangle. Semicircle is half of a circle. You see it here? Area shaded is area of semicircle, half of a circle. Something nice over there. Minus area of that triangle inside it. That's all, the compound shape. So the semicircle and subtract the triangle from it. What's the area of the semicircle? Half of pi r squared. Half of pi r squared. Minus, what's the area of that triangle? Half base times height. As a right angle triangle. Half, the base is 36. 18 plus 18 is 36. Times the height is 18. This radius is also 18. And the pi is 22/7. Let's put 22. All right. So it becomes half. This pi is 22/7. This radius is 18, so it's 18 squared. Minus half 36 times 18. Put all of that in the calculator and get your answer in centimeters squared. You don't need to waste time and work it out piece by piece. 185? 185 centimeters squared. That's it. The next question somebody wanted to do was the January 2025 paper. Let's see if we can bring it up. January 2025. Huh?
Sir, can we say 185.1?
Yes, sir, that may have to.
Say that again, what's the question? Yeah, Mike.
No, sir, I was saying if we can say 185.14.
Yes, that's okay. That's fine. But remember, I know 3 significant figures we tend to work with. All right, January 2025. Where are you? 2025. Somewhere here. I'm going to another way. It here, so. Oh, this is one that we did the other day. Let me see. Yeah, this is one that we did the other day. So let me bring it up another way. Let me bring it up another way. Come on, have it over here, sir. I don't think I have it over here, sir. I don't think I have it over here. This is my downloads. There you go. All right, so it's the number 7 or 6. 6. There you go. Bring up another one. That's a 2-page question. All right. All right, so this is the first page, guys. Right here. This is the first page right here. All right. And it gives that information. Pi is 22/7 as usual. And it says a piece of wire, 61 centimeters long, bent to form a sector. And it says the radius of the sector is 18 centimeters. Show that X. The angle there is X. The angle inside there is X. And I want to show that X is equal to 80 degrees. All right, and having done that, they want to calculate the area enclosed by the wire. That's the first part. I'm giving you 10 minutes to do this question. Don't need more than 10. 10 total for the 2 parts. That's part A. Part B is a different question. So this is part B on the next side of the screen. Right here. That is it. It says a cylindrical block of cheese has a radius of 12 centimeters and a height of 8 centimeters. The cheese is divided into equal slices. Uniform cross-section of a slice of the cheese is a sector whose angle is 18 degrees as shown in the diagram below. Calculate the length of the arc AD Determine the area of the curved surface ABCD. Then given that the area of OAB is 22.6 centimeters squared, calculate the volume of the entire block of cheese. Let me give you 10 minutes to that. Five minutes on each part, 10 minutes. Start. 5 minutes on each part, 5 minutes on A and 5 minutes on B. Come on. 10 minutes to that question. 4 and 6, come on. Easy. It's a 8 minutes. It's a 8 centimeters. All right. Zoom in over here. Zoom over there. garbage with your place, the road plate, or the paper and stuff inside the road plate. When you have a bottom plate, something in the garbage outside. Or in the garbage, plate that. Told you, he's not looking at you aqui. Class aqui. And I told him to use the bathroom for me, something. What time? 11 seconds ago. That's a bad man. Ready? Let's do this. First part over here. A piece of wire 61 centimeters long is bent to form a sector. It means that the perimeter of this sector is 61 centimeters. All right. So the perimeter is this piece, which is 18, plus this piece, which is 18, plus the arc length. But the arc length is, the rectangle is x. Is a fraction of a circumference. It becomes x over 360 times 2 pi times the same radius of 18. That's what this curved piece up here is, this piece. So it's the 18 over here as well. This plus this equals 61. That's how we're gonna get the x. Total perimeter of that thing is 61, because that's the length of the wire that was used. All right, so we can set it up. The perimeter is 61. See there, the perimeter is 61 centimeters. And the perimeter, as I said, is 18 plus the arc length. And arc length is this. 30 over 360 times 2 pi r. So we equating that to 61. And work for the x. So it becomes 18, which is this length. All right, good. 18 plus this piece, which is x over 360 times 2. The pi is 22 over 7 right here, times 22 over 7 times this 18 right here. That's all equal to the 61 centimeter length of string. So transposing everything away to leave x as the subject. So this right now is what? 36. So I subtract the 36 over here first and consolidate the values on this to simplify it. Let's simplify. 18 into this goes 1 time. 18 into this goes 20. But go to that. Yeah? I'm going step by step, simplifying it down. Ready again. 18 into this goes 1 time. 18 into this is 20. And then 2 into this goes 1. 2 into this goes 10. Then 2 into this goes 5. And 2 into this goes 11. And so all of that reduces to this 36. We're going to come and subtract from over there. And this whole expression is going to become 11x over 5 times 7 is 35. That's all equal to 61 minus, this is 36. 18 and 18 is 36. 61 minus 36 is how much? 60, you don't give a lot of space to work with. Small amount of space.
Sure, 25.
25.
This is 25. So to find the x now, you can multiply the 25 and divide under the 11. Don't put it right here. So the x becomes equal to 25 times 35 over 11. And that's supposed to be 80 when you work it out. That work out to 80?
Yes, sir.
Beautiful. So that is 80. That's the work you have to do. Just at 6, you don't give a lot of space to work with. Huh? Which part? This last part is up? Then what do you use for pi? Huh? Let me see what the calculation. Hold on. 25 times 35 divided by 11. Yeah, you get 79 point something. Yeah, because that's approximately 80. See, they're approximately 80. That's 80. Yeah, where's the now, Jordan? Which part? Don't understand? Huh? You understand how we get this and this? Mr. Transpose. The more I leave x alone as a subject. So we take the 35 and multiply it up here, so. And take the 11 and divide it under. Just cross multiply and divide. Right? So the 35 multiply up here to give me this. And then this 11 is divided under here. This works out to be 79.5 is approximately 8. Next part now wants the area enclosed by the wire. So it's an area of a sector, which is 360 times pi r squared. So that area is theta, which is 80. 80 over 360 times pi r squared. The pi is 22 over 7, and the r is 18 squared, pi r squared. Let me write it in red already. So right here, we use theta over 360 times pi r squared. That's what I have right here. What I work out to? 226.
226.28.
226.283.
So 226 is good enough. 3 significant figures. Centimeters squared. That one. Hold on. All right. Next part. Huh? Huh? You put in all the number and get 225 exact. It don't really matter, not a big difference. It's okay. 80 divided by 360.
I apologize if you are I'm not saying I don't see any done what I'm going to do. What I'm going to do. Before like
Let's do make so much nice on the class. You might be somebody. Our next question over here. This question says that cylindrical block of cheese. So the block of cheese is like this. Cylindrical block of cheese like this. As a radius of 12 centimeters and a height of 8 centimeters. So the radius is 12 and a height of 8. That's the block of cheese. All right. You say the cheese is divided equally into slices. Take the cheese and slice it up like so. Slice it up like that. And after the finish slicing it up, it says the uniform cross-section of a slice of a cheese, where the angle is 18 degrees in here, is shown in the diagram. So the 360 degrees around the center of the cheese is now divided up into 18 degree sectors. So to know how many slices they got, you just need to divide the 360 by 18 to know how many slices they got. So let's work that out from now, because I might need it. Right? So the number of slices is 360 divided by 18. Number of slices is 360 degrees total divided by 18 degrees. That equals to 20, don't it? 20 slices of cheese. So that information might become relevant. Question says, calculate the length of the arc AB, that's this piece right here. So working in this sector, where the sector angle is 18 degrees and the radius is 12. Length of arc formula. Theta over 360 times 2 pi r. So arc AB is 18 over 360. That's theta over 360 times 2 pi r. 2 times pi is 22 over 7. Times the radius is 12. What did we use here? Let me write it out. We use theta over 360 times the circumference of 2 pi r. That's what we use in this calculation here. I'm going to work out what this is easily, the calculator, and put it here. Let's put all that in the calculator. What did I get? Anybody did it? 3.77. 3 significant figures good. So that's 3.77 centimeters. That's the length of this arc right here. And the question says, determine the area of a curved face. ABCD, that's this curved face right here. The one this area here, so. That's easy because this piece right here, so, is this 3.77. And this piece right here is 8. So that you have a rectangle. If you flatten it out, it's going to be a rectangle. So that area becomes 3.77, the arc length of here, and the length, which is 8. And how much? 30.1. Could have put 30.2, but it's all right. Centimeters squared. Next part now says, given that the area of OAB, that's the top area right here, so. That is the cross-sectional area of this block of cheese. And the distance between the two end areas.
Excuse me, sir.
Yes?
Sir, can you go over that question again, please?
Which part?
Sir, the curved area, the curved face one.
This one?
Yes, sir.
That's just the area of this flat piece right here, so. The area of this piece right here, so. We know this length up here, I know this length up here. If you flatten it out, it becomes a rectangle. If you flatten it out, it becomes a rectangle. This part up here, so, is 3.77. And this piece down here, so, is 8. So it's formed out like a rectangle. A, B, C, D. Length times width. Understand that?
Yes, sir.
That's all get the area. All right. Good. All right, they're telling us now that the area of this face up here, this end, they're telling us that it is 22.6. I guess if you work out, it would be the same thing. They wanted to calculate the volume of the entire block of cheese. So to calculate the volume of the entire block of cheese, we can calculate the area of one slice, calculate the volume of one slice, and then multiply it by this 20, because there was 20 slices that we had. What's the area, what's the volume of an object in uniform cross-section? It's a cross-sectional area that they just gave us. Multiply by the distance there. Cross-sectional area times the distance between the two and give you the volume of the that slice. I wonder if we could have calculated from this though. So calculate from this to, the entire block of cheese, because we know we do the radius is 12 and the height. So could I calculate using that to pi r squared h? Pi r squared. Let's try. Let's work from this. Must work. So let's calculate the volume of the entire block of cheese. Right? But they gave us this area because they want us to use it, I guess. So the volume of the block of cheese will be 20 slices times the volume of each slice. So let's work it two ways. The volume of the block will be equal to 20 times the volume of a slice. 20 slices times the volume of a slice. The volume of a slice is a cross-sectional area, which is 22.6, times the height, the length, which is 8. Remember, volume of an object with uniform cross-section is volume of an object with uniform cross-section is the cross-sectional area times the length. The length is just the distance between the two ends. The A is the area of each end. Think of this as an object with uniform cross-section. This is an end, and the other end is under here. Those are the two end areas. And then this is the distance between the two ends. So this becomes the L in the formula. So the volume is the end area times the length. And the area is the area of this face times the length gives you the volume. All right, that's what it is. That's what we're working it out. So this then becomes this calculation with 20 slices, and this is the volume of one slice. What I work out to?
3,616
centimeters cube. Let's work the block, the entire block and see. The volume of this cylinder. It will be pi r squared h, don't it? Must give you the same answer. This work out to that? 3,616, That's all I got. And I'm working it out now. Another way to get the volume of the block with the volume of the cylinder, that cylindrical block, which will be pi r squared h on the block of cheese. That will be 22/7 times radius of 12 squared times the height of the cheese is 8. Where that all from and tell me again. Must get the same thing. If it is correct. So 620, and that is because we did some correcting down for this 22.6. That's what that. There's some correcting down that is taking place with this 22.6. We're still getting the same thing basically, 3,621 centimeters cubed. The only reason why, because if we calculate the area of the face, we're not going to get this number. It's not the exact value, that's a corrected number. If you calculate the area of this face, we set ourselves. Let's work it out over here. That end area will be 18/360 times pi r squared. Pi is 22/7. The r is 12. If you work that out, you're going to see that you're not getting exactly 22.6. It's a corrected figure. It's 18/360 times 18/360 times 22/7 times 12 squared. Calculator has given me 22.628 something, but I corrected it to this. By correcting it to that, you basically reduce the value of the calculation down here a little bit. That's why I get a little bit less. So I think if you did it either way, they'd have to give you a marks. This is a more accurate answer for the volume of the block, this one. But this is if we use the information that they gave us for one slice. But that is it. And that is it. That is it. That is it. What time is it now? 8:40. We have time for one more question. Anybody have another question? Any other question? Bam, 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 bam. Any other question? Or like you don't want to do anymore, you all bust up. today. Remember, carry some garbage with you, please. Don't leave them in the room. Bottles and papers, don't leave them in the room, please. All right? I tell you in the group, I'm having a session tomorrow. I'm not sure yet. I'm really not feeling it. Serious. So I let you know if I'm having it tomorrow. Huh? Keep it. Yeah, but people coming here are not serious. All right, guys, we're gonna end it now. Bye, everybody. Tomorrow again. 9 to 9. Tomorrow. I'm gonna end it now. Bye, everybody.